And when we started, people said, this is just a mess. It doesn't work, because this is what they saw. But that's because some teams didn't use their own names for the producers, so they had just used producer 1, producer 2, and then Confluent was not able to distinguish between those different producer names, so they just merged all of them together. But if you have a separate name, then it will look like this, and it's a good way to be able to see who are using your data, for example. And we can also search for data. So here I search for add, and then I get some schemas and tags and some topics with that in it. But have we had any hurdles? Yes. I talked to some people in the organization, and they said, well, this work is maybe 30% technical challenge and 70% organizational challenge, because it's a shift going from a central data team where they know everything and go to where the teams are the domain experts, and they should create their own data products. So getting the teams to have this responsibility is quite a shift, and it's not that easy. But I think we're on the right track, and I think we'll get there. So if you want to start working on data mesh, I would suggest you to start on the domain ownership if you don't have it already. If you don't have domain teams, that's where you should start. And then you can add metadata to what is out there in the data. So you add owners, you add descriptions, and then you can add more and more, and then it should be easier to create data products afterwards. And you need some governance to see who can access these data, who can access what, and who should be able to do what. And then you can start creating data products, so having some teams. So start small with 1 or 2 teams creating their data products, and then go from there. And then you can show this in a data catalog. But take one step at a time. So we started with a chef that thought grocery bag was fine dining, and we ended up with a masterpiece where everything is self-served buffet. And the secret is knowing how to prepare, how to organize, and how to serve exactly what is needed for the rest of the organization. So just like data mesh. So imagine now going back to your team saying, hey, we're not in the grocery bag business anymore. We're here to serve up some 5-star in a buffet. So now it's your turn to go back and turn raw messy data into something that everyone wants to dig into. So let's swap those grocery bags with some gourmet meals and start serving up some 5-star data-driven success. Thank you.
Thank you, Lotte. Yeah, no time for questions. There's a few empty seats there and over there. Please use them. You don't have to stand in the hallway while we have the next speaker coming up. Ólafur.
Hello, sir.
Hello. Just plug it in and then pray it works.
I can play.
But you got to run Doom on satellite. I mean, that's nothing.
This is a little smaller, right?
Yeah, okay.
Hello, hello?
Yeah.
I don't know what's going on with the screen now.
So this is the
It's way too small.
view, and then you can switch.
There we go. Right? Ready? Yeah? I have 130 slides. Can everybody read? Yeah. Please steal this idea. It takes 2 minutes to make. Okay, cool. Oh, echo. No? There we go. Okay. Hi, my name is Ólafur Waage. I'm a senior software developer. I work at Factlines in Norway, here in Norway. And this is my handle on most places, and you can come yell at me on the internet. That is a feature of the internet. So, the place where you live right now, it's pretty good, right? There are probably things you would like to fix and things you would probably do completely differently, but this is your place right now, right? And probably things that you love and you wouldn't trade for the world. But then you get the news. You have to move. Oh, stressful, right? Yeah. The move is going to take a lot of work, and there are a lot of unknowns as well. It's also going to take you a lot of time and money to move. But you hope that in the end, it's going to be worth it, right? Yeah. So system migrations are in a way like moving to a new place. The new system is better, right? We're hosting in a new, better place. Oh, it's written in this cool new language. Oh, everybody loves that one. And all of the 2020 hindsights are accounted for. Yes. All the design fixes a lot of the older design issues, and it totally has any new unforeseen consequences. Yeah, we can ignore that. So migration isn't a very exciting topic. But when you're tasked with doing it, it is really tricky. And you hope that the internet, the place we are now, right, is full of great tips and tricks to guide you along. So here I am contributing to that ecosystem, and here are the things that I have learned from doing system migrations. There are many types of migrations as well. And if you go on Google and you search for migration, one thing that you might pop up is the 7 R's of modernization. Relocate, rehost, re-platform, refactor, re-architect, rebuild, and repurpose. Yes, they really wanted to force the R's on that one. So this list is a good resource. Please use it. But it also a lot of it revolves around what you can do on the cloud end, like switching cloud providers or moving to a new system. That's okay. This talk is mostly on the rebuild and re-architect. So we're going to do a whole new thing. We're not going to just take the thing and just pop it over in another place. So this will also be about moving or doing the migration all at once, which is also pretty tricky. Some migration strategies revolve around having both systems alive at the same time. Like, also there's another one where you rebuild a small part of the system in a kind of a ship of Theseus way, where you slowly replace one plank at a time while the system is alive, while you're sailing the 7 seas. This will also not be that. This is a one swoop over. Good. So recently, I was working as a consultant for a company that was doing a new platform, brand new platform, file new. Oh, you love that one, right? File new? Yes, I love that too. So it's a whole new apartment, out with the old, in with the new. The company is a B2B company. It had a legacy system, and let's call that system S2. That's the old system. Good. It was standard B2B fare, users, companies, users access to the companies, and some data. Some data that you have to store in the system. The code in the new system, which is very ingeniously called S3, had nothing to do with the code of S2. Like we said, file new. Oh, I love that one. S2 was PHP and MySQL, which is fine. S3 was full stack TypeScript and Postgres. There was also an old school hosting provider involved somewhere. I'll show you that in a bit. And S3 would be hosted in the cloud. It's like we're doing like, what's the worst case of the worst case of the worst case, right? Not good. And like I mentioned in the movie analogy, they had learned what not to do when it came to the design of the new system, how the data should be structured, et cetera, which means that the data model in S3 did not match the data model in S2. There were vastly different pre- and post-conditions, and which basically meant you could not clone the database of S2 into the cloud for S3. It wasn't the same thing. There were also features in S2 that were not moving to S3, and there were features in S3 that did not exist in S2. I keep stacking on these worst-case scenarios, right? Now, because I'm stacking onto worst case scenarios, here's a fun twist. There's a reason why I call the systems S2 and S3. Who can guess? Maybe from the title of the talk. Because yes, S1 existed as well. S1 was still in active use. S1 contained important data with important customers. And yes, S1's data model did not match S2 or S3's data model. Because obviously, the people that designed S2 learned from the design of S1, right? So this was one of the core reasons why we decided to not do the double writes and not move the system slowly over, because we would have had to do it twice. So instead of having 3 platforms, 3 databases, 2 hosting services, and having 2 double write migration systems live at the same time, we decided to migrate both S1 and S2 into S3 all at once on the same day. Ready? Who has the computer? So spoilers, we did. It's about a year ago. It went really well as a migration can go, but it went really well. And so this talk, after all the preamble, here are the tips that I'm going to give you, so that hopefully that you also will have an excellent migration. Ready? Yes. Of course, a big asterisk. I couldn't make it bigger, but I wanted it bigger. Like with any list of things, there are things that work for us. You know, all the preamble. You should totally pick and choose from my list and throw away the stuff that you don't like, right? Your migration is going to be its own unique thing. So use this as a resource, throw away stuff, adapt what you want. Cool. So, number 1, the actual migration, like when you do it, should be the most boring part of the entire process. It sounds obvious, but this needs to be the mantra when you are preparing for the migration. The point of doing all the hard work beforehand is to make the actual migration as mundane as possible. Okay. The next tips should help you achieve that. Write the migration as code in a strongly typed language. It's very tempting to write the migration as a collection of database queries. Please don't. Write it as code, and that code should be strongly typed to avoid any accidental apples to oranges comparisons, because you will have those. Model all of the data of both systems, or in our case, all 3 systems, as separate types, and write code to convert between them. This, again, might sound obvious to people, but this is something that needs to be said. A user in old system is not the same as a user in new system, even if the data is almost the same. So we have old system user with some data, and new system user, almost the same, something there, something not there, and your migration is a convert function. And that is your canonical way to go between old user and new user. This is the thing, again and again. The code itself isn't that interesting. There will be code in the slides. It is from the actual migration, but I changed a bunch of stuff because, you know, slides. Yes, this is Iceland. Woo. And yeah, if you want the pictures, the sources are in the corner. Split the migration into as many discrete steps as you possibly can. Think of the migration of users, for example, in the old system to new system, as its own isolated migration. Find the leaves in the design and split them into their own migration steps. Your entire migration system is then just those steps performed in the same order, again and again. Here's an example: user import, company import, license import, user company import, and then there's the function that do that. And within those functions, you can call them, and they are very isolated. They do the work by themselves. Don't run your migration multi-threaded. Please. There is an asterisk though. Migration in strong and well-defined sequential steps will cut down on so many edge cases. Yes, it might take a little bit more time, but remember, rule number 1, make it boring. Asterisk, if you're 100% sure, fine. But don't tell me, like I warned you, basically. This is the big one for us. Assert, throw, and crash on anything that might look out of the ordinary. This value should always be here. Cool, prove it, put an assert there. This array is never empty. Cool, prove it, put an assert there. Add hundreds of these. I think we had hundreds. If the migration did not trigger any of these, then, knock on wood, we should be okay, right? An example, the member should never be null. Then we can use the member. The call from that function should never be, should not be nully or falsy. It's just a collection of these again and again and again. It's again, very boring, very mundane, but this is important. Log as much as you can, like the pun? Okay. As much as you can into a separate file. Logging, not just to see what you did, but it's also a great way to get an overview of the data that you just created. Wait, there's a user type called editor, but there are no users with editor type. Well, that might change how you do and write the actual migration code. Comment like you've never commented before. There are going to be so many little edge cases, so many little nuances to think about, right? Oh, we can do this operation on every user except the ones before 2011 because there was a bug and they look a little different. That's a comment. Like, you had that meeting, that's a comment. So this is an example. I can't show you the code, but for those who have written TypeScript, the imports at the bottom there, this is a comment before one migration of just all of the preconditions, assumptions that we've been doing. This is really important, and we refer back to this again and again. Here's another file. We also do it. This is the scroll bar. I couldn't zoom out enough. We structured it. We made like little tables out of it, and very cute, right? So yeah, we were very analytical in doing all this. I love this one. Progress bars are surprisingly useful, right? It sounds like an unimportant thing, but it's one of the more useful things when we were doing the migration, because migrations take time, and they deal with a lot of data. So a visual indication that something is happening is very important. And if you change something which causes it to get stuck, you know immediately, because the progress bar is stuck. Again, very simple. Just import progress bar, we did it in command line, you can do in whatever you want. Yep. Perform test migrations while you're doing the migrations. So the code you're writing is supposed to convert old data into the new system. So do that and reset if it worked. Are you done writing the user migration? Cool, run it. Are you done with the company migration? Cool, run the user migration followed by the company migration. Yeah. And do these migration in as real of an environment as possible, because latency matters. If you do it locally, cool, it's really fast. But they run it against AWS, and whoa, it takes half an hour. Like, yeah, okay. This is a very sad but true one. You're almost certainly going to have to read and or run some of that code again. Yes. So be nice to your future self. Be thankful for all those asserts and all those beautiful comments and those well-named functions and classes, right? We all do that? Yes, of course we do. Because there's going to be that one customer where you got it wrong. So you're going to have to rerun some of those migrations. So again, also thank yourselves for having the migrations as isolated steps, because this again helps you with that. Store unique IDs from the old system in the new system. Don't use them for anything, just have them there. So ID name, email, legacy ID, right? Because you're going to get a call from support. Why does the data look like that? It wasn't like that in the old system. And you're going to thank yourself for keeping that old ID somewhere. This has come back again and again. So, and as simple as that. You have an S3 company ID name and an S1 ID, S2 ID, which might not be there, might be there. Yeah, it's as simple as that. It's okay to write custom code for that one weird case, or many weird cases. Because migration is never a clean process, and you're going to find a subset of data that just doesn't fit nicely with a normal migration. That's fine. Then treat that weird case as its own thing, because it is. So here's an example. This is actually from the migration. I rewritten some of the commenting, but there was unset data, I call it, in the thing. It was called something else, but it doesn't matter. But the data wasn't linked correctly, but then there was data that was linked correctly. So instead of migrating the thing by itself, it's migrated in two steps. One as the unset data, and one as the set data. There were two migrations. And we did them in this order. So yeah, this is very important. There are things that you don't migrate. This is also normal, right? Perhaps the old system allowed you to delete data and leave a foreign key broken. Yeah? Or the design of the feature in the new system needs data that just was never saved in the old system. So of course you don't have that data. You're going to have to make a decision on how to move forward, and you need to document why this data wasn't migrated. Or, this happened to us in a few cases, you might not have to migrate the data because the feature was only used by a customer, and that customer is no longer a customer. So this is also a thing you can detect. So again, just simple as this, doing checks. There was and this is actual code just rewritten a little bit. There was some stuff that was duplicate, then we just treated as the first ID. And because you have, like the old system isn't going to change when you do the migration, the ID should stay stable. That's a sentence, should stay stable. Yeah, some data we don't migrate, some data that we treat as another data. That's totally fine. Here's an actual function, again, rewritten a little bit. So this is actual user import. We have a progress bar. We get the S2 users, map them to S3 users. We start the progress bar. We start a transaction. For every user, we update or import. This is for S2 because we did S1 first, and then there are users in S2 that also exist in S1, so we update them accordingly, and that's it. I mean, it's not very exciting code, but it's going to be a lot of code, and you should make it boring. So, you all took that in, right? This is all now saved in your brain. So this was a lot, I guess, right? So, here are some fun stats. It was about 30,000 lines of code, okay? Not because it's interesting that it's 30,000 lines of code, it's the ratio that I want to show you. Because only about 1,000 of those lines had to do with S3. Because that was just CRUD, maybe not the D of CRUD, but it was create, read, update. We didn't do much deleting for the new one, right? Because the rest of the code was, how do I do this? How do I take this S1, S2 data and convert it? Or how do I deal with this weird edge case? That was about 14,000 lines of each for S1 and S2. So just to give you the ratio of the S3 code was very boring. The S2 and S1 code was, how do I take this data and do something with it and convert it over to the S3 code? Yep. So, more fun facts. It was written in TypeScript. And so the system is in TypeScript, and this was written in TypeScript, some of that code, the migration code, ended up being the basis for some of our testing setup. Because this was about dealing with the data and handling the data, so this was the basis for our test setup. Also, because this was split into isolated migrations, we could do the actual migration on the day in many steps. So we could have run it all at once, we didn't, which is fine. But because it was split down, we could do this in many steps. This was my favorite comment, because yeah, I was very likely tired. If it used to be associated with a feature but isn't anymore, then I don't migrate it because I never opt out of it. I never opt out of it. Do you opt out of it? No. Yeah. So don't code tired. So for those who have phones, wants to take a photo, you can do that right now. I'm probably okay on time. Yeah.
Very good.
Very good. Any thoughts, questions, angry rants?
We have a recording, so.
Where's that? Yeah?
Thank you.
Yeah? Oh, we can talk after. Yeah.
No time for questions.
No, that's fine.
But you hang around here, right?
Yes.
Yeah, cool. All right. Then, Elise. You can drop the mic on the table. There's a few seats on that side. If you just walk in to the left or to the right, you can find a place. Okay. Oh yeah, I should have turned that off. Can you say a few words, Elise? So we.
What?
Yeah.
Hello. Oh.
Just cancel that.
Yes. Hello. Hello, and welcome to my talk, 10 Reasons Your Application Isn't Accessible and What You Can Do About It. My name is Elise Kristiansen, and I'm a senior front-end developer in Aplia in Skien. I will just try to get my manuscript on this there. I lean heavily on my manuscript today. My pronouns are she, her, and for all of those who can't see me today, today I'm wearing a beige blazer and a white t-shirt and brown trousers and some kind of muddy white sneakers right now because it's raining outside. In my 7 years as a front-end developer, I've seen countless of websites being launched without being properly universally designed. And that is why I have made this talk with this kind of clickbaity title, and I'm sorry for that. Since this is just a short talk, I will not go hard in onto how to technically solve all these issues. I will just try to get you aware of them and give you a little nudge on how to solve them in a superficial manner. And I have to say that creating a website that meets all the requirements will also improve your SEO performance and make it easier for everyone to use. So it's good for business. I have to dive a little bit into this dry area of the law. And because the accessibility on web has been legally required for years to ensure that all websites and web apps are accessible for everyone. A website that isn't universally designed is just as bad as a building without a wheelchair ramp. The law is called Regulation on Universal Design of Information and Communication Technology. And this regulation was established under the authority of the 2008 Anti-Discrimination and Accessibility Act, which aims to prevent discrimination based on disabilities. So many words. Now on to something more fun. And you can scan this QR code if you want to read it on Lovdata, if you don't trust me. My cats. These are my cats, Luna and Venus. These cats will follow along with my presentation to give those who are kind of like me, who struggle a little bit with concentration, something to focus on during my presentation. Because studies show that including pictures of cats can help you maintain focus for a little bit longer. So the cat pictures are rarely relevant to the content of my slides, but who doesn't love a good cat picture? This is the list. It's very long, so we should just start. I will begin with some of the more technical issues, and then move along to some more structural issues afterward. And you can take a picture of it, or I will, on every slide, I will have this little short link that you can go into and read my whole presentation as a blog post. So I had just published my whole manuscript. Issue number 1, insufficient alternative text for images and graphics. And there you have this short URL down there. A person with blindness or deafness needs to be able to get the same information as everyone else. To detect some of these issues, you can use a scanner. My favorite scanner is Pally. Pally is an open source accessibility testing tool that helps developers and designers identify and fix accessibility issues on websites and web applications. And yeah, that's my favorite tool, but there are so many other accessibility scanners you can use out there. A scanner will be able to tell you if an image or video lack any text alternative at all. But, however, a scanner might not be able to recognize if the alternative text provides enough context for the image. I will give you an example. An image of a cat that is trying to catch a bird might have the descriptive text, a cat and a bird, but that doesn't say anything about what this image is trying to tell in a context. For an article about birds that are going extinct, the image text might be bird being hunted by a cat. But for an article about a cat's behavior, the image text might be cat hunting a bird for fun. It tells you something that are relevant to the article it's in. So make sure all multimedia elements and images not only have a text alternative, but that the text also gives away all the relevant information for the context the multimedia is in. Issue number 2. Failure to use available text alternatives for multimedia elements, such as videos and audio files. The necessary types of text alternatives must be carefully considered. There are various kinds of text alternatives you can include. We have captions. Videos with sound must have captions so that people with hearing impairments can follow along. And we had transcriptions for audio files, and videos must have a text transcription. And the last of these alternatives is audio descriptions. Videos with important visual elements must include audio descriptions for visually impaired users. And again, you can use a scanner to help you catch a lot of the missing text alternatives. Issue number 3, missing and bad link text. I just had to take a little bit of water. A common mistake is missing or simply just bad link text. A web app or website is mostly full of links that are either taking you to a new page or taking you to another place on the same page. But we as developers have a tendency to put small icons or insufficient text like just read more as link text. And how is a visually impaired person supposed to know what more means without having any context? Use descriptive link text for all links. For example, read more about bees for an article about bees. And use ARIA labels for icons. For example, go to homepage wrapped around a house icon. A scanner will be able to catch a lot of the missing links, but will probably not be able to distinguish between a good and a bad link text. Issue number 4, inadequate contrast between text and background, which can make it difficult for visually impaired people to read your content, and solving this also makes it better for everyone to read your content. Again, you can get help from scanners, and you can also use your browser's inspect tool. The inspect tool in your browser is a very useful tool. Most browsers let you hover over an element and see the contrast ratio right then and there. You can see here that it's the little arrow when you open the console. Most browsers have a little arrow in the top left corner that you can use to hover over elements and see the tag, the color, the font, and also this bulk of accessibility information. And there we have a contrast. And on one side, it's a high number, and on the other side, it's a low number. And they even have a check mark and a warning symbol. And the higher the number, the better the contrast. So when you are developing something, just use your inspect tool as you go. So you don't have to use it on the whole page right before launch. Just make sure it's a part of the developing process. But remember, text on images and gradients is not that easily caught with just computer tools. Make sure you manually check all the colors in the background of an image up against the text color you have put on top of it. In this example, I have a good contrast ratio in black and a bad contrast ratio in light blue on a light blue background. And I'm not sure everyone even can see the text. So yeah. Issue number 5, lack of content structuring with proper use of headings and lists. For assistive technologies to work optimally, the web app needs to be written with the correct tags, especially the right use of heading tags. The different numbers are for semantic structure and not for styling, as so many people use them for. It's important to begin building the web app with the correct tags from the very beginning, because rewriting it will take time. My best tip here is that every time you want to use another div, just try to think about another tag to use. Use p tags for paragraphs, use nav tags for navigations. HTML is such a rich language if you actually deep dive into it. And if you are using the correct tags, it will solve so many accessibility issues. Issue number 6, missing keyboard navigation or incorrect focus order, hindering people who rely on a keyboard to navigate your page. One easy way to check your page itself is to use your own keyboard. That's the quickest and easiest way to check your page. Just tab through everything and make sure that all elements are logically ordered and accessible. A common mistake is to make clickable elements only reachable by mouse and only clickable by mouse click. So make sure you have used the right HTML tag, because they already takes care of a lot of the tab navigation issues. And you can use tab index in need. But if you have used the right HTML tag, you shouldn't need a tab index, but that's in need. And now we are moving on to some of the more structural issues. Issue number 7. Inadequate testing with accessibility tools and user testing on individuals with various disabilities. It's difficult to develop for challenges you don't have yourself. When you develop something, you tend to take your own experience as a starting point. And you assume that users of screen readers and assistive devices are experts themselves. But they are not. They use screen readers because they have to. David, a 75-year-old who just started to go blind but has never worked on a computer in his whole life, doesn't have any better prerequisites than you to know how to navigate a screen reader. You are the expert. And if you cannot use a screen reader on your web app, how is David supposed to do it? So set up good testing routines. Use the test on people with disabilities and make sure that make sure that testing with disability devices is part of the estimate. I'm sorry, I had to drink some water. My throat is a little bit sore. But estimations takes us right to our next issue, lack of accessibility awareness during the design and the development process. Developers tend to forget about accessibility when they estimate. And when the development has started, it's too late to incorporate it because one may feel there isn't enough time. Take responsibility and focus on accessibility already in the planning process. Make sure every participant knows how important this is. The customer, the designer, the developer, the editor who are going to publish content on the web app. Everyone needs to be on board. However, the fact that everyone wants to focus on it doesn't necessarily mean that everyone knows how to. And that takes us to issue number 9. Inadequate training and awareness among developers and designers about the importance of universal design and how to achieve it. I only have one bullet point here, and that is encourage developers and designers to take courses. There are plenty of easily accessible courses out there that can be done in just a few hours of the workday, and they are definitely worth the investment. And for our last issue, issue number 10, economics. People believe it's much more expensive than it is to develop for accessibility, so they fall into the trap of using accessibility overlays instead of coding the website universally from scratch. And that's a huge no. Don't do it. Design for simpler and cheaper websites. Keep the routines and guidelines in mind and scale down functionality and needs. Don't compromise on accessibility. A black and a white website in Times New Roman with all elements just listed one after the other without any design at all is way better than a website that isn't universally designed because it doesn't exclude anyone from using it. And that was all I had. It went a little bit faster than I should, but yeah, that's probably okay. You can add me on socials. This is my sources. And if you want to read the whole presentation as a blog post or article, you can scan this QR code. Thank you very much.
That was actually perfect because we're exactly at 10 now. We have a 15-minute break just outside upstairs. Please be back at 10:15 sharp so we can continue with the second set of speakers. See you in a few minutes. Yes, please move in. Yeah, please move to the center of the rows. Don't leave a space next to you empty, so we have enough, because I'm pretty sure now we will have the peak attendance. Everybody will be here. Every seat is needed. Please fill up the empty slots over here. Please move together. Thank you, to keep space for the others. There's a few seats over here on the outside, as well as there. Please close the gap. We need all spaces. Okay, then they are too late. Please close the gap. We don't have time. Thank you. That's a chance to meet new people. Same here. Please close the gap. Please move inside. Hey, can you move to the right and close the gaps? Thank you. There are 3-4 seats on the outside. Hello. Okay, say hello to your neighbor. And we are now gonna continue. Very good, thank you. All right, thanks for coming back. Second slot, we will have 4 speakers. So it's gonna be intense. And I'm very happy to have Anna with us now. Yeah, please welcome on stage. Okay, then let's try hardware. No worries. Can you say a few sentences to see if your mic works?
I think it is.
Okay. Let's try again.
I think.
Wait. 2, 3. Pray to the tech gods. What's this?
I don't have presentation button. Did work.
Oh, we have more USB-C.
I don't know why it doesn't work. Shit. What can I do now?
I don't know.
It did work a moment ago. This cable on it. But it did work. Just a moment.
Yeah, maybe there's it sounds like there's
Okay, now there is. Just a moment. Give me a second.
Yeah. Do you need to click it?
No.
Okay.
Okay. So hello, my name is Anna Wojciechowska. I'm a software engineer. All my life I worked with software in different companies. Since 7 years I live in Oslo. I work for a QT company. And recently, before around COVID, I decided to pick up a hobby, surfing, which you can do in Norway. And as a software engineer, I started to look at the forecast as a dashboard and thinking that the forecast is generated by some sort of the software model that is probably badly tuned, because each time I was showing up at the beach, the waves were not exactly there. So I was quite confused because it took me some time to arrive. And I was thinking, maybe, naively thinking, but naive motivation is a good motivation. I was thinking maybe I can improve this forecast. So I was thinking, what do I need to improve? Of course, I need to know how good are the waves that are showing up, and I can maybe compare it to the actual forecast and then know how much it's off and do something about this. So how would you measure the waves? It's a bit tricky task because if you look at this from like a sports perspective, you might think, just look at this, compare it to some surfer in the water, and you will know the height. The point is, like, the surfers are not always in the water, and if you just judge the height from the looking at the waves, you will not get the right measurements because they have some sort of fractal nature, so they are self-similar. But the problem of measuring waves, it's already sorted by science. You have all sorts of different measurements. So you have gyroscope-based wave buoys, you have laser measurements, you have ultrasound, then you have the satellites. And then there was just one problem with all those devices. They were just insanely expensive. This was just the amount of like, and I talk about when I started a few years ago, it was the amount of like hundreds of thousands of kroner. So basically it was not available for me. But I was not discouraged. I was highly motivated by the frustration. And and then I was searching, and somebody told me that there are things like pressure measurements, and there are pressure sensors that work underwater. And I only knew that they work underwater. That was enough for me. So what's the physical idea? You basically try to measure kind of hydrostatic pressure. It's not exactly only hydrostatic pressure, but the simplified formula is if you put a sensor at the bottom of your beach when you want to surf, and there is the wave going over the sensor, if you look at the projection, you will have some sort of water column that will change its height. So if you will have the highest point of the wave, the crest, you will have slightly higher water column than in the lowest point of the wave. And basically just measuring this height difference, you will have a pressure difference. And if you measure it or sample it often enough, then you will have some sort of time series of the pressure, and then you can recalculate it to actual height, and then you can keep on processing the data. You can run a Fourier transform on it and get the spectrum, and then you have all the data that you need to improve the forecast. So I soon discovered that there is the whole movement of open source hardware. So I only had the software engineer perspective. So basically, I figured out that this open source hardware is kind of similar to open source software movement. Basically, there are like equivalent of the software. It's of the source code. There are available open designs, schematics, and there are Gerber files. And basically, if you get them, you can create your own hardware. And I found a project done by a marine biologist from the San Diego University. And I decided, okay, I will just do it. The only problem was I didn't even know where to start. So I had like a classic education. I knew that semiconductors exist. I've seen some Maxwell equations, but that not necessarily helps you with building the stuff. But actually, I was like still obsessed with doing the sensor, and people started to help me, and somebody told me that there are the maker spaces, and that was the thing I actually need. It's because there were the places where you can join, you can meet people who have all the experience and they can answer all your questions, and they have all the gear that I didn't have, because when I started, I didn't even own a multimeter. So this is just a very simplified idea. On this side, you see the assembled device. It has a sandwich architecture. So there are 3 boards, and the reason why it's a sandwich architecture is because it's supposed to be put into the pipe and then put at the bottom of the sea. And this is very simplified hardware architecture. Most important part, you have your pressure sensor that is connected to commonly used microcontroller I used at Mega. And then all the data is stored in your memory card, and additionally you have your extra real-time clock because you need a time series data. So you need to have a timestamp on your data. So the starting was a bit complicated for me. Luckily, I had friends. So they explained me that there are things called bill of materials, which is basically a very long shopping list of all those elements. They were around 30. And then you place the order. So even placing an order was kind of challenge. And once when you have all the elements, and I started my project in COVID times, so there was a component crisis. But I managed to buy all the parts. Some of them I had to buy on eBay. And then what you do, so you order what is called a printed circuit board, which is basically all the cables printed on the board. And all you have to do, put kind of glue, which is like soldering paste. You work under microscope. And then you put all those components. And here are just all the components that are on the CPU board. So here you can see the actual Atmega and the real-time clock. And everything is quite small. It's like less than millimeters sometimes. And then you just put it to the oven. And I would joke that some people bake cookies, and I was baking the boards. And then you end up with a shiny new board. And basically the story should finish here, because I should just show you the data. But I had to also upload software. I connected it. I was using Arduino IDE, and then I had a problem because initialization failed. I should check the connection and so on. So basically, I had a design that I followed to the letter, and my device was not working. And I was like, how can I figure out what should I do to make it work? How can I test if the things are actually working? So of course you do the visual test, so you compare if you have the right elements, you double check all the connection, you do connectivity tests. And then because I had the software background, the idea was, can you debug hardware? And it turns out, to some degree, you can, because you can break down the whole project to actually mark all the wires, and you can compare it to another Atmega and just see the differences. Because I started to be suspicious about the actual MCU, and there are also this kind of devices. The socket, when you can put your Atmega, because it's very small, so it's really physically hard to connect the wires, and then you can connect all those wires and double check if things are working as they should. So what I figured out, I've discovered that the problem was with my Atmega, and as I said earlier, I bought my Atmega on eBay, and I knew that maybe you shouldn't do this, but there was like component crisis, and I thought like maybe if I diversify it and I buy from different users, then one of them would be legit. But also, like, if you diversify, there is like higher risk that you will buy the wrong one. So I just wanted to nail that most likely I bought the wrong one, because I asked my dentist to X-ray the Atmega. So she did a favor, and you can see that one of them is not exactly wired. So that was probably the reason why it didn't work. Anyway, I managed to make it working, and then there was the next step, because the sensor should work underwater, so you need to kind of waterproof it. So those are all elements that are part of the housing. And then when I was doing my housing, because it should work underwater and there is lots of pressure, then when you buy your pipes, you need to make sure that the pipes are certified, that they, I was buying them from the swimming pool shop. They were certified to 10 bars. So then I've discovered that the ocean is not exactly your friend, and electronics and salt water, which is very conductive, are not exactly friends. And also I've discovered the meaning of smoke tests, because occasionally my board would smoke. And And most of the hardware testing is actually destructive testing, so you have to buy plenty of boards, and if you do your project in Norway, each time you usually do your shopping in some abroad shops. You have to pay tolls, you have to pay shopping, you have to pay sending fees, so it really costs you and delays you with the project. So things that I've learned is that threaded connection is not a good idea. The best ones are the flange connection, and there is the whole flangeology. So basically, if you want to make it really waterproof, you have to think about the gasket, and the gasket should also be made of the rubber that would work in the marine environment. And even if you have the screws should be of possibly marine grade, and then the whole electronics, you can actually protect your electronics from water and saltwater exposure. There are different ways to do it. One of the ways is just put everything in the epoxy resin, but I still had like some connections and my SD card that I have to take out. So I was using the conformal coating. So one of the things I've even discovered, like if the device is working underwater, the rubber actually can conduct a little bit of salt moisture, and if it accumulates, it can impact your device. And also, one should remember that the device that is actually conducting electricity will corrode faster. So then the next step is, that's an actual sensor. And this sensor was designed for working in the freshwater, not exactly saltwater. So then you have to adapt it to the saltwater environment. So you do a trick. You create an oil bladder with the mineral oil, and the water is actually squeezing the actual oil back instead of your sensor, so it's protected. So there is another story how to make it solid and double check that is working as designed. And then the next things that I've learned is all the gluology, I would say. So you discover that all those glues has different viscosity, and even if you test them in like the bathroom environment and you believe it's watertight, and then you put it on some depth with water, it can turn out that there can be some air bubbles that can create the maze, and the water will go through this maze. So that's like another level of difficulty to make everything work. But I managed to make it work. This is another story, like the barnacles will grow. Once I even found a fish in the sensor, because like I was keep on testing it. But I managed to make it work, and that's some overview of the software architecture. So basically the major code was in C. I was using Arduino. Then it was working on my Atmega. The output was CSV files. And then I just wrote a simple Python script. And because I was still experimenting with my data, I was just using time series database Influx and visualizing things in Grafana, because I was mostly concerned about my data. So that was like a short prototyping pipe. So here are examples of my results. So the first things you need to check is doing the hydrostatic tests. Like you make your sensor measure volume of water, and you just add this water and make sure that the pressure is proportional to the height of the water in the column. And then there are another results of tests, like I put it in the Sciolis Marina, then I was comparing to the Oslotite data from Kartreverket. This is the data from the Portugal. If you zoom out and you have like 1 day of data, you will register tight. But if you zoom in, you will have all the small waves and the ripples visible. The next that I've learned is there is no such a thing as being over-prepared. Why do I tell about this? So I did all sorts of tests. I occasionally had to hire some diver, and I thought that everything worked. And I still had my first prototype, and I decided to go for a holidays. This is Shikama, one of the best beaches, one of the best point breaks in the world. And I was very excited to get data about perfect waves. That's like a surfer's dream. And as usual, I found divers. They went down and installed my sensor. I had like over a week. I hope to have over a week of data. And then, yeah, again, I only got 4 seconds of data. So what happened? So I occasionally noticed that the device would reset itself, but it was reset itself. So I was a little bit ignoring, and the project was quite large. So what happens, basically, the power connection failed. So then I was kind of down, but I decided, okay, I will just improve everything. So I will improve the battery holder. I will change the PVC wires to silicone ones. I stopped even trusting in GST-PH connection, so I did crumpled my own cables just because I just really wanted to make sure that things actually work. And then I concluded, because there is this rule that the chain is as strong as its weakest link, and you can like put as much energy as you can to make sure everything will work, but the Murphy laws also work. So basically, I decided, okay, so if I cannot trust single devices, and I am able to build several devices, so maybe I can build several sensors, because the total cost and the total work of building several sensors is not, it's kind of comparable to one. And then I've decided to, okay, I will just build as many sensors as I can during the summer. And I've discovered that actually building those boards is not exactly a repeatable process. So on the one side of those images, you will see the sensors that worked, the boards that worked. On the other sides are the ones that don't work. People who are experienced have less of the not working part. But the things that I've learned, it's like even if I would have the very same components from the very same producer, bought from some respectable and trustworthy distributor, and I would assemble it in a very same way, using the very same gear in the same room, there would be like slight difference in the data. So here are 4 assembled sensors that were measuring atmospheric pressure in my room, and then I would just leave it to compare the data, and you can see there is not exactly a shift between them. One of them, the orange one, should be removed from usage. And then the shift is around 2 megabars. That would correspond to 2 centimeters of water. So just to tell, because mostly when we work with the data, we have the data kind of cleaned, and we don't see all the dirty details. So then the next thing that I've learned is, because the project was quite large, and occasionally I had to convince divers to help me and negotiate the price. So if you show something, it's still working prototype. Like all of those devices have exactly same electronics inside, but the first one was the first that I built. I've used the protective white pipe, so it looked like a bit as kitchen plumbing. And the trick was like I basically replaced the white pipe with the black one, paid a little bit more money, and then it looked a little bit more neat. So then people are kind of more trustworthy to your project. And like, they don't examine you that much, and they can't believe this is an actual sensor. So where I am now, my sensors are in below the surfing beach, I would say. And now I've discovered there are new problems. GPS is not exactly accurate, so you need to recover it. You can put some markings, but then there's another sets of problems with mooring and making sure that all your markings will survive and making sure that nobody will steal those markings. So this is like the whole new story with retrieving the data. But I managed to make it work. I've also learned how to drill in the concrete. In the meantime, yes. So that's all from me. Thank you.
Thank you very much. So the learning is, don't make your IoT devices look like pipe bombs. No,
or
it's
did I turn it? Yeah.
no, it's off.
Maybe you need to turn it on first, yes. Hello. Hello?
Yeah.
Yeah, I think it's working.
Can you go there?
How do I allow, maybe? Quit. Do this. And her.
Oh, you have to.
Right,
you want
to
s-
die.
Yeah.
Here.
You're mirroring now.
Am I? Oh, yeah, okay.
So go on
So here, start mirroring,
Yes.
and this will work.
There.
Other way.
Yes, on that side. Yeah.
Then how do I can see?
Double click on the title bar.
Maybe I need to go to that green thing.
Oh.
There it is. How do I get here? I don't know where my.
Where your mouse is. That's to the right.
It's the other way. Yeah, oh God. Okay. Yeah. Yes, I'll just still back. Whew, okay. Manage. Hi, everybody. So, life is about prioritization. And I think Marissa Mayer, the former CEO of Yahoo, got it right, in my opinion. So God, family, work in that order. And that is what I aspire and strive to keep, that priority. So my name is Haimanot Tekie. I'm originally from Eritrea and Ethiopia, but I've lived most of my life in Norway. I'm 35 and a wife and a mother of those two beautiful babies that are not babies anymore. I spend a lot of time studying Jesus and attending various prayer meetings and Bible study in a small church that I go to, and taking care of my family, which involves braiding Rebecca's hair. So one of the picture down there, I watched like a YouTube tutorial on how to make this traditional Eritrean Ethiopian braiding for the first time, and I was so proud when I managed. So she needed to do that for the Kulturdag in her school. And I also spend a lot of time trying to be a well-rounded and competent software engineer. And I currently work at NAV as a senior full-stack developer, which means I'm neither good at front-end or back-end. But I've been doing this for 8 years, and but it feels like I just got started. Will this do? Okay, how do I, this maybe? Yeah. But today I want to talk to you about my journey of learning React and the struggles I faced and what I wish I knew. I remember the first time I encountered React. It was not fun at all. And it was in the very early days of my career. I was asked to fix a small bug in an existing React application. On the surface, the task seemed very simple, manageable, and but the issue I was having was this React application was already set up, right? With npm, Node, Webpack, Redux, ESLint, Prettier, JSX, and a bunch of other dependencies. I have no idea what they were. So just imagine the overwhelming feeling my poor junior self felt, and my experience up until that point was mainly with Java from school years, and I was mainly doing like a backend work, and the little front end I did was with Swing, right? So that's Java still. So looking at this React application, it felt like I was being thrown into a maze without a map. So one of the most difficult parts of learning React for me was the fact that I was being introduced to so many things all at once. I had issues trying to start the application locally, and I got help with that. And then, I had issues with knowing where to make a change, and I got help with that as well. And then when I finally made my change, Okay, I can use that. Yeah. So Eslin screamed, and I had no idea what I did wrong, but I got help with that as well. So with a whole lot of like hand-holding from colleagues, I completed the task, but I was left with very little understanding and a lot of frustration and confusion. And I remember when some developers were talking about, the benefits of React. React is very fast. It uses this virtual DOM. It doesn't operate on the actual DOM to make the change, and that makes it fast. And I was like, okay, that flew right over my head because I did not know much about the real DOM, leave alone the virtual one. So what I'm trying to get across is that not having a good understanding of the fundamentals of web development was a big hurdle in my journey. So, okay, I needed to learn React properly. So I decided, okay, let me find some tutorials. Some people suggested Egghead.io with some short videos there. Okay, I watched them. And there was some YouTube tutorials, and there were even some cartoon-based tutorials on Redux. But all of those things didn't work well for me because, and my frustration, like Brian Holt, one of my favorite instructors in Front-End Masters, he captured my frustrations very well when he talked about his experience. And what he said was, my problem with many tutorials was that they jumped over steps 1 to 13 and they started at step 14. And that was exactly how I was feeling with most of the tutorials. Most of the tutorials assumed that I already knew a lot, which I did not. And they often jumped right into like building a small application or a small example without properly talking about how did they set their projects up and what are the different tools surrounding this React thing were and what were they for. So what I wish I realized early on was I wish I knew, okay, I need a lot more structured and step-by-step approach to learning rather than just watching a bunch of small tutorials here and there and trying to piece what I learned together afterwards. So as you can see, my struggle with React was not really the React itself, because React is a small UI library, right? But my issue was with the ecosystem around and the tooling around React. And that's what made things difficult for me. So, and also the fact that I did not know about web development, right? That's a whole thing for itself. So that added to my challenge. But these are my heroes from Front-End Masters. I actually met Kyle Simpson and Kenzie Dodds in one conference, and I just have to calm myself down, stop behaving like a fangirl. Yeah, so the turning point for me was when I came across Front-End Masters. This is a learning platform. It's subscription-based, but I do ask my employers to please pay for the subscription fee, because this is necessary for my work. And my favorite part of the platform is this learning path. And the first thing I did when I got there was I ate a piece of my humble pie and started at the beginning. And then the first course there that I took was Complete Intro to Web Development by Brian Holt. And this course, it's about like 12 hours long, so I watched it with like 2x speed and then slowed down on the parts that were new to me. After that, I watched some Getting Started with JavaScript by Kyle Simpson. I watched another JavaScript course called JavaScript from Fundamentals to Functional by Bianca. And I also took some courses on Node.js by Scott Moss and full stack development by Jem Young and some testing by Kenzie Dodds. And I still use this platform today also because it always updates the courses when new versions of the tools come. And this after I covered the fundamental things, then I went to watch this React course by Brian Holt. It was called Complete Intro to React, and I don't know how readable this is, but those are like the different steps, right? So the course was super hands-on, and the best part, it does not jump steps. So, and after a short introduction as to what React was, he went right into like the tools surrounding React. And he spoke about what those tools were, how to configure them, set them up to get started with a new project. And then only then, after like on step 14, did he start to speak about Redux, right? So I started on the wrong end of things when I was trying to learn this thing. So and also when it comes to the toolings, he doesn't go in depth into like each tooling, because that would be like super time consuming. But he gives you like enough to cover what they are and what you need them for and how to set them up. And if you need to dig deeper, front-end masters have courses on those as well. So now looking at an existing React application was not as daunting as it was in the beginning. And I can't tell you how rewarding that feeling is to know that you're not just navigating and moving in the dark. So I'm super grateful for that. Another thing that I think would have helped me was like if I could just take a step back and draw a parallel between the Java ecosystem that I was familiar with and compare it to the new React ecosystem that I was trying to learn. So, of course, this comparison has its limitation because there are two different Java and React or JavaScript. They serve different purposes, but it would have been helpful. So, if we take like building and packaging in the React world, we use bundlers like Webpack or Vite, and in the Java world, we'd use Maven. So bundlers in the React world, they bundle our JavaScript files, CSS files, other assets that we might have, and optimize it to be loaded to the browser. In the Java world, Maven would do the compiling of the Java code, handling dependencies, and packaging everything into a jar. And this can then be executed in the server. But when it comes to dependency management, in the React world, we have NPM, and then we have all the dependencies coming in, or the dependencies are listed in this package.json file, and it's pulled from NPM's registry. In the Java world, we have Maven. The dependency is listed in POM.xml, and it's pulled from Maven Central. So there's some similarity there. And for development and runtime environment, in the React world, we use Node.js to both build and run JavaScript outside of the browser in our computers. And then in the Java world, we would have JDK and Jerry. And when it comes to code styling, ESLint is used in the React world, and checkstyle is serves similar purposes in the Java world. Code formatter, Prettier does that for the JavaScript world. And in the Java world, as far as I know, at least, that's the IDE, or you can set up your IDE to auto-format your code. When it comes to core structural unit, in the React world, you have components. And components, they can be class-based, as they were in the beginning, and we have functional components today as well, which is more widely used. And this leads me to my next hurdle that I wish I had understood better earlier. In Java, I would typically create a class, I would instantiate an object, and I would use methods to mutate the state of that object. In React, however, regardless if it is class-based or functional, I cannot directly mutate the state of the component. State is immutable, and if I need to change the state of a component, I just have to tell React to do it. So React handles that for me. So in React, I would use, set state if it's a class-based component, or use state hook if it's functional component to do the state change. And React then creates a new version of the state and merges it with the previous state and re-renders the component with the new updated state. And all of this is happening without my involvement as a programmer. In Java, I was used to managing both state and behavior imperatively. I was used to explicitly saying to Java, I want you to update this. I want you to do those steps to update the state of this object. But in React, state is managed declaratively, and when state is updated, it automatically triggers UI re-render or UI change without me having to explicitly say that. So this shift in paradigm required a change in mindset, and it took me a good while to adjust. And with React's approach, you end up with a lot simpler and cleaner code, but you do have to let go of some control. Another area that challenged me was understanding the asynchronous programming in JavaScript. In Java, I was mostly used to synchronous programming. I call a method, I wait for it to return, and then I move on to the next. And of course, I've learned about threads and multi-threaded stuff in university, but I hardly used that in the Java world. But in JavaScript, things are different. Fetching data from an API is done asynchronously without blocking the UI. And promises and async await make those things possible. But I did not know this at the time, and this is one of the courses that really were helpful for me to understand that. This Will sentence, he had a course called JavaScript, the hard part. So this was super helpful for me. So, what I wished I knew that would have made my journey in learning React a lot more enjoyable. It was the extreme importance of building the solid foundation in JavaScript, the DOM, and the modern web development before jumping into React and Redux. So if I could go back to this early days, I would assure myself that I was struggling with React in the front-end world, not because I was slow, but because there is a lot going on. Front-end is not any longer about just making a button pretty or changing colors. It's a whole thing. And I tell myself, take your time to learn those basics. It will save you a lot of frustration in the long run. And my humble request to those crazy, busy senior developers working with or mentoring junior developers, I would say please be patient and gentle with helping the juniors to grasp the fundamentals and do it step by step. That's a key word, step by step. Please don't try to offload the knowledge you have accumulated in the past 10 years within 10 minutes, right? So, and your guidance can make all the difference. So thank you for your attention. And that was my talk.
Thank you. Plug and play, plug and pray. Oh yeah, we'll take the clicker.
Tack ska du ha. Hallå? Dere hører meg? Okej. Ja, ska vi se. Hvordan får man... Ja. Yeah. Let's see. Allow. Okay. I'm gonna quit this VPN client. Let's see. Yeah, I used to have a button. Let's see. This?
Yes. Stop now.
Yeah. Woohoo! Okay. I went over there. Yeah. No. Okay. Okay, this is very hard. I should have turned it off afterwards. Let's see. Should we bring it? Let's see. Ugh, Christ. Is there? Do anybody know if there's like a shortcut for options? No. Ugh, Christ. I can't like get the. Can I? Okay.
I'm not
okay,
a Mac
a little
user.
bit down.
We're taking tips now for getting the presentation to start
Okay.
with Keynote, I guess.
I'm gonna get.
Ah,
Okay.
well,
Yeah. Okay.
cool. All right.
Well, we did it the hard way. All right. So, there's something wrong now. Again. Let's see. Do I just have to do like this and try again? Come on. Ugh. Okay. Yay. Cables. All right. So I'm Nora Tessem. I'm a consultant and full-stack developer at Embrick, which means that I mostly do backend, actually. I also have a background in usability and design, so I have very strong opinions about how things should look, but I don't particularly enjoy coding them. And I'm very into like abstraction, and I also have like a background in databases, which is the thing that I prefer to work with if I can. I'm currently hired at the in-house software department at Embrick, migrating legacy software, collecting energy consumption data from private homes, the little smart meters you all have at home, to the cloud. Previously, I worked on the analysis team, building applications to improve the distribution grid. And in that capacity, I helped to build a Swiss Army knife of sorts to build simulations of the future energy consumption width. That's supposed to be used by grid planners. Those are the people who decide how kind of your local distribution grid looks like, fuses and such. First, I actually want to acknowledge that in the era of remote working, it's sometimes hard to get the quiet to have good ideas. I think at least this was conceived in like the old school whiteboarding setting, where you spitball ideas together intensively in one moment, and in the next you sit in silence, contemplating after somebody discovers a caveat or something that needs mulling over for a moment. Remote work has its perks, but the kind of the safe silence to ideate and to think things over and to not rush a solution isn't always there. I collaborated with Sindre Mehus, which is a consultant at Sienta, on the following design, and I think we had a great time coming up with it. Maybe too much of a great time. Anyhow, calendars, what are they? Everybody knows what a calendar is. It's kind of something you take for granted, right? It's to sort of track the passing of time. In the West, we have had several official calendars through the years, The Georgian calendar we have today superseded the Julian calendar, and many other civilizations have their own calendars again. In science and in sensor data, like I work with, we often use timestamp or epoch or Unix time, which is the continuous passing of every non-leap second since January 1st of 1970. We didn't really have a lot of computers before 1970s. We had some, but the bulk of them are after 1970s. Calendars are not just to keep track of time, it's also an observation of what happens in our environment. And here we have the concept of the perpetual calendar, which sometimes has the name of the lunisolar calendar or the tropical year. And also Primstav, the runic almanac, which some of you may know about, that we used to have in earlier Norway. It's a perpetual calendar as well. It's fixed. It kind of describes what happens through the seasons, and it has some holidays that are always on the same date. Tropical year, or the solar year, is what we experience on Earth. It's the seasons, it's the ellipses that Earth takes around the sun. It doesn't add up mathematically. It's 365 days, 22 days, and that's like 5 minutes and 45 minutes, 5 hours and 45 minutes, and then again some. It's not perfect, but the solar year is very used in agriculture and astronomy because it actually describes what happens around us. It's not just a proxy we use to track time. So it's like empirical facts encoded in a system. Our calendar today, the Gregorian one, doesn't add up to whole days, and it's inconvenient to build time systems around. It has a solution for the fact that there's a remainder of a day, and that's called leap year. It was created in the Julian calendar, and it was revised in the Georgian calendar, and it still isn't perfect, and it's still causing a lot of bugs, actually. Getting back to the energy consumption. Grid planners have to know what's going to happen with our energy consumption in order to sort of know where they're going to build out the distribution grid. And so they had this idea that we just take what happened past and we just make it so that it happens in the future, and then they could test their hypothesis on it. And that was kind of the product that we were going to create. And because of that, we had to make a very simple solution where we just take the past energy expenditure and we just extrapolate it into the future, and we do nothing with it. So they actually have a very neutral ground. Of course, the past is not neutral when it comes to energy expenditure, because you can have outliers such as weather. You can have like a very cold year, and if you sample from that year, the next year, it doesn't actually correctly represent the future at all. But this is something we chose to not care about. Actually, in this phase of the project, we just wanted to something that you could build on later, and then you can maybe implement some adjustment and weighting according to like if what the data you sampled was from a particularly cold year or something like this. This is just like the really prototype for energy consumption. People do different activities that expends more power, like cooking and washing, and also maybe they have an electrical car or something like this. And people are creatures of habit, so they do the same things at the same time every day. And some people only go to work Wednesday, like Tuesday, Wednesday, Friday. So the day a week really impacts how the power consumption data looks like. So what we chose to focus on was the day a week and the time of year, really. And then you could envision a solution where you just take 1 year and you just plus 365 days. What can go wrong? Well, if you do that, you have the concept of weekday drift. Your Sunday will become your Monday. And if there is a leap year, then your Sunday will become a Tuesday after the leap day. And it's not very convenient. It doesn't really represent the fact that you use energy differently on different days. And of course, you can get around this by subtracting 1 day and subtracting 2 days, but after a while, just like counting on your fingers, it gets very complex. And it might not be it for like really tidy, future, long-term, robust and flexible solutions. I personally don't like indexed for loops, which would be like maybe the solution to this. I could say that I find this easier, but when developers say they think something is easy and simple, they're just actually stating their preference. This is my preference. Don't feel discouraged if you're of a different opinion. And also, there's probably some C programmers in the room that's going to think that this solution is incredibly inefficient. But we build it to sort of be robust over time because what we were going to end up with was not very certain at the time. So we had to make sure that it was kind of easy to develop. And when I say easy to develop, then maybe I'm not right, because maybe it's very complex for some people. So instead, we opted for cool abstraction and math stuff. We want to avoid bugs and make the system easy to understand over time. And I admit that maybe it's not that easy. But I wager it's easier than keeping track of +1 and +2 and all of this stuff. And after 5 years, you're like, plus. It's very hard to sort of break into a for loop like that. And you want to build that. So all of a sudden, you want to take account for like if it's a holiday or something like that, because people, they cook it all day on Christmas Eve, and that really impacts the the graph of their data. And so we kind of ended up building on some kind of database concepts. This is not a database talk, actually. You will see no databases here. Don't be discouraged. Or cookbook logic. Because in the back of a cookbook, you can kind of look up several parameters of a recipe instead of like counting your pages. And we had to kind of determine what it was going to be our key. What time-related attributes determine energy consumption? Well, you have the time of year. We sort of made that into month. And then you have the weekday and the hour. These are the objects, the key, month, weekday, hour, and then the value, load, which is like the kind of how much energy the customer used at that time, sample from that date, and to make sure that we can do some calculations afterwards, I'm going to show you in a minute, we had to keep track of which day of year that was sampled for, because that can vary, and how many days there were in that year, because sadly, we're going to have to account for leap year. So this is the code. This is the code in a different formatting, because I didn't remove the previous slide. And well, this is how you instantiate the calendar. You sample a year of data and you put it into this constructor, and it magically makes a calendar for you. So now this was the talk. No, I'm just kidding. It's not. We heavily utilized Eclipse collections for this project, and on this project as a whole. I really recommend it. It's kind of based on Smalltalk, but you see that there's like some elements of it that looks a lot like SQL. The group by, for instance. I'm going to show you another group by very soon. Anyway, we cast all the timestamps into its respective values in our calendar system. That is on the previous slide. And then eventually you get the future consumption. Here you send in a from timestamp into the future. So you take like maybe tomorrow, the day tomorrow or the day today, and you say, I want like the previous 2 years of data extrapolated into the 5 years of the future. And then you get your result. But wait, how do we find the closest value? When you have a Tuesday in April, 1 year, that Tuesday in April may be like so much further out the next year. And maybe the last Tuesday of March is actually very much closer to the day you want to extrapolate for. So when we calculate the value we're going to end up with in like 2 weeks in the simulation, for instance, we take the previous month, we take the current month that you're calculating for, and you take the future month, and you bunch that all into a list. Okay? And then again, what is the day of year for? Well, if you take 3 months worth of data and you shove it into a list like we did, you probably end up with around like 12 elements, maybe less. And then you want to, out of those 12 values, you want to determine which one is closest to the date you're trying to extrapolate for. And also, you have to account for leap year. And you have to account for the fact that if you are trying to find January 1, then maybe the day that is the closest to your date, like your Tuesday in January, is actually December, January. So your formula has to kind of wrap around 365 or 366, depending on the year. Enter cool math stuff. So usually when you try to wrap a circle, you use modular, right? Because the scale kind of ends at 365 or 366 in this case. And here I made a grave mistake of future-proofing the code, because you actually don't need modulo for this. Modulo is the best to use when you actually have a circle that is always the same and not sometimes a different circle. But I kind of accounted for that in the math. And just for fun, I had ChatGPT rewrite this formula for this presentation, and it worked for the one sample I tested before doing this presentation. And it's probably a whole lot easier to understand, I think, than this. But looks so much cooler, and nobody's going to dare touch this before the time of ChatGPT. So I'm pretty pleased that it exists, and it will maybe protect the future generations from the insanity of wanting to use math in certain circumstances where it's actually not that needed. Okay, so we have the last piece of the puzzle here is, you have all the values, and then you group it by the get distance is over there. This is get distance. It's like the distance between 2 days, right? I'm not going to blame you if you sit here like and don't understand anything. Don't feel stupid. Just don't. I'm stupid. Okay. And then you group by the distance, And then you get like, okay, this Tuesday in April is this many days away from the Tuesday in April you're trying to figure out. This day in March is like 2 days away from the Tuesday in April you're trying to figure out, right? You group it by that and you take the minimum value. It's over there. Let's see. Oh, it's a very bad laser. Anyway, let's see there. You group by this and you get like 1, 5, 11, 340, and so on. And if you get no answer, you get a 0. It's very unlikely that that's going to happen over 12 values, right? But if you have an erroneous like time, maybe that's going to happen. And then you group by over here, and then you select the smallest one. And when you have selected the smallest one, there is a chance that you might get several values, especially if you're sampling several years. And then you do an average. And if that doesn't yield anything as well, you get a 0. It's probably never going to happen, but it's nice to account for it in your code. And I don't want to push the burden of getting a null pointer to the people who are maintaining this code today. And the reason why I'm choosing to make it a 0 is because then it will be very obvious to the person who is running the simulation that something went wrong. And you want to at least have some kind of transparency around the things when you're making stuff like this. So what's missing? Well, very many things. This doesn't actually account for the fact that you can have like missing timestamps, right? And then you can end up with like the Tuesday in March, even though there was like a 2 o'clock measurement in April. Maybe that's more correct. But also, if the 2 o'clock one was a big outlier, you would have like a 2-hour stretch of like really high power consumption. So you want to account for that. Also, this doesn't use like statistics at all, and you're very prone to weather overfitting. For instance, when you have like a Siberian winter year, you don't want to assume that you're going to have 5 years of Siberian winter. I would not like to have that, at least. And there are societal factors that you can predict: pandemics, war, inflation, bank crisis, general strikes, many things that change the way we behave. It's really hard to predict the future. Anyhow, I hope you enjoyed this talk. If you want to talk to me about anything, I'm very game when it comes to that. And I'm interested in a lot of stuff, but I care deeply about databases like Willow here. And that's it.
Thank you.
Is my mic working already? Yeah. Let's see.
I got the tip in.
Yeah? There are even like leap seconds. Leap seconds.
Yeah, I know.
So because
We only have our values, though.
Yes, we implemented the calendar.
Yeah. Okay, I'm just going to apologize right away because this will go into the break a little bit. If you have to leave to take a break, just do it. I won't be offended. Okay, so I don't know if anyone here can relate to this, but I have spent years wanting to work with something without actually taking any action to do so. I had talked about it, I had thought about it, I had dreamed about it, I had looked into it, and then I had talked about it some more. But I hadn't done it. I honestly hadn't even tried. So this talk is about doing the thing, which in my instance was learning iOS development to become a native app developer. And for anyone, oh, wow. So for anyone who now is like, native developer what? Native apps are applications developed specifically for the platform they run on. For example, many companies will develop one specific app for Apple and another one for Android. Some of these some examples of native apps are Winther, NRK TV, and Finn. I'm also going to use the term iOS quite a lot. This refers to Apple's products like the iPhone or the iPad. But before we get any further into the talk, hi, my name is Egwene. I have a master's in informatics from the University of Oslo. I worked 3 years as a front-end consultant, and for the past year, I've worked at NRK TV as an iOS developer. So going from saying that I hadn't even tried to do iOS development to saying that I now work professionally at NRK, of all places, as an iOS developer, something obviously happened in between there. So, like you see, the talk is named Only Doing the Thing is Doing the Thing. And that is the central part of my journey. The only way to become an iOS developer was to do iOS developer things. And that makes sense, right? I mean, not just talk about it, but actually do things like learning the language, the frameworks, the tools like Xcode and simulators on your Mac. Oh, I should not touch the table. Cool. It truly does. Awesome. Okay. So, how do we go from thinking and talking about something we want to do to actually doing it? The rest of the talk will focus on the 4 steps, they are already up, that I found helpful when deciding that I had waited long enough to start. While this talk will focus on my road to iOShood, these 4 steps can be applied to pretty much anything, from how to set up an online shop, to creating your own backend, to getting to know Figma, even producing a talk in less than 2 weeks. So let's get into this with the first step, identify what you want to do. So the first step is pretty obvious, right? Identify what you want to do. You probably already know this. But just because something is obvious doesn't mean that it is straightforward. So I have 3 questions that I go through to kind of help me, and probably maybe help you guys, identify the what and the why. So question 1, what is holding you back from pursuing this? In other words, why are you postponing doing the thing? Why did I just talk and think about iOS development for years? And to be completely honest with you, I was really scared. I was scared that I would try and that I would not be good enough. And I was scared that I would fail. And I was so scared that it felt reasonable to just not try at all. Because, you can't fail if you don't try. But you can't succeed either. So I get real with this. There's usually a reason why we don't do the things we would like to do. And figuring out why that is can make it easier to at least try. So question 2, what is your goal for doing this? And I'm not saying that you need a goal to start doing the thing. You definitely don't. But it can be easier to stick with the process and to know when you've accomplished what you set out to do. And the goal doesn't have to be grand or sparkling. It can be really, really simple. When I was thinking about this before starting my iOS journey a few years ago, my goal was to get a small win every day. This win I could get through showing up. And like I said for question 1, I was really scared of failing. But if I could get a win from just showing up every day, it felt a little bit less scary. And related to figuring out your goal, it can also be really easy to become the type of developer your first job needed. I don't know if anyone else here can relate to this. But it can also then be really hard to break free, especially if you work as a consultant like I did, because they make money from you doing the one thing that you now know how to do. So another, but unspoken, goal of mine was to get to work as an iOS developer. And this definitely felt like a grand and sparkling goal, kind of impossible at times. Question 3, what do you already know? because you can build on the knowledge you already have to either build up, like figure out the steps you want to take, or to figure out which steps you don't want to take. So, because in essence, what I wanted to do was make apps for iPhone. And you don't need to do native iOS development to make apps for iPhone. You can use a cross-platform framework like React Native. The pros are you'll get an app that runs on both Android and iPhone. And at least for me, I knew JavaScript from university, so it was kind of like, oh, I already kind of know it. Plus, I had worked with it for a year already. So going the React Native route to make iPhone apps should have been the right choice for me. But for some reason, I was still thinking about the mysterious world of native iOS development, and I was really like hooked in their ecosystem already, so why not just connect my job to it as well? That's step 1 done. After having identified what you want to do, why, and what has been holding you back, you're ready for step 2, finding resources. With the internet, this should be the easiest thing to do. However, I find that it gives me a massive functional freeze due to all the choices. A quick Google search of Learn iOS Development shows several different courses and resources. And the same search on YouTube gets a whole list of different creators telling you different ways to start in different ways. And it's just too much information that the hard part often ends up being choosing the resource and not actually finding one. So my best tip here is go back to basics. Talk to the people who are already doing what you want to do. Ask them how they would go about learning what they do now and figure out their resources, where they go looking for answers and inspiration. And if you don't know anyone who is doing what you want to do, this is a great opportunity to network. Do this either on LinkedIn or even better here at AdaCon. There are so many interesting talks today. I'm sure several of you could find something that you would love to try yourself. Like I now really want to try migrations. I never thought about it before. Don't do. So yeah, you'd probably, like most people love talking about what they've learned, and you'd probably be surprised by how helpful they can be. But depending on how you like to learn, it could be beneficial to look for structured courses, either online or in person. Courses generally have a set progression and a timeline, which for me is how I prefer to learn. However, the most important part is not what resource you choose, but that you choose one and that you commit to it. You can easily spend days, weeks, even months jumping between resources, but that will not get you any further. I would recommend not spending more than a day or maybe an evening looking for a resource to use, and go with what you think is best at the end of that time. Ultimately, all resources will teach you something, but it is the effort you put in that will make you learn, not which resource you choose. The same thing also goes if you prefer side projects to courses. If the goal is learning, then focus on that. Don't spend all your time coming up with a perfect project. Just do the thing. For my iOS journey, I talked to people already working with the iOS development, and I got recommended the program 100 Days of Swift UI by Paul Hudson. This is a great source if anyone here wants to learn iOS development. The reasons for my choice here, choosing this, was that it was free. And all I needed to start was a Mac with Xcode installed. I did not have to sign up to any extra site. I didn't even have to create a login. Everything is hosted on his own page. Like you can go into YouTube, but you can also just watch it there, meaning you don't get to see other content or video ads all the time. It also has you starting making apps really quickly, which was what I wanted, but it also takes you through the beginning, like how do you get started? How do you write integers in Swift? But the main point maybe for me was it had a time frame, not just here are the different steps, but here are the 100 days. You just have to show up 100 times and the rest will just figure itself out. Kind of. So step 1 and 2 should ideally be short and sweet. Both could be completed in an afternoon because it's not that serious. Step 1 and 2 are guidelines. They're here to help you with the execution of the most important thing, the doing the thing. Step 3, do the thing. This is the central part. and the most important part. So it's probably going to feel strange that this is also the shortest step in the doc, because there's not that much to it. Once you've identified what you want to do and you've found a resource to use, now all that's left to do is taking action. And how do we take action? Like just do it. You just sit down and you do it. There's one thing that could be really helpful at this stage, and that is deciding on a time frame. Could be the 100 days, but it could also be like when during the day should you be doing this. I was lucky here because my program gave me the time frame 100 days. But if you ask me if I completed the program in 100 days, no, I did not. I used the time frame for a guidance of how far I had gotten. So I knew, okay, I have now spent 3 weeks learning. That means that there is 89. Math's not my. We're not mathing here. I could figure out how far I had progressed based on which day I was on, and that was the most important part. So I just knew I had to show up 100 times in order to complete the program, and I would learn a lot about iOS. But I spaced those 100 times over the course of 12 to 14 months. And that's because life happens, and that's okay. And you just have to keep showing up when you can. You don't fail if you stop learning for a while. You only fail when you stop, completely stop. So if you stop today and you don't pick it up until the day you die, then yeah, you kind of failed. But you still have all this opportunity to succeed. So then, doing the thing. What you need to do is show up. And then you show up again, and again, and again, and again, and you get the point. This is the step where you utilize the effectiveness of just showing up consistently. If you work on something for 15 minutes every day for a month, you'll undoubtedly get further than spending 2 hours one time. Plus, things will stick better in your brain, I think. I will drink some water now. So, when I started doing the thing, learning iOS development, I spent around 15 to 60 minutes every evening. And suddenly, I had made 2 apps in 3 weeks. And 3 weeks after that again, I had made 7 apps. And at the end of the 100-day program, I had made 13 different apps. And also been through several technique projects focusing on themes like animation, accessibility, navigation, and data, to name a few. But as you can see here, it's nothing fancy. This is not doing anything perfectly, nor to production levels. And it doesn't have to be, because like I said, it's not that serious. We're trying to do the thing and just learn, do it. And perfection is kind of the murderer of doing sometimes. But of course, disclaimer, most of these apps were done under the guidance of the program I was doing. But the more I learned from the program and the more apps I made, the more I could think up solutions myself. I started knowing where to look for answers. I started getting a feeling of what was possible and how to start working on an app idea from scratch. It weirdly felt like magic getting to this place, but it was just the effectiveness of showing up consistently. So step 3 is definitely where most time should be spent. This is the part where the magic happens, even if the magic is just consistency. But we need to know how things are going to. So let's go through the final step. Step 4 is all about assessing how the doing went. I'd like to add right away that this step can come in the middle of the doing the thing, of any of the other steps. It's not necessarily the last step, but it is an important one. Going over how it went, what could have been better and what was already great, helped me adjust how I was approaching learning iOS development. An example, as I was getting further into the program, I started pushing the sessions later and later in the evening, which resulted in me not remembering much the following day. So I decided to go back, redo a bunch of days, and be stricter with doing a session after dinner instead of right before bed. And that magically just helped. Assessing how it's going can also be a great help in deciding that you don't like what you set out to do. And quitting is also valid. Just because only doing the thing is doing the thing doesn't mean that you should be doing something you don't enjoy. Sometimes doing the thing shows us that we're not actually that into it. It could have been a fun exercise, but that was it. Or maybe a great hobby to enjoy in your spare time sometimes. And that's okay. I, as you might have gathered, decided that iOS development was a fun exercise that I was interested in exploring even more. Some of the reasons for this was I enjoyed how easy it was to test several accessibility features on device without the need for extra software. I loved how quickly an idea could go from a sketch to an app, and I really loved being able to have what I worked on my phone at all times, which also resulted in a cool party trick. Want to see what I just worked on? So yeah, I wanted to pursue iOS development, which had me do the more difficult thing than actually doing the thing. I had to believe in myself and what I had learned, enough to dare apply for a job as an iOS developer. But that is a story for another day, including how I used this exact same formula to learn Figma just to make the coolest CV to ensure I was noticed in the application pile. And I was. Yeah, you can give me applause. That's fine. But yeah, pretty much there you have it. A pretty simple step guide to how to do the thing. Summarizing it up, like get clear on what you want to do. Talk to people who are already doing what you want to do and get their tips and tricks. Set a time frame and show up consistently. Remember that doing the thing is more important than all the other steps, but all the other steps can simplify the process for you. Don't forget to assess, and don't be scared to adjust your process or change the thing you've been doing. Like they say in hiking in Norway, der ingen skam å snu. Like there is no shame in turning back, ever. So yeah, lessons learned. There is no magic or hocus pocus to learning something new. It just takes time and showing up consistently, like you just have to do the work. Who would have thought? Remember that the goals are there to help guide us. Doing the thing itself is the goal. If you want to pursue or try something, don't stand in your own way. Don't let go of a great opportunity because you're scared you might get rejected. Just remember that companies hire people to do this, so don't do it for them for free. And sometimes things take longer than anticipated, and that does not a failure make. The timeline is more like a guideline, like any consultancy would know, especially when we are exploring and learning. And in hindsight, I realized that I probably would not have needed to spend more than 100 days learning SwiftUI to get where I am today. But I did need the boost in confidence completing the program gave me. And now we're almost done. This went quicker than I thought, so that's good. To finish this up, I just want to take a second to go, this talk didn't go into anything technical per se, because as cheesy as it sounds, my goal was to make a talk that I myself would have needed 2 years ago. I hope it can encourage at least one person to get started doing the thing they've been thinking of doing, or to seize the inspiration you gained from AdaCon today and try the cool thing you heard about in a talk, because I believe in you. And finally, I have heard there are more women iOS developers, but I have yet to meet anyone in person. So if you are an iOS developer or if you want to become an iOS developer, don't hesitate to reach out. Thank you all for listening. Enjoy the rest of the day.
Thank you very much. So we now have a break until 11:50. And I have added a slide or a feedback form for the speakers. So you can take a screenshot. I will also send you an email with the link with the form where you select the talk and then you submit feedback. So please don't give feedback to the speakers before asking them. But if you send it to us, we will collect the feedback and then ask the speakers if they want to hear it, and then we'll share it with them. Yeah, enjoy the break. Be back at 11:50. All right, you can get prepared a bit. There's a QR code for the next speaker that you can scan to participate in this presentation live. So scan the QR code. And I guess if you don't want to scan a QR code, because this is what your chief security officer told you, you can go to slido.com, use this code and a passcode. Okay, please, also reminder, remove the space in the rows, move to the middle of the rows, so for the rest of the people that are coming later, they find a space. I would very much appreciate that. Do you want to start? Yeah, okay. All right.
Can you hear me? Yeah? Yeah? For my presentation, I need help from you people in the audience. Please join this poll, either by scanning the QR code or by joining at slido.com. The name of the poll is Testing is Hard, and the passcode is AdaCon24. Yeah? So it's cool to see getting in some responses. Yeah, so just continue joining okay. Yeah, just continue joining. I will have more polls during my talk. Writing tests can be really hard. Let's talk about the challenges and why it matters. I am Torunn. I work as a software developer at Cisco, working with video conferencing devices. Today, I want to discuss software quality and the importance of testing, a topic I find both challenging and crucial. My goal is to inspire you to write tests for the code you create, even when it seems unnecessary. We often think, my change is so simple and small. It shouldn't be necessary to write a unit test for it. But trust me, it is often a good idea. I will start by sharing my own journey with software testing, and I hope you will join me in this interactive poll to make the session more engaging. I've learned a lot about programming during my work, during my career, thanks to the support of excellent colleagues and mentors. It's been a while since I graduated. And during my studies, the focus in programming was primarily to getting things to work. Testing was something we did manually to prove that what we had built was finished. The issue with this approach is that if your project is successful, your code will live for much longer than the time it took to build it. We're talking about support periods that can exceed 10 years. There will be changing requirements, someone will add to your code, and your code will be used in a way you did not anticipate. I've learned that software has two values when it comes to its worth. First, its current functionality, what the software can do today. And second, the software's ability to be modified, what the software can be used to tomorrow. Later, I began learning how to write tests for my own software. This was around the time when we started getting smartphones. First, I learned about unit tests. These are tests that are tightly integrated with the code, often written in the same language as the code. I learned about test frameworks and test-driven development. Test-driven development is a method where you write the failing test first before you actually implement the code. I immediately liked this. First, it helped me break down a complex tasks into smaller, manageable pieces. Second, it reduced stress. When leaving work for the day, we know that the code we had written during the day was already safeguarded by tests. I also learned about black box integration tests running on real hardware devices. At that time, these tests were written and handled by QA specialists. I must admit I had mixed feelings towards these tests, since compared to the unit tests, they were far more complex, and since they depend on the real world, they are not deterministic. Nowadays, there are many books and talks available about software testing for developers. So I'm curious to learn about your experience. Most of you are much younger than me, and it's so cool to see young female developers in the room. A lot of. When you learned about programming at school or at university, how much time was spent on learning to write tests? Okay. Testing is hard. Let's see what's happened. Okay. Okay. It looks okay on your side. Yeah. So how much time was spent on learning to write tests for your code relative to just writing the code? Okay, I'm not seeing any answers, but can you see it? Yeah, good. Yeah. Then I want to show you a code example with the use of unit tests. So here I've got help from the GitHub Copilot to generate tests for the tennis scoring game. So the tests is on the right. On the left, we have started to implement the tennis scoring game step by step. The process is highly controlled. We are gradually building quality into the code by ensuring that every logical branch in the code has test coverage. It might seem trivial to add all this text on the right for such simple and highly readable code on the left. Is it really necessary? History has shown that a surprisingly large number of bugs could have been prevented with unit tests in place. You may look at these unit tests as protecting your code with Gore-Tex, or protecting its functionality like we are preserving food by canning it. So now some years have passed, and the code has grown more complex, and you are asked to fix a corner case for something. With unit tests in place, you can write the new test case for the corner case, fix the issue, and run all the existing tests. You will then be able to fix this issue much faster and with higher confidence if there are unit tests in place. You can think of these tests as the brakes in a car. Without brakes, you cannot drive fast. So whether you use test-driven development or write the test afterwards, it's not the point here, the important part. What truly matters is that you validate the feedback. the test provides when it fails. So make your test fail intentionally, comment out the code, and run the test. Does the test cover what you think? Evaluate the quality of the feedback. A failing test should at least tell you something about the expected value and the actual value, and spend time on good names for your tests. That gives context. Improving all these aspects can make your tests easier to understand for others. So the other family of tests I learned about was these physical device tests, where the entity under test is the complete product. To facilitate this, the QA team had developed a complete standalone system to control the device through our API. There are several benefits with this testing approach. First, it is real. You are testing on real hardware in a real environment and with all your third-party components included. Second, it's harder to cheat yourself. And 3, you can perform stress testing, evaluate performance, and supervise CPU utilization and memory usage. However, there are also challenges. Speed. Physical device tests often provide slower feedback compared to unit tests, since you have to upload software and boot up the device. Stability. These tests can be less stable due to the complexity and real-world dependencies. And error handling. It is harder to test exceptional behavior like error handling in these tests. So this is a picture from our lab where we run about 60,000 tests daily. Yeah, so when working with on Cisco video devices, we have these steps. We compile with strict flags, such as treating warnings as errors. We write and run the unit tests, and we perform real device integration tests on real hardware. The feedback from the last step is slow. It would be really beneficial to have something in between the last 2 steps to have faster feedback. To achieve this, I will first sketch a simplified model of the software on a video device. So we typically wait for something, some input, either from the network or from the user. We will then parse and validate this input, and then it's the do it part. That's where you have your algorithm, your business logic. And then we will present the result either as a signal back on the network or showing something on the screen. So the middle parts we can cover by unit tests. But imagine then that we try to cover a larger part of the software. And we model the passage of time, and we model the network. We model the attached hardware and the services we integrate with. Then we get something we call simulated integration tests. These tests can verify that the units are actually working together. However, the quality of these tests depends heavily on how accurately you have modeled the real world around the software. Bad modeling here is like covering your code with concrete. It gets really hard to change despite tests. So validate your modeling. To compare these testing levels with, for instance, an airplane. Think of all the software in an airplane as small Lego bricks covered by unit tests. For instance, the logic to control your seatbelt lamp. The simulated integration tests will be more like running a flight simulator, and then the real device, the physical device test, it's like taking a test flight. For the first 2 types of tests, there are many tools available. Since we are working with C++, we use various sanitizers and memory leak checkers like Valgrind. For other languages, other tools may be available. For real test flights, you can also simulate various weather conditions by using different network conditions and performing fuzzing tests with various inputs. Okay. Can you still see the poll and the responses? Yeah, so what kind of tests do you work with? So developers have these tools available while working on changing code. First compilation, then writing and running the unit tests, and then the simulated integration tests. And it's also possible to run some of these physical device tests from pull requests in GitHub. Then code is pushed to the main branch, and the entire process is repeated. The deterministic tests are then expected to be completely green. But the physical device tests will have some small amount of failures due to real-world issues. This needs to be analyzed, and we have good tooling in place for that. Imagine then if anything in this pipeline turns red, then we have efficient breaks, and thing needs to be reverted. So, okay, our software is now ready for deployment. It will be under the stress of the real world with real users and real networks. How can we know if how we tested it upfront was sufficient? So this is how we do deployment for video conferencing devices in Cisco. We first deploy to internal users. So, eat your own dog food is an important mantra. The idea is that if the product is good enough for our customers, it should be good enough for us to use in our daily work. We use our products with fresh software extensively, ensuring that we actually use the software we create ourselves. We care for our solution and provide feedback on early deployments. Then it's the early adopters, and the rest of the world gets software every month. So how often do you deploy to your customers in your development organization? It's working. Okay, so seems okay. Yeah. So now I would like to take a step out from the software world, and let's have a look at this beautiful fabric. It's fabric for furniture. Are anyone familiar with the term martindale? What it means that this fabric has 60,000 martindale? No? No, it's a unit for the durability of fabric, according to the amount of times discs can oscillate sandpaper across the fabric. So I found this cool. I wanted to show you. Maybe I can play this video. Am I able to play it? No? No, I'm not able to play it. Sorry. We'll continue. So we do stress tests in our lab. At the same time, the real answers is hard to get before code is deployed. So in the book Release It, Nygård introduces longevity, I think it just means long time, as a system's ability to operate according to spec for a long time. The only time the device the devices are expected to reboot is when we deploy new code. Our customers may postpone upgrading of software for several months. A video device should therefore be able to operate according to spec for several months without a reboot. This is a tough requirement. You need to have control of memory leaks, data growth, and ensure the system remains in a valid state throughout this period. If a device should crash during this time period, it will send data back to us so that we can be made aware of issues. I assume that we all experience unresponsive software from time to time. The only solution is often to turn off and then on the equipment to get it working again. You are familiar with this? It shouldn't be necessary. To understand how we are doing when it comes to stability, we need feedback from devices out there in the real world. We need logs and metadata without compromising customer privacy. So all groups on these deployment channels, they send logs and crash reports to help us monitor and improve the software. Legacy code. What do you think about when you hear the term legacy code? I have heard several definitions. Code that someone else has written, or old code, or difficult to change code that we don't understand, or code that no one dares to change. I learned about this definition some years ago, that legacy code is code without tests. Given this definition, I think that even today, 20 years after this book was published, new code is created that is instantly legacy. Sometimes the reason for this is that the part of the code you are working with is really hard to get under test. Writing tests for existing code that was written without testing in mind is hard. It's challenging to walk the talk when it comes to adding tests for all code when you work in a legacy code base. So we need a lot of tools for software quality. So first, these steps. We compile, run unit test and simulated integration test. We run on real device integration tests and internal deployment. And finally, out to customer deployment where we collect data. So to summarize, add tests from the beginning. Incorporate testing as an integral part of your development process from the start. Check your assumptions. Collect data from the real world to validate your assumptions and ensure your software behaves as expected. Strive for high quality feedback. Aim for clear, actionable feedback both in your tests and from real world data to continuously improve your software. Thank you.
Thank you.
Say a few words to see if your mic is working.
Yes, can everybody hear me? Is this volume okay? Great. Let's do this quick test. Turn this on so I know it works. I have.
Want this one?
Oh, I can switch to this one. I just brought one in case. Do you have an USB that's free for me? Perfect. And do we have slides? We have disco. We have slides. Let me see. Yeah, this is
Then you
Keynote.
can just present and then it asks you to stop mirroring.
Oh, how do I do that?
Oh, good. I just got that tip.
Wait.
Maybe you.
Let me. Okay, let's escape. Why? Okay. Maybe this will work. No, it's not showing. Let's
Go use the display setup.
yeah, sorry.
Play slideshow.
But I need my the center view. Okay, what if I do like this? Will everybody see this now? Or the slides? It's not working. Yeah. Oh yeah, it's probably mirroring.
Yeah, exactly. So then, okay, click on this one.
Stop mirroring. Okay, now it should work. It's still not working. Okay, do we have like 1 more second to try it or? Can I?
But it's 2 screens, so something is on the other screen.
Something.
So this is the audience view. It shows
Yes.
something else. So if you drag it over there, okay.
Okay. And if we manage to plus play?
The green thing.
Okay. And where did my? But I still can't see my presenter view. Okay, let's wing it. I guess we just have to run.
Okay.
I don't know.
Does it work without slides? Without the notes for you?
Probably it's not going to be as good, but let's do it.
Thank you. All right.
Okay, we're having some technical issues, but that's okay. You're going to see everything. I just don't have my notes, so we'll wing it, but it's going to be fine. Welcome to this short journey with mob programming, or I should probably say software teaming, because both in Norwegian and English there's a push to move away from the term mob, because it has some negative associations with it. But it sounds fun in Norwegian when you say, let's go mobbe. But I'm going to try to stick with software teaming throughout this talk, but I may use them interchangeably because we called it mob programming when we worked with it in my team. I'm Helén Persson. I use the pronouns she, her, they, them, and I have a master's degree in high-energy particle physics, which is just a fancy way of saying that I did data analysis trying to solve the universe mysteries. No biggie, no biggie. And it wasn't until I started university that I learned that I liked programming. And I remember sitting in my first programming lecture, my first year, and the professor asked, how many of you have programmed before? We were 300 students in that class, and about half of them raised their arms. And I was going to myself, okay, I'm gonna fail. That's a great way to start university. But it didn't happen. I passed, and I found out that I actually like programming. I enjoy working with it. So I chose as much as I could into my degree. And when I finished university and I was thinking about what do I want to do for work, I knew that I wanted to do something with programming. And I thought I was going into data science, but an opportunity turned out to be a front-end developer. And I took it, and I love it. And being a developer is kind of like being a physicist, actually, because I get to solve problems with programming. It's the same thing I did in university. And now I'm a front-end developer at NRK, where I work on internal systems for archiving and publishing radio shows and podcasts. And imagine this scenario. You're in a meeting, and you're discussing shapes, because shapes are very important for your client or your users. But you don't go into details. You just say shapes. It's a good word. It covers everything. your team may be left with different ideas of what a shape is or what they're supposed to build. And when they leave this meeting, if they have these conflicting ideas, it may result in some part of your team having to rewrite their code, do double work, because you didn't talk it through. Software teaming is a possible tool that can help alleviate this. And why were we doing software teaming? Well, we have this system that is a special program that only lives on special computers. PCs, no Macs, only PCs. And you have to use that to get your audio for your podcast into our system. Okay, so if you edit your podcast on a Mac or a non-special PC, you have to transfer that audio file into a special PC, use that system to get it into our system so it can go out to the audience. Sounds kind of tedious. We need something new. So we were tasked with changing this and make a new entry system for audio on podcasts. And it involves our entire tech stack, both front-end and back-end. So it's a perfect opportunity to try out software teaming. And the idea in software teaming is that for an idea to go from your head to the computer, it has to go through someone else's hands. And before I move on further, I want to just ask quickly, how many here have heard about mob programming or software teaming before? Okay, a couple of you, good. How many of you have actually tried it and used it yourself? Still a good group. That's great. So the next part, you can relax now. It's going to be a little bit of repetition for you guys, but just so the entire room agrees on what we are talking about, I'm going to run through quickly how software teaming might work in practice. So there was some cute cats earlier today. I don't have my own cats, so I had to make some. But I fully support cats on slides. And in software teaming, you work together. Everybody that's needed is in the room, and you sit around looking at one screen and share one keyboard. And the group member that's currently holding the keyboard is the pilot, or the driver. And the rest of the group are called the navigators. And the pilot's job is to type in what's being said and proposed from the group of navigators. And the navigator's job is like being a map reader. You have to tell the pilot where to go, what to write, and how to write it. And these roles, they rotate in the group, so everybody participates in every role. And you have kind of quick changes. Maybe down to a couple minutes of being pilot and then you change again, or longer periods of time. Depends on what your group thinks is most efficient for them. And I like lists, but there's only 2 lists in this slide. Here's the first one. Software teaming 101. Okay, we know pilot navigator, that's mostly what you have to remember, but everybody participates all the time. This doesn't mean you have to have an opinion about everything or you have to be mentally present all the time. It's okay to zone out. It's okay to zone out now as well, if you heard this talk before. I'll tell you when you have to come back. But the main part is that everybody's there when they're needed. And this one is really hard, but it's something you have to practice and figure out how to do. And it's say the right thing at the right time, the right way. Because when you're working in a group, it can be kind of intense. And you're trying to have focus on maybe line 15 where you're working, and then one in the group sees an error on line 30. And it's really tempting to go out and be like, hey, we're missing a colon on line 30. And then you shift the entire focus of the entire group and maybe breaks the flow that they're in. And then you have to go back, but wait, what were we actually doing? So to figure out how to say what you need to say when you need to say it is a task that everybody needs practice on. Work together, and with this I mean create issues, solve issues, discuss, create ideas together, as long as it's feasible. It's okay to break away, maybe have some alone time with gathering ideas, and then you come back to the group, and then you can pick the best from everyone. Oh, I like this part from this idea, and I like this part from this idea. So Having time apart is okay, but most of the work should be done together and decisions should be made together. Create good habits. It's like, shouldn't have to tell that to people, but it's still very important, so it's on my slides. Because it's hard to get into a good rhythm, it's hard to find good habits. And sometimes when you work closely with people, they annoy you. So you just have to figure out a way to deal with that doesn't break up the group. And now we have enough to embark on our journey together, but also my team's journey with software teaming. So we started out 6 people. None of us had ever done software teaming, but how hard can it be? We understand the concept, we know what it is, we've heard about it. Well, you don't. You don't really know what software teaming is until you tried it. And we spent a couple of weeks feeling like we didn't get the hang of it. It was really hard, so we had to call in some experts, and we're lucky to have that at NRK, some software teaming experts. So they came in and helped us a lot, gave us some tips and tricks, and I'm going to share some of them with you during this talk. So when you go out and try software teaming yourself, maybe you can avoid some of the blunders that we did. In a group, it's always going to be discussions or conflicts. And it's tempting to just say that the best way to resolve them is the golden middle way or the golden mean. But is that actually the best way all the time? Let's say that your group is discussing how long a piloting session should be. Like, how long are you the pilot? Someone maybe wants 5 minutes. Another in your group wants 10 minutes. Okay, we just split it. Let's go in the middle with 7.5. And now you may end up in a situation that actually doesn't work for anybody, doesn't feel good for anybody. Because what it turns out you needed was 10 minutes in the morning when everybody was feeling rested and had their morning coffee and was happy. And then in the afternoon, you could switch to having 5-minute sessions because you needed the quick change to keep everybody engaged and on track. And finding the flow in a group is hard. We were a group of 6. That's maybe a little bit too many to do software teaming, if I were to be honest. I would say 4 and 5 is optimal. 6 works. It's just more people that have needs you need to figure out. But one of our biggest problems was tasks outside the project, because we didn't do this full time when we started. And when you've been doing software teaming for 6 hours and you come out from that meeting room and you're kind of deflated, it's hard to pick up another task and do that for the rest of your day. So we solved this by moving our focus almost 100% to this current software teaming task and letting non-critical tasks just wait. We were doing this for a month. It can wait. It's okay. And we also learned that if needed, some people can break away from the software teaming group and solve critical issues. It's not a problem. And we lost a lot of time and flow and momentum in changing pilots because we were only doing this for a month. So we thought it's easier for all of us if we just use our own laptops, so we don't have to find a keyboard and an editor setup that everybody agrees on. And that sounds okay, it's a short amount of time, it's efficient, right? And Git is your friend. You can just push and pull whenever you need to. Well, it's maybe not that efficient, because every time you're switching pilot, you have to make a commit. Work in progress, part 344, still not working. But every problem has a solution. And we started using mob.sh, which is a cute little program that lives in your terminal, keeps track of your Git branches, and with 3 easy commands, it helps you to just push and pull the code you need. It creates temporary Git branches for you. And when you're done, you just do mob done, and you get 1 clean commit for all the work that's done that session. And breaks. Breaks are good, but they are also bad. And if I were to do software teaming again, I would opt for more individual breaks, where you can leave the room when you need to, instead of having breaks after a set amount of time, because if you're in a flow, it's really disruptive. When it's like, ding, 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 timer went off, 15 minutes break. Oh, we just got started. Okay, everybody leave, everybody out. And then you have to start finding that flow again. And that's hard. And what is happening? Because we were front-end and back-end together. We were doing back-end things in Java, front-end things in JavaScript, which meant that at any point of time, some of us was working in a language that they don't use or don't understand or don't know. So we were spending a lot of time really trying to make sure everybody understood everything we were doing. That sounds like the ideal, nice place you want to be. But it's a time hole, sinks you down. You get nothing done. And the goal of this wasn't to make all of us turn into full stack developers when we were finished. So we had to learn the hard way. It's okay to not understand everything at every point of time, as long as you understand the main ideas and why you're doing what you're doing. It's okay for me to not understand Java in the backend. And time is of the essence. You never have enough time. And software teaming actually gives you back sometimes that we often lose as developers. We don't have to do pull requests because everybody's there. Everybody's watching the code happen at the same time. So you don't have to do pull requests, which means you don't have to spend time reviewing them, and you don't have to spend time waiting for your work to be reviewed. But there's also a downside, and that's the small, simple tasks that you think, oh, this will take me 5 minutes to fix on my own. It feels like it takes forever doing that in software teaming, because first you have to have your ID, then you have to explain it to someone else, and then they have to type it in. It takes much longer than just doing it yourself. But the good thing here is that when doing it in software teaming, someone may be able to say, hey, good idea. How about this edge case? Oh, you haven't thought about that. Okay, let's fix it now instead of waiting for a bug in production and then having to throw everything up in the air and fix it immediately. So there's good and bad with everything. And our biggest benefit from this is shared knowledge across our entire team. Because when you work together, you also share experiences together, and you get a better understanding of the pain points that front-end and back-end faces, and what they have to endure, and how our systems communicate and work together. And I'm not going off on a long tangent here now, but I just have to share a story from when I started working in this team. The back-end was working on splitting a text field into two. Sounds like a pretty simple task. Just split the text field. It wasn't, and it's not that I didn't believe my coworkers, like I thought they were doing their best, but I couldn't wrap my head around why is this taking months and months to split this text field. Well, now I know. I've seen the complexity of their system with my own eyes. I've felt the frustration of being pulled to almost a slow motion of technical depth and old good ideas. So now I understand much more what they're doing. And I also think that even if we're not doing software teaming every day now, it made us a better team in the fact that we now know how to describe our needs better when we are in meetings and discussing together, and we find better solutions because we have a common understanding. And a question that at least popped into my mind as a junior is, how is it going to be being a junior and a senior together in a software teaming group? And actually, it works out pretty nice. It's quite easy. And I would approach this question the same way as we had to approach the question of people knowing different programming languages. If you're working with something, and let's say the pilot knows how to write a function in that language, the navigators can easily say, okay, we need a function now, and the pilot knows how to do that. But if the pilot doesn't know, the navigators can simply change the language into being, okay, we need a function now. To write a function, you do this, or you type in this. And that's a great learning experience. And a little note or caveat or whatever you want to call it is, please let your juniors be active in the discussion. Let them have ideas. Don't shoot them down too early. And maybe try out their idea first, and then you can build with the seniors' experience on top of that, or show, okay, we tried this, turns out it didn't work, but it was a great possibility, it might have worked. Because sometimes, and I said I was a junior, so it's a little bit of like a clap on the back to us, but sometimes we have good ideas. Sometimes we're not stuck in the way things have always been. So listen to your juniors, but also guide them. It's okay to tell them, this doesn't work, or this doesn't work because this and this. And also, I must say, like a last point on this slide, sometimes new stuff happen in programming, and there's new ways to do things. So something that didn't work 5, 6 years ago, may work now. And they might have learned that in school. So really listen to your juniors. That's my point. And we're going in, reaching the final step, and that's planning. And I know that a lot of people, when they talk about software teaming, they don't talk about planning. But it was such a huge issue for us. How do we keep track of everything that needs to be done, big and small? How do we take all those things that just pop into your mind while you're working and keep them in one place so everybody knows that you thought about this on Monday when you're not here on Wednesday? How do we keep track of the things that we're not doing? Because when you're working on something, there's going to be something that you think, oh, this is really cool, I want to do this. But it's kind of out of scope. Maybe if we have time after delivery, we can do that. Well, our solution was pretty simple. This is a Lucid Spark board with Post-it notes. And this worked wonders for us. It helped us give a place, so each Post-it note is a little thing. And most of them, because we like to turn them green when we're done, are small things that we can do within that session. We try to split everything up to that. And then we can just move them around. Okay, we didn't finish this session. Okay, let's pull it and take it with us to the next. Or we kind of finished this. It's working, but it's not perfect. Okay, let's write a note that it could be an improvement and put it in the improvement slot box. And let's move on. And as I said in the beginning on this slide, I know that people don't talk about it that much, and I know that people that work full-time with software teaming doesn't necessarily plan out things to this degree. But for us, it was a super useful tool, and we had a very limited time frame that we were working on. So it was good to actually be able to say, this is off limits, this is out of scope, or this is something that the front end or the back end could fix on their own after we have delivered this work. And whenever I'm listening to talks like this, I'm always sitting there, oh, but how did it go with the project? You tell me all this stuff, but you don't talk about what happened. And I have to admit, we spent 2 months. We were only supposed to spend 1. And the first part, which we thought was going to be the easiest, took the longest. And most of this is because we didn't allow for time in our planning to learn software teaming. We just started off, thought, we'll get it down within an hour. We didn't. We had a lot of retros discussions about how we want to work together, changing things up, trying this thing 1 week, trying this thing another week, finding out nothing really works for us, so trying a third thing the next week. And that's okay. So if you're sitting here thinking, I want to try software teaming, but I'm not sure how to approach it, it's really easy to start. It's been said many times today, just do it. I like Egwene, we work together at the NRK. That's going to be my new motto, just do it. But also, give yourself some grace. Allow you for some time to learn. And then the product. It turned out awesome. So great. And now you actually can upload audio to your podcast from any computer, which is like amazing. So, and I think this product turns out better than what it would have done if we hadn't done software teaming. And the final takeaways. This is the second list I talked about. It's fun to try something new. It was really fun to try a new way of working, and we learned so much as a team just doing it for 2 months. And with software teaming, you get a common understanding of your code base, which means that you're not depending on that one person in your team that knows that one system, that knows how that integrated with that other one system. So it's a great way to spread knowledge around. And software teaming can be a great tool. But like all tools, it's good and bad. It's good because there are many people looking at the same problem, creating the best ideas. But I don't want to also just sugarcoat it for you guys. So I'm going to be honest and say that it also can be quite demanding to be in a software teaming group. And it doesn't work for everybody. So I think that being part of a software teaming group should be voluntary, should be an option, should be something you do because you think it's fun. And just know you're going to learn your coworkers to know a little bit more than you just do sitting in the office every day. And have time to plan for learning in the beginning. And what my last point is that rules are meant to be broken. I've shared my story or our story here today. Take away what you like, and there's really not one way to do anything, especially not software teaming. So in any group, you have to discuss how you like it. Even if it's the first time you're doing it, or you've done it 100 times and you're creating a new group, you have to take time to do the retros to talk about how you guys want to work together. And if it's not clear where I land on this question today, what do I think about software teaming? I think that if you're thinking about it, you should definitely try it. And if you want to discuss software teaming, programming, maybe particle physics, you can follow this link and find me on LinkedIn. Thank you for your time.
Thank you.
Yeah, thank you.
Now it should work. Can you say it?
Yes, maybe I can say something. Yes, it works.
Right.
That's great.
Can I plug it in?
Yeah. And the speaker view is down here.
Yeah.
Oh, don't
Yeah,
pull it.
this is
Be
like-
very careful.
Yeah. That's for the clicker. Now the clicker should work.
The clicker should work. It does not. No, that's okay. I don't care. Okay, so since we have had technical problems earlier, we're gonna go into the break, and that's amazing because I like it when things go wrong. Okay, so who am I? I am Ågot. I work in security incident response in NAV. So I am the person that you call when everything turns to shit. It's also a really bad day for you as a developer if my team calls and like, hey, we are from cybersecurity. Do you run this application? I saw that you were the last one to commit to GitHub. It's an amazing day for everyone. I drink way too much coffee. And I am passionate about preventing burnout in the tech industry, which is ironic since I am the largest stress factor that could possibly exist. And usually you have a picture of yourself here, like on the top of a mountain or something, but I usually stay indoors. I don't have cats, I don't have kids. So I put a picture of like the job I had when I realized that incident response is the most fun thing ever. And I censored away all the things I am not allowed to show. But yeah, this was the mood, like sitting around waiting for that phone, one of all of many phones to ring. And the old school phone, which is like down there, is if you're stuck in the elevator. It would be me that would say, yes, hello, how can I help you? And you're like, oh my God, I'm stuck. And we're like, don't worry. We will maybe come. And there's like an EU regulation about how long people are legally allowed to be stuck in an elevator. And that's 72 hours, so. Don't worry, it will be fine. I recommend this designating like one corner for sleeping and, you know. Yep. Okay, so why do I want to talk about documentation? And what does that have to do with anything? Okay, this is an actual screenshot from the NAV Confluence. It says, brukerinnsikt, like user insight. It's created by someone who has quit. In 2021, you can be the first one to like this completely empty page. How many of you have a feeling inside your heart right now that you have this situation at least once in your Confluence? There are way too many people, I'm gonna say. Because why does it matter? It's because if this happens, oops, your files have been encrypted. This is the WannaCry decryptor. So if you get the WannaCry ransomware, this is what's gonna happen. And then like maybe 5 minutes later, your phone is gonna ring and it's gonna be me. And if you don't remember how you set up your application and you didn't put it in Confluence, what do you do? Like, what do you do? You're fucked, that's what you do. Okay, so another example from life. This is bad, what do you do? Like your actual house is on fire, then what do you do? I mean, run out, it's good first step, and then what? Go to NAV, yeah, but you know. So something that usually is in every office and like official public building is this. It's an evacuation map. Because you all think that if you just look at this, you will be safe, right? But I can tell you right now, this is the floor that my office is in. And I can't reach that far, I think. But they put a steel door to shut off half the floor. So if you are in like the bottom half and you need to escape to the upper half, there's a steel door that is not in this drawing. So when the fire department comes and they're like, oh, it's like an open access, we can go, oh no, there's a steel door, which is a problem, you know. So who you gonna call? These guys. But what do they do to prevent burnout? Because they don't. Their actual job is to watch people die, for real, and they stay in their job. Why? Why do we, the largest stress moment in our job, is to maybe have downtime? For most of us, that's the worst that will happen. These people, if your house burns and they get a phone call that the hospital burns, they're gonna say, okay, bye. And they leave your house and they rescue the people in the hospital. And your house and your things and potentially your life will be lost that day. And they don't quit. Why? Like really, why? So here are 70. Huh? Maybe meaning in their job also, but you know, I'm not going to trash talk management in case they are watching this stream. But here are 7 things that they do that we, that includes me, needs to be doing. Okay. The first thing is to exercise. Because biologically, like your brain chemistry, when your stress rises, your ability to think goes down. Like that, if you don't think that applies to you, you've never been stressed in your life, and come talk to me later and I will help you with that. You know, that's so the first thing that happens is that you lose your ability to have like oversight and overview of like the terrain, like your surroundings. And if you exercise, then you will know what to do because you fall back on what you've practiced. And if you don't practice, you fall back on, I don't know. I don't even want to think about what you do if you get stressed and have not practiced. This is why we do first aid courses. This is why we do fire drills. And we should do the same. Like, what do you do if you think you have failover and you realize that you don't? When was the last time you checked that your secondary location site actually did catch if the first one fails? When did you shut off your server and check that it actually comes back up if something disastrous happens? If you didn't check, you don't know. If you didn't check your backups, you don't have backups. Okay, I'm really being kind of angry with you now, okay? Okay, and then use your daily events to practice your skills. If you have a small bug, what do you put in GitHub? Do you put fix the bug? Push. But I can guarantee you that the fire department, they don't have one single incoming phone call which is closed by just a phone call. They will document everything. Who, what, where, when. They will do that. And if you start doing that, then when everything goes bad and you have to call someone to help you, or someone calls you and like, there is something in your code, then you can go back and see. And when your stress levels rise, you will fall back that you know how, at least you know how to document. Okay? One thing you know how to document, you know. Okay, the third point, plan for 24/7. And I'm not saying you should have a 24/7 daily thing, but what do you do if the downtime starts at Friday at 2 o'clock? Then what do you do when you are still there on Friday evening at 11 in the evening? Like, what do you do? Who is gonna order food? Like, who is ordering food? It's not me. I have my plans, so what are you doing, you know? Which budget is the food coming from? Who is paying for it? How do people get home? The last train left at 9, like how do you get home? Like, what do you do? And someone needs to pick up your kids from daycare, you know, what do you do? And if you don't have thought about this before everything goes to shit, then you don't have anything. You have nothing. You know, when me and my team calls you and you are still there at 11 in the evening and I say, okay, you need to actually go home. Someone needs to go home and you need to do the shift rotation right about now. Who goes home? Who stays? Now, the downtime isn't fixed, you know. Transport of London recently had a cyber attack and it was 16 days that they only spent in the initial containment phase. Are you gonna stay at work for 16 days? Just to fix the first thing? I'm not, I'm going home. Okay, when your stress levels rise, you forget how you configured Kubernetes. I can guarantee you that you will not be able to figure out the special little trick that you had to do to get the legacy system talking to the new fancy cloud thing. You don't know that. If you didn't write it down in a manual with easy steps, you are not able to do it when you're stressed. Okay, and assist the new hire to be as self-sufficient as soon as possible. And this is connected to number 4. Because if you hire a new one, it doesn't matter if they're junior or senior.
or a consultant, or if it's me, you know, if you have a manual that will tell you, like kind of detailed how to do things, then they will be able to start working earlier. Everyone has started a new job, and the first week you just sit there and be like, I don't know. I mean, pretty much everyone has done that, but if they had like, this is how you set up, this is how you do stuff, this is how you get started. And also, if something really bad happens and you have to call, like I don't know, some company to help you with your incident response, what does it cost to have like 5 consultants sitting there being like, I don't know, just as a motivation for if you have a budget responsibility. Okay, cross-check that your map and the terrain actually is the same. Because the nice little thing that you wrote down about making the legacy system talk to the Kubernetes, that's like 2.5 years ago since that stopped being relevant. Because now there's a new trick that replaces that trick, but it kind of uses components from there, but also from there, and it's like you need to periodically check that your documentation actually fits your workflow. It doesn't, you can't only like, this is not regex, it's not write once to read never. It's actually write it many times and also check it many times. Okay, and this is the biggest one for me to prevent burnout. And I have speedrun this presentation so fast so you can go eat lunch after this, I'm just gonna say. The way we do debrief in tech is shit. There has been cases where like the cybersecurity or like the downtime, like the incident response people come in and are like, okay, so what happened? Oh yeah, that guy clicked a link, but he doesn't work here anymore. Yeah, we fired that guy. It's like, okay, but I kind of need to talk to him. Yeah, he's not picking up the phone because he's angry that he got fired. It's like, yeah, well, maybe that's not the best way to do things. And it's a lot of the time it can be about like assigning blame. And if you are in a team where you feel that if you do something wrong and if you push to prod and prod breaks, which can happen, and you are kind of worried that you're gonna get yelled at for that, just get a new job. It's not, just don't. But we need to not only care for the people who broke it in the first place, because that will happen 100%, but we also need to care for the people that fixed it. Because if you come in and try to help someone, you can get very stressed, and it's so easy to like go down a rabbit hole and think that, oh, it's actually the firewall configuration, or like, oh, there's something about that, and you miss like a huge clue, you know? It's so easy. And then you can feel responsible for not seeing that thing because you got like focused, because your stress levels, you know, what I have said many times, they are up, so you are unable to take in new information. And we also need to like actually go through what happened. And if no one has any documentation, if you didn't write anything on that commit message, if you didn't take some notes anywhere, it's gonna be pretty much impossible to retrace the steps, both how it happened and how we fixed it. So we need to like step up and actually care about each other. You know, hot take. Empathy, you should try. But we need to actually help people and care for them and make like an environment where it's safe to fail. Because when you call and I come down to your team to help you, I'm gonna be a little bit like, okay, let's fix it like I am now. But it's also a kind of we need to actually care for each other and be like, no, that's okay. It's okay that you don't know. That's like the thing that I do the most. I know exactly what happened. I have seen it, I know. But it's like, oh, what do you think happened? It's like every time I call someone and it's like, so yesterday at like 2, did you click something? I know, they clicked something. Every time they're like, oh, I don't know. Yeah, maybe you were like on the internet, maybe checking some emails or so. Oh, yeah, yeah, did you click? And they're like, no. And I'm like, that's okay if you don't know. That's what I say the most, but yeah. try to be nice. Because we need to not harass people when they do something bad. A little bit of harassment now that you're here is fine, but like if you do something bad, then I will not harass you. Okay, I have time for one question, because I decide we have, and none of you, I am here later. Thank you for listening.
You definitely earned that. Thank you. Thanks very much. All right. Lunch break until 2:30. Remember, so you go down the 2 stairs, and then where the glass doors are, to the left over the small glass doors, and then you file into the area where there's lunch. You should smell it. Please remember to return your dishes. Like when you go to the buffet, then around the corner, it's a bit hidden, this is where you return your dishes. Like in most canteens. Please do that. And I'll be back at 2:30. Thank you. (13:30) 1330. It's on the slide as well.
Yeah, that's gonna work.
Kind of works. Is that the sound?
Yeah, so I mean, it's not important.
It's not
Just
speech.
for-
Yeah. That should So we have enough space for everybody. I think we have to give it a few more minutes. Whoever is trying to call me should come to me now. So, what the fuck? How was the lunch? Good? Good? Okay. Thank you. Yes, find a seat. Yes, we have changed this adapter here. Let's hope this is a bit more forgiving when it comes to changing devices than the other one. We will have 1 more minute before we start. So, ja. Okay. Det for deg. Bare trykk nei. Det må skru det, så da det på.
Hei Ingrid.
Hei Snorre. Hei Ingrid.
Er du klar her?
Nei, men det går vel greit, gjør det ikke det?
Ja, kanskje vi bare sier det sånn?
Jo, vi gjør det.
Bra.
Jeg er veldig spent på om vi klarer å si det i kor. Det er kanskje det jeg er mest spent på.
Ja, det kommer ikke til å gå. Jo da, det går helt fint. Vi får bare styre oss.
Okay, then we're gonna continue. Please find a seat, and we are happy now to come to kind of a celebration already, kind of after the break. Pretty cool that you joined us to announce what do you think is the female developer of the year in Norway. Very happy to have Finn here again. You were here last year, this year again. Thank you for your support. And for also joining us in this mission to highlight a bit the people who are typically not on stage as much. Thank you.
Thank you. Hello, everyone, and welcome back from lunch. I see some of us still joining us. I am here today together with Ingrid and Helle to present the award Female Developer of the Year 2024. I'm very excited to be here, and by the people I've talked to, it's been a great event so far, so super to actually be allowed to do this. I'm also quite cognizant that I'm not perhaps the person you were expecting. I'm not a strong female role model. I'm a middle-aged white man, as my wife said to me. I'm also in a position of power. So why am I here? Well, I'm here because I believe that diversity is something that concerns us all. I strongly believe that diversity is something that concerns middle-aged white men, because we are key in shaping the future of tech. I believe that we have a key role to play in that we need to create arenas like this where diversity can flourish. We need to look for and find ways to systemically change the way we approach diversity and make sure that it sticks. And then we also have a key responsibility of highlighting the many role models we do have today, which is why I'm proud to also be here on stage with one such role model, Ingrid.
Hi, I'm Ingrid. I work as a developer and tech lead at NRK. and I've been there since 2018. And when I started university, I had never been inside a computer terminal. I had no idea what programming was. And I kind of like to think that I am a proof that you can still learn, even though you haven't grown up with programming at home. And last year, I won the Female Developer of the Year prize, and that is why I'm here on stage today with Snorre.
Thank you. So what is this prize all about? Well, at Finn, we have worked quite long to try and get diversity into our teams. We believe that it is a key aspect of any team that is building a product that serves the entire nation. Recognizing the need for an award to highlight strong female role models, we created this award in 2021. And the aim of the award is to encourage more females to take up careers within technology. And that
is going to lead us to the finalists and role models.
Yes.
Okay, so I'm going to read out the text for each of the finalists, and you will probably do the
I
click.
can do the clicking.
We haven't had a run through. We're doing it now. Okay, so first finalist is Hannah. Hannah is a full-stack developer at Turi Dig, and her technical skills and passion for inclusivity make her stand out. She has driven forward important projects, including complex integrations with HubSpot and Brønnøysundregisteret, and she's a strong promoter for universal design, and she mentors girls through Girl Tech Fest, a true role model.
Our next nominee, Silje Grimstad. Silje, who joined Capgemini in 2019, has taken on key projects like the Digital Career Certificate. She co-founded She Codes to support female developers and is a part of Capgemini's Accelerate program, constantly pushing for growth while encouraging diversity in technology.
Next up is Yulai. Yulai's tech journey is colored by her passion for coding and her dedication to sharing knowledge. She is a full-stack developer with a master's in informatics and her contributions to the Nordic Balancing Model program, which is a modernization of the power grid in Norway and Sweden, have been invaluable. In addition, her ability to solve complex problems, she also mentors new developers and lecturers at the University of Oslo, building a bridge between education and industry.
Torborg Ek. Torborg started her career as a software developer and has since then held several leadership positions. 2 years ago, she returned to coding, following her passion. Her ability to adapt, whether it's solving client challenges or mentoring others, makes her stand out. Torborg serves as an inspiration to many, and her journey shows it's never too late to follow your passion and succeed in tech.
And the final finalist is Ada Elise. Ada's tech journey is of the unconventional type. She is a full-stack developer who has successfully built her own company, Kodebonden, focused on website development, while also living on and building an actual farm. She has built a strong reputation as a developer while balancing family life. Her journey proves that with hard work, success in tech is possible from anywhere.
Now this is where we start to get nervous, not click too many clicks. Let's see.
Yeah.
And the winner is, one more click right on. This year's winner has really impressed the jury and made a lasting impact in the technology field. Starting as a developer, her problem-solving and innovation skills quickly stood out.
Over time, she became great at building relationships with clients and providing solutions that really worked for them. Her decision to return to coding highlights her dedication to her craft and passion for her work. We are proud to announce that this year's winner is
Torborg!
This is my first prize ever. Yeah, I can try to say something if you have time.
Yes.
I actually didn't prepare anything because all the others were so great, and I'm a little bit old. But thank you. This was great. The introduction and everything. Thought I was listening about someone else, and all the nominees were so great. So this is unbelievable, and yeah, my first prize. Thank you.
And then before we conclude, we would also like one last celebration of all of these great models. And thank you for listening. For those of you who are here, can you come up on stage, please?
Ja. Torborg? Okay. Oh. Okay, I have to. Hello? Yeah. So.
And one last round of applause. Hooray. That's it. Thank you.
Thank you very much. There is a few seats over there. There's a big hole there, so you don't have to stand there if you don't want to. There's also seats in front of here. And then, yeah, we'll have Ruth.
Hello.
Yes.
Testing.
All right.
There. I have. So, hello everyone, and welcome to my talk. So, when I first got the question if I wanted to have a talk today, I thought that I don't really have time for it right now. And that was, of course, because a new World of Warcraft expansion had just released. So, after some consideration, I thought that, what if I combined the two? What if I created an add-on for World of Warcraft and then presented that on the conference? So that's what I did. A little bit about me. My name is Ruth Merethe Granevang. I have a Master of Computer Science. I've been a developer since 2005, and I won the Female Developer of the Year in 2022. I currently work at Aschehoug as a developer, and I have a special passion for programming and creating educational games. And this is my homepage. So, what is an add-on? In World of Warcraft and a lot of other games, you can add some extra utility to the game. And in this game, you cannot modify the existing logic and rules, but you can add something new. You can run scripts, You can add UI elements. And some examples of popular add-ons are, for instance, tracking damage. Everyone likes tracking your damage and competing with your friends to see who is contributing the most. You can update your health bars to only display the most important things. And you can have warnings, for instance. So what add-ons should I make? I wanted to make something that added some value to the game. And it was important that it did not already exist, because then I could just download it and use that instead. And since this was about a month ago, it couldn't be too complicated, because I needed to be sure that I actually finished it and had time to make the talk. And I wanted to create something that I will use when I play the game. So what I ended up with was an add-on that will summon the right mount for each of my characters. So this is an existing UI in World of Warcraft. It is called the Mount Journal. And as you can see, this is a game that's been around for quite a while. It's actually 20 years old this year. So people have gathered up a lot of mounts over the years. And but I wanted to utilize my mounts and not scroll inside this list to find the perfect mount. They have also added a summon random favorite mount, but that wasn't quite enough for me, because when I play my warlock, I want her to be dark and have blue horses, or maybe purple or black. But when I play my druid, I want white horses and greens and nice things. So that's why I created this, and it's called the Mount Selector. You can press a button to summon a random mount. And if you are in a flyable area, it will summon a flyable mount. And for each of those characters, you can choose the preferred type. For instance, my Frost mage, she likes to ride on dragons or cats, but my warlock likes unicorns and horses. And the preferred color. And I also added some bonus functionality, that is this list of mounts based on type and color. And that little checkbox, so you can choose if you only want to use of your favorite mounts. The first thing I had to do was to learn how to code Lua. And that is the scripting language that is used in World of Warcraft add-ons. And it's a lightweight, efficient scripting language. It's embeddable, so it's easy to embed into other languages. It's dynamically typed. It has automatic memory management. It's free and open source. And it is used in several games for scripting game mechanics and creating add-ons. And some examples are Baldur's Gate, Roblox, The Sims, Path of Exile, and World of Warcraft. So here is some basic Lua syntax. As you can see, it's pretty intuitive and straightforward. There's a comment. You can print out to the console. You can define local and global variable. And this is how a function is defined and how it's called. And here is a normal condition. And there is one data structure in Lua that is used a lot, and it's called Lua tables. And it can hold any type of data, including functions. And the key can be anything but nil values. And here's an example with a number, string, boolean, and a function in a table. And you can extract the data by either using the brackets notation or the dot notation. And tables, they are references, so when the reference to a table is lost, the data is garbage collected. And you can loop through tables using pairs. And you can also use tables as arrays. And if you do so, you probably want to use I-pairs, since that guarantees the order of the elements, unlike pairs, when you loop through it. And then you need to find a name for your add-on. And it is very important that it is unique, so it don't clash with other add-ons. So then you need to do some research, because there are a lot of different add-on tools out there. And so mine became Ruth's mount selector, because mount selector was a little bit generic, but Ruth is my in-game name. And then you create a new folder that should be in your add-ons folder. And it should represent the name of your add-on. And that must also be unique. And after that, you can create a .toc file that will define your add-on. It should be in the root folder of your new folder. And it should be named exactly the same as the folder, just with a .toc ending. And this file, it defines some metadata for your add-on, for instance, like version, title, author. And it also defines what variables you need to save across your sessions. For instance, what types or colors you have picked, and what files to include. And now I'm going to show you some examples from my add-on. So this is how I create the main frame. That's the frame around my add-on. And I do that by using the function createFrame. The first parameter is what type of frame. It could be frame, button, menu, and some other stuff. The second is the name of the frame. And the third parameter is what is it logically attached to. And the last one is if you want to apply a template to it. And I use the basic frame template with insets to make this nice cross in the corner and stuff. Then I set the size and align it right on the page. And I hide it to make sure that it doesn't pop up every time I start the game. And then there's several lines just for setting the title with a font. And I also like having my my windows draggable, so I can decide where it is on my screen. So therefore, on the title background, I added a script. So if you mouse down, you can move the frame, and if you release it, then it stops moving. And some data, I needed a lot of data for this add-on. I extracted the list of mounts from the game, and it was easy to get the name of the mount, the icon, whether it's flying or not. But what I couldn't find any data for, and what was probably the reason why this add-on did not exist already, was I couldn't find what color the mount was, and I could not find what type it was. So I did a combination of two different approaches. I fed all the data I had into ChatGPT and let it guess what color and name, what color and type it had. For instance, if the icon name was like Blue Dragonhawk, then it could guess that blue was the color and maybe it was some kind of bird. But in the end, I had to do a lot of manual checks and to create data. And this is the data format I ended up with the name, ID, spell ID, icon, type, and color. And here is how I created the filter dropdown. So you can press the select colors dropdown and then choose one or more colors. I used the create frame again, and here I used the UI drop-down menu template and setting a width on it, and then aligning it on the screen. And then I use the UI drop-down menu initialize that makes me, I can send in a function that will initialize the drop-down. And so this is the function I sent in. Thank you. The self here is the actual drop-down. Then I create a local table called info, and I'm using the UI drop-down menu create info function to create a basic template for it. Then I'm adding a function, and this function is what is run when you click the button in the UI. Then it selects the color, saves it, and re-render the list of available mounts. Then first, I added the all button. It's called buttons, all the items in the list. And I set the text, the value, and if it's checked or not. And then I use the UI drop-down menu, add button, to add this to the list. And so I loop through all the colors, and I reuse the info table, but I'm changing the text value unchecked for each of them. So, but the function is still the same. And then I add the buttons. And here is how I get the available mounts data. First, I'm creating a local variable to store them. And then the cmount journal is an API that has a lot of methods regarding mounts. And this basically loops through every mount in the game. And then I use some functions to pick out all the data I need. I had to use two different, the get mount info by ID and get mount info extra by ID. And then I check, is this mount usable by this character, and have the user collected it? And should I consider whether it's a favorite or not? And if that is true, then I fetch the hard-coded data, my data that I built, by the find mount by ID function I have made. And then I basically merges the data from the game with my hard-coded data. And here is how I create the summon button. And that's this button that will actually do the summoning of the mount. I do use the create frame again, and this time a button with a button template. I set the size and align it, set the text. And then I add an on-click script to it. So if you are mounted, then dismounts. Otherwise, it reloads all the mounts and then summons the correct mounts. And then I clear the key bindings to be able to set a new key binding. So the user can select a key. Here the value is Q. So when I press Q, it will trigger the random mount button. So I can use Q whether or not this frame is visible. And then it was time to publish the add-ons so people can download it. Right now I have 117 downloads or something. So, and I picked CurseForge because that is the add-on manager that I use. And there I had to create a project, add an icon and a description, upload some screenshots, and zip the folder containing the add-on. And it was important to get the folder also and not just the contents of it. And there was an approval process. The first time it took a couple of days, but after that, every update it took just a few minutes because then they run some kind of automatic check that just checked that the file formats and stuff were okay. And here's some resources that you can look into if you want. And if you have some trouble, I would recommend going to the Discord server that is here. They help me out a lot. So, yeah, thanks.
Thank you. You actually have time for questions if you want to take some. Okay. Then Ingrid, you're back.
Can I also get a glass of water?
Yes.
Thank you. I'm good. Okay, sound is on. We will not get sounds on the speakers, but the closest of you might hear a little bit of sound in the beginning of my presentation. Let's see. No. Okay, raise your hand if you felt a little bit nostalgic right now. Yeah! Okay, and raise your hand if you have missed Internet Explorer. Okay, none. That's kind of good. So this is NRK TV in Internet Explorer, and that's okay. Because in January 2021, we decided that it is no longer supported. No surprise, because we wanted the developer experience to be as best as possible and not be limited by a very few amount of users. However, I haven't shown you what nrk.no looks like in Internet Explorer, and I'm going to save that till the end. And in the meantime, you can think about how many stubborn individuals are still using Internet Explorer to browse the news at NRK today. Okay, but first, small step back and introduce myself again. Hello, my name is Ingrid, and I work as a developer and tech lead at NRK, and I have done so since 2018. Today, I'm going to talk about how you can become a slightly better web developer. For whom, you might ask, because I hadn't even thought about that this could be a biggest question. For your users, of course, or brukere in the region. Because this is the reason that we create products. And I think that as a developer, it's easy to create solutions that work best for yourself, because it's your computer. But I also believe that if you actually think about your users from a technical perspective, your product will actually improve. A little fun fact then. When I was making this presentation, I needed an illustration, and I went to Google and I wrote brukere, and this was the first image that came up, and I thought, oh, that's great. And then I realized that the person in the middle with the orange sweater, that's me. Yes, okay, agenda. I will start to talk about why I care about this, and then I will talk about how internet users use the internet in 2024. And then I have tried to make some questions you probably should think about when you work as a web developer. And the goal with this presentation should be that you learn something and you have some things to consider while developing. Okie dokie. So I mentioned I work at NRK, the Norwegian Broadcasting Corporation. You will not get more presentation than that, but these are our products. And I work at the team to the right, nrk.no, and we are the biggest single product at NRK. We have about 1.5 million daily users, and we are news-driven, but a broad entrance to all of NRK. So my reason to care about this is because we have very many users. And we are kind of required to say that our users, it's the whole population. That means from teenagers to old people. And that means that our products need to work for many people at the same time. But it's also quite okay that we are legally required to think about this, so we don't have a choice. The Norwegian Broadcasting Corporation is obliged to take special preparedness measures to ensure that information from the government reaches the population in time of civil emergencies and war. Wow. This means that we are equal to P1, the radio station, and NRK1 to deliver information to the people if something happens in wartime. In practice, that means we should always be available. So there are two things we need to think about with this. First, cloud. Front page of NRK.no is running on 3 different data centers, 2 in Azure, 1 in Google, which makes us redundant. And I'm not going to talk more about that. It's very cool. Come and ask questions later if you think it's cool as well. But the second part is what I am going to talk about today, and that is code. Because the problem with this is that it doesn't help if your application is up and available if you still cannot get the information from the page. So that means that the code has to work for everyone. And you might be thinking, what? That's not possible. And you're right. But I like to think about it that we have to do our best to always be available to as many people as possible. So this is why I care about this. And you might be thinking, but Ingrid, I don't have any specific emergency preparedness responsibility. That's a mouthful. So why would I care? And I think you should care because you hopefully have users. Hopefully not just white old men. But I hope that you kind of care about the users that they actually can use your site. And that leads us to, but how do the user use internet in 2024? And there are several things worth considering here, because many of our users use technology different from us developers. We're starting easy. This is statistics from global statistics from StatCounter for the last year, and this is how users use between mobile, desktop, and tablet. Tablet, not so many, not growing, not declining either. Desktop has been declining for the past few years, still declining. Mobile, ending for about 60% of our users. This is quite similar with our traffic at NRK. NRK.no, we usually say that we have 70% of our users on mobile and 30% on desktop. But recently we have started saying 80% on mobile. That means that if you make an incredible desktop experience, almost no one will see it. Kind of depressing, but also worth noting. Okay, so I say that they use their phones to browse the internet. What does that really mean? Bit curious, bit naive. I went to Power and checked what's the cheapest and most expensive phone right now. I found these, both Android, both on sale right now, about 20,000 Norwegian kroner in price difference. And how do you think a website is on one device compared to the other? I kind of hope that it's better on the one to the left, because I hope you get something more than just being able to fold your phone for 20,000. And where on the smartphone scale do you think us developers usually are? Do we have more fancy phones than the average person? I think so. And these are new phones. How many here has a phone that is more than 3 years old? Yay! 5 years? Yay! Okay, someone, but very few. And you're thinking, maybe you're thinking, but this doesn't apply to me because I'm a web developer, I work in the browser. Okay, so we're going to move to the browsers then. Most people actually use the pre-installed browser they get with the device they purchase. I mean, it's insane, but it's true. And nothing wrong with any of these, except I would not use the 2 ones on the left. And people also ignore notifications to update. And they might not differ that much from developers because, well, this is a screenshot from my Chrome when I made this presentation. And just so no one feel left out, if you're a pleased web app developer thinking, oh, it doesn't apply to me. Yeah, it does. Most people don't update their apps, and the apps also use the browser on the phone, which is probably the pre-installed browser. Okay, back to browsers. I have so far told you that people don't update their browsers, and I thought I should add some statistics to prove this is correct. So this is from NRK.no. Most users use Safari, and then Chrome, and these down here, that's developers. And if we have a look at Safari, you see most people use Safari 17. That came out last year. So we still have 4.38% using Safari 16. And you think, that's not that many, is it? Well, for us, that's 65,700 daily users. That's quite a few. And then you think, but Chrome's different. Kind of is, because people are using multiple versions here. Look at this one. Chrome 56. I had to Google. It was released November 17, 2016, 8 years ago. And we have 2.18% still using it. Is that a lot? That's 32,000 users daily. And does it really matter? Maybe, maybe not. But the problem with browsers is it's usually differences between the browsers, but also most browsers are not backward compatible. So that means that new features you create in newer versions of your browser will probably not work in this one. And that can give you a headache. And since we have talked about browsers and devices, I also need to discuss data usage. The average person used 4.83 gigabytes per month in 2020. I cannot decide if that's a lot or not. But I think it's worth noting because that means they don't use very much data as well if they browse on their phone and if they're not at home. And okay, I don't like to use examples that aren't ours, but this is from Podtoppen, and they had put this very big NRK logo at the bottom. So I thought, well, okay. If you wonder which podcast is the most listened to or least listened to, you can go here. And if you want to go all the way down to the bottom to find out which one is the least listened to, you have used 557 megabytes. And if you don't know if that's a lot or not, that's half an episode of Game of Thrones. Or, if you want another comparison, that means that if you have had this discussion 10 times in a month and checked, you have used more data than the average person in a month. And then, I mean, it's kind of nice to put on the front page of NRK.no. We do not have 1,000 images, but we're still doing 6 megabytes. And maybe you're thinking this isn't important to you, because my users are at home, they use Wi-Fi. What if they are not? And we're not talking about Monson traveling through Alaska. But maybe you want your users to be able to use a product while working from their cabin. Or what if they are on a train in a tunnel? And it's worth considering that what works very good on a poor, bad device is gonna work great at a good device under special conditions as well. And suddenly it matters how big your page is. Okay. So I said I was going to have some questions you can keep in mind when coding, so we're going to go to that section. We will start easy and with the hardest. Who is the product designed for? What is your main target group? Usually it's never teenagers and grandmas. It's usually somewhere in between. But if you are creating an internal system for developers, you can probably assume they have good computers, good Wi-Fi, good phone bill covered by the employee. Like us, we have at NRK.no, the front page editor CMS is created only for Windows with Chrome, because we know exactly which machines they are using. Usually don't have that luxury. But if you're creating a product for young people, it's worth noting that they usually have a quite good device with cracked screens, and they are super greedy with data. So they tell us they don't want to check the news because it takes too much data, but they gladly watch the news on TikTok. Okay, once you know who you're creating your product for, you can start about thinking, what can or should I use? And this is like the most frustrating slide, because I want to put so much here, but I picked up something you need to think about. Starting with framework, size, speed, server-side rendering, those are the most important for me at least. But also important is the support for functionality. In other words, can I use CSS container queries now? It's not new anymore, so I should be able to. For us, we rely on functionality over browsers. That's why we kind of don't say, do we support Internet Explorer? That's not interesting. It's interesting to see, can I use this functionality, yes or no? And we do that by combining caniuse.com, browserlist config, and auto-prefixer. And if you haven't seen caniuse.com, it's where you can look up CSS and JavaScript features and check this. What you can do, this tells you which browser is supported for each functionality and from what version. But what you can do is, if you have collected your own data, you can mount this in and you can actually see my users support this functionality with 95% coverage, for instance. Okay. We have chosen what we want to code in. Now we have 2 goals. 1, we want the best possible developer experience, otherwise no one will do the job. You cannot write old JavaScript just because you have users with old browsers. Secondly, how can you make the user experience the best for the most people while also fulfilling the other premise, good developer experience? So for us, we do polyfills and we have thresholds for them, which means I probably have to just mention what a polyfill is. Because I mentioned browsers are not backward compatible, so if you want to use new features in the browser, you need to have a polyfill for that for all browsers. And you might also transpile over JavaScript. But I'm not going to talk about that. The problem with this is that you get extra code to the old browser to make it work. So the people sitting on old bad devices are now getting even more code to make your code work. Seems kind of unfair. They were on the slow devices in the beginning. Okay, but we do have that. And to try to make up for it, we try to do it dynamic. We don't load polyfills if you don't need them. I mean, you could need polyfill for a page, but you don't need it before it's actually where the user is scrolling to. And the same comes with content loading. You don't need everything to play a video if the video is not even near the view. And that kind of leads to the next question. How can I load as little as possible? And then we need to talk about caching. Or we don't need to, but I want to. Because the goal of caching is to avoid unnecessary data loading at least more than once. And we do caching at different levels. That is quite relevant for a web developer as well. We do element caching. For instance, if you have a widget on the front page, it's cached different from the rest of the web application. We do JavaScript splitting into different files, and then we cache them on versioning, so that if you do some JavaScript changes, only some of the files will change, and the others will still be loaded from the cache. And I said size with frameworks, but because if you do choose to use React, I mean, I like React, but it's huge, and you decide to send it to the client, you should cache it. And you should not load it on every page load, and you should absolutely not care if they have different patched versions, so that people get new versions of React based on how they're browsing your web application. And of course, if you can, server-side rendering with hydration and caching makes everything better for the user. Okay, yes, we talked about how users are on the internet, and that leads to the last part, to figure out how is it to be a user of mine. Because I have already said that everyone has not the same phone as you, the same number of, the same browser, and might not even have the same data in the month. So to figure out how it is to be a user of yours, you should test the product as a real user, or you could rewrite that and say, test the product as a shitty user. And DevTool is your friend. Reduce network traffic, toggle caching, CPU. I mean, it's so much fun you can do. It seems like you're sitting on a bad computer after toggling some things there. And if you have testing virtual browsers, some free, some quite expensive, but if you have them, do them both with automated tested and manual testing. Okay, so anyone care to guess how many stubborn users we have that still uses Internet Explorer to read the news? Yay, 5,508. Is that a large number? I don't know. I think it's large because I can't believe what world they live in. But the percentage is still so small that we don't have to. We're not obliged to make it work. But for them, I'm going to show you what it looks like. Oh. I imagine everyone has the sound on when using Internet Explorer. Yeah, someone said to me that the reason they still use it is because it works, and that might kind of be true. You see that some things are not working, and that's because we don't make a lot of effort to make it work, but so far it is working, and we're not going to remove it just to remove it. That would also be kind of stupid. And if you wondered, do Internet Explorer need any polyfills? Yeah, it needs all of them. Summarizing very quick. Keep in mind, who am I making the product for? What canon should I use? How can the user experience be the best for the most people? How can I load as little as possible? And what is it like to be a user of mine? Yes, thank you.
Thank you very much. I see there are some free places there, so you can come in. Quickly come in. Please make space there in the middle. Remove that so that people can move in. Thank you very much. Again, we are fully booked. Maybe you should put that sound on the Internet Explorer users when they open up AdaCon. Sarah. Ah, there. I have to turn off the mic. Can you lift up your hairs?
Yeah, like this.
Okay, like this. Okay. Yeah.
Yeah.
Good.
Could I also have a glass of water?
Yes.
Yeah, hello everyone. The next 20 minutes will be about dataviz accessibility and what we can do to make our data visualizations more inclusive for everyone. A bit of background information about me. I'm Sarah Fossheim. My pronouns are they, them. I'm an independent accessibility specialist, also with a background in front-end development and UX design, currently located in Oslo, but soon moving myself and my business to the very north of Norway, to Varanger. And to start a conversation about dataviz accessibility, I'd like to show you what the state of it is these days, with an example of a chart that I found related to the upcoming US presidential elections, where a news outlet ran thousands of predictions to check whether Kamala Harris or Donald Trump would win, and then visualize those in a scatter plot. And the demo I'm going to show is me using this with a screen reader and checking what the experience is like. And it's very similar to how a lot of graphs sound like when I test them.
Harris wins 55 times out of 100. In our simulations of the 2024 presidential election, Trump wins 44 times out of 100. There is a less than 1 in 100 chance of no electoral college winner. Figure calculator PNG image. Harris 555. Trump 441. No winner. Plus 4. 1000. Simulations. Harris win. Trump wins. 1 simulated electoral college outcome. Image. 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 No winner. Image. 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 Image.
So I'll stop it at that, but for those who didn't hear it because the sound isn't working, the screen reader read every single point on the chart, so 1,000 points, image, 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 image. And that's of course because the developers tried to turn those elements into something usable for screen readers, turned them into images, but forgot to add the alt text. Or maybe they tried to add the alt text, but there was a bug in the code, so it didn't come through on the actual live version. And it gets this way because of the code, and it's very easy for us in the field, both as accessibility testers or as developers, PMs, designers, to just all blame this on the developer who wrote this one component or this one chart and be like, hey, you didn't add your alt text, what kind of a stupid developer are you, kinda. But what to keep in mind is that this isn't a code issue or it isn't a developer issue. When I see something like this, I also ask myself, did the designers do some research about what a chart like this should be like, what the experience should be like for a blind person? And did they communicate this and document this for the developers who will be actually implementing this into code? Did testers catch this? Did this even get tested with a screen reader? What's the process if the tester found this issue and said, hey, all those points are announced as an image? Did someone follow up on that? How do those fixes get prioritized? Does time get set aside throughout the process to plan for accessibility, to have this conversation? And also, is this part of our school system or our education system? When we go to conferences and we learn on what we can do to make our code better, is there any conversation about accessibility there? Is there any training budget when people want to go to conferences or go to training to improve their web development, dataviz skills? Do companies actually prioritize accessibility in that training budget? Will you be able to get a promotion if you choose to go for accessibility training rather than for performance training courses? And were people even aware that this type of bug can happen? To me, accessibility is much more of a culture and process issue than a specific code issue, design issue, planning issue. It affects everyone that touches your products in the process. So it's also important that, like, if you're sitting here as a PM or you're sitting here as a designer or a developer or a tester or as a CEO, like, there is going to be something in the world of accessibility you will have to do in order to make your product more inclusive. And when we talk about accessibility, I do want to recap a bit what it is we're talking about. And mostly when we talk about accessibility these days, we talk about web accessibility. And especially with companies who have offices in the EU, the past year, the conversation has been a lot around the European Accessibility Act and a very dreading deadline of June 2025. And this is important for a lot of EU companies because it's a law that says that all products have to be accessible for people with disabilities. And if not, people can actually file complaints and sue the company for not being inclusive. And of course, here in Norway, we already had laws like this from before. In fact, when clients approach me and say, hey, do you want to work with us on accessibility? One of their first things they ask is, do we have to comply to the Norwegian law system? And can you avoid us getting sued over this? And what the Norwegian laws say is that the private sector has to be compliant with WCAG 2.0, A and AA compliance. And the public sector has some additional requirements about what you disclose on your website and also has a newer version of WCAG to comply to. I'm not going to go that much into compliance these days, but I do want people to be aware of it, that when you are building a product, it is actually important to think of accessibility for more than just the users. You can get in trouble yourself as well. And in this, I keep referring to the Web Content Accessibility Guidelines, or WCAG, which is also something that if you start looking up accessibility online, you're going to come across this document a lot. And This might look quite intimidating to you, and it definitely looked intimidating to me the first time I wanted to get into accessibility work, and I opened this document, and I was just presented with text upon text upon text. So what's important for you to know here is that this has principles, which is things like that your content should be perceivable, it should be operable, it should be understandable to everyone, and the code you write should be robust. Then you can find more information about specific guidelines that you should adhere to, and then the actual success criteria are testable criteria that you can check. Does my websites include those things? And something fun there as well is that there's two small links that are very easy to miss: understanding and how to meet. Those for developers and designers that are implementing the work, there's a lot of information there on what kind of techniques you can use in order to make sure that, for example, an image is announced to people using screen readers. So when we talk about accessibility, we're often talking about alt text and about sufficient contrast, or about using HTML elements, so those are very specific things. But there's one important thing that I want us to talk about as well before we continue to dataviz, which is that accessibility is not just about technical specs. It's not just about testing or getting audits done, or about reaching compliance, or about doing work to avoid getting fined. It's very much about including people, and more specifically about including disabled people. My screen stopped working. There we go. And in Norway, almost 400,000 people are on NAV uføretrygd, so on support from NAV because they are disabled. Worldwide, around 15 to 25% of the population has reported to have a disability. The 15% is if you check the World Health Organization data, the 25% is based on self-reported disabilities, which is around 1 million people in Norway, around a fifth of the population. So it's a quarter of the population, or 1 million people in Norway, that are being excluded or facing barriers on the majority of websites and the majority of data visualizations. In 2020, WebAIM did a survey to check the accessibility of the web, tested 1 million websites, the 1 million most popular ones, and found that 98% of them have accessibility errors. And it was around 60 errors per page or something. This has improved to this year. Only 96% of websites have accessibility issues, so we are making some progress there. So how do we include all of this into dataviz? Are there any people here who have worked with data visualizations before, like implemented a chart? Yeah, quite a bit. All of you are actually accessibility designers, accessibility developers in a way. Because to me, dataviz, it's a way of implementing accessibility. We create visualizations to make the underlying data more accessible. If I show this table where stores of Walmart in the US and locations of them, it's 5,282 rows with every location of Walmart added. If I ask you, in which state are most Walmart stores located, you're probably going to have a hard time figuring it out from this data table, because you're going to have to look at 25 rows at a time for 5,000 rows total. But if I instead put this in a graph, now while I'm talking, some of you have probably already gotten the answer in your head. Most of the Walmart stores in the US are located on the East Coast. And more specifically, there's higher concentrations of them around larger cities. And I know that because of the amount of data points that are on this chart, I can see locations where there are more of them gathered. I also know that the size of them relates to the amount of stores in a city. So the larger the hexagon, the more stores. Also the coordinates, this is maybe something that happens a bit more subconsciously, but I can, for example, locate LA and Dallas, Texas based on the X and Y coordinates of that dot on the chart, and I can kind of recognize this, and this is how I get to the information. And additionally, there's also color here. The more red a dot is, the older the median age of the stores in this area, and the more green or blue it is, the younger the median age of the stores. So I can also tell that Walmart started somewhere in the south of the US. I can even find the specific area or the specific city, which is in Arkansas. And I can see that because the color gradually gets more orange and blue, that the Walmart stores gradually started. They started in one location, and then in a radius, they spread themselves throughout the US. And that's a lot of visual information and a lot of properties and a lot of things that have to be combined to tell us this insights that are both high-level summaries. On the East Coast, there's more Walmarts, but at the same time also can provide me very detailed information about Walmart was started in Arkansas, and then it gradually expanded throughout the South, and then went to the East Coast, and then to the West Coast. In order to make those more inclusive, we're going to have to think of several things. And one of them is we start by the visual. We're talking about data visualizations. It's a very visual practice. We have those colors, we have those shapes, we have those sizes, and we will have to make sure that those colors have enough contrast. Color contrast, you may have heard about it in the text sense, that interface colors and text colors need to have enough contrast with their backgrounds. In WCAG, it says text has to be 4.5/1 contrast. That's to make sure that everyone can read this. Here on this text, I have a lot of contrast, so even if the lighting here was bad and or the screen was bad, if you were in the back of the room, you would be able to read this as well. If I went for very light contrasts, you would probably maybe struggle a bit more as well. So ensuring enough contrast is not just for people with low vision to be able to understand your graphs. It also helps for people who are joining from devices with bad screens or joining from bad light conditions or, yeah. And for charts specifically, the color contrast is 3/1, and I will soon show you how you can test for this yourself. Graphical objects, so for example, bars on a bar chart, they need to have 3/1 contrast with their backgrounds. So in this case, this black dot has an 11.78/1 contrast with the background. But it also needs to have this contrast with adjacent elements. So in this case, the blue and the green, they do not have enough contrast. They only have 2.5/1. And the reason that this is important is because, for example, on a pie chart like this, if I am low vision and I cannot understand the contrast or see the contrast between both shapes, I cannot see the data, and I cannot see that 1/4 of this pie chart is dark blue and that 3/4 are another meaning. I can just see one color. So the more data points we add, the more we're going to have to start testing. In this case, with 2 colors, I will need to check, is the blue having enough contrast against the green? Is the green having enough contrast against the yellow background? And is the blue having enough contrast against the yellow background? Just adding 1 color means that I suddenly have to test 6 different colors. Is pink having enough contrast against blue? Is pink having enough contrast against green? Green against blue? And then all 3 of them against the background. So the more and more colors you add to your chart, the more and more colors you're going to have to compare to each other and find the balance between. And this is one of those areas where I feel like it's really advantageous to start early in the process thinking about accessibility, because if you think about it, if you have a chart with like 5 different colors and you already have to do a lot of color adjustments, if you push this to production and everyone is using this chart and the colors have been used throughout other charts, if now 2 years from now you have to come back to this and start fixing this, suddenly you're going to have to go back to colors that you as developers and designers, your users, your investors, branding, all have gotten used to, and you're going to have to start making small tweaks to those or even going for completely different colors. And it's going to be quite a bit of work to like collect all the different shades of red you have throughout your project, all the different shades of orange you have throughout your project, and try to align them in a way. Whereas if you do this at once, as soon as in the design process the designer sees that one color no longer has enough contrast against the rest, it might be only a 5-minute job to just slightly adjust the brightness of one of the colors and make it work. And what we can do for this is there are very handy tools for designers. If you're using Figma or Sketch, there are plugins like Stark or Able that you can use. For example, Able is one that I use a lot. You select 2 colors or 2 shapes that have a color in your Figma artboard, and the plugin is going to tell you the contrast ratio and whether this meets WCAG, large text, small text, or graphical shapes requirement. Similarly, if you are a developer or a tester, or in any way you don't have Figma and you just want to quickly check how your website is doing, there are automated tests like X, which is made by the Q, which is an automated accessibility tester. That one will pick up on color issues. And same, for example, if you're using Chrome, in the Lighthouse accessibility report, it will also pick up on color contrast issues. And for dataviz specifically, there's the dataviz contrast tool, which is recently made by someone from Schibsted. I think there's quite a bit of Finn people here as well. This one, following this, it's not necessarily going to make you WCAG 2.0 or 2.1 compliant, because it's based on a different algorithm of calculating color contrast that's supported in WCAG 3.0. So when you are trying to make your graph compliant to the law, you will have to do some extra checks for the WCAG 2.0 compliance. But what this thing does is it checks if colors have enough contrast and also takes the thickness of your lines into account, because it's in line on a chart will need more contrast than a big ass circle in the middle of a page. Related to color, and this is not something I'm going to talk a lot about, we have to also make sure that our color palettes are colorblind friendly. And the reason I'm not talking much about this is because when it comes to dataviz accessibility, I feel like it's one of the main and only things that have been out there information-wise for a very long time. When I got into dataviz accessibility in 2017, and I Googled how to make my charts accessible, the only thing that came up was don't use green and red as your color palette. So yeah, don't use green and red. And what can help you with this is, for example, the colorblind plugin for Figma, which when you use the plugin, it will take your artboard, copy it 8 times, and for different types of, and generate different types of color blindness. So show that for someone who has full color blindness on the bottom right, there's just black and white version. For someone who cannot see green or who cannot see red or who cannot see blue, it will look differently. And again, if you do this while you're designing a chart or while you're designing a website, it becomes easier and easier to adjust the colors while you're doing it compared to going back to your chart again months later. And if you want to test this in a website that's already live, you don't have to start picking those colors and recreating them in Figma. You can open, for example, Firefox Accessibility Tools, which has a little simulate button that simulates whichever web page you're on for different types of color blindness again. What did you say? Chrome has it too. Okay, great, haven't discovered it yet. Also related to color is to not just rely on color. So this can be, for example, adding patterns or shapes to give meaning to data and not just green and red, but for example, a green circle means positive, a red square means negative, then there's also the circle and the square as different. And alternative formats, this can mean different things. This helps both when it comes to color contrast or when it comes to the way you will perceive elements, and also to make things more understandable for everyone. For example, here, the charts that showed the generations of, or the simulations of whether Biden or Trump was going to win in 2020. There were also like lots of data points on a scatter plot, but the data was available there in text format. Biden is favored to win the election. It was there in number formats. 89 out of 100 simulations, Biden won. And it was there in like a very visual format, a lot of dots next to Biden's face and very few dots next to Trump's face. So the data itself is explained in different levels of complexity and with different ways. Someone who doesn't speak English will maybe be able to understand what this is about by seeing that there's a big face of Biden with a lot of dots next to his face. If you find it, for example, difficult to understand the numbers, you can still read the actual text, Biden is favored to win the elections. If you are a more visual person who wants to see things in a 2D, 3D space, then all the dots will give you the information as well. Like there's a lot of different ways of accessing this. And similarly, there's the red and the blue, which is very well known as Republican and Democrat colors. It's also explained in a legend and explained with text on top of the dots and a picture on top of the dots. So both the explanation of the color and the data is in this chart visualized in many different ways. And a bit more detached of that is using tables as a backup to visualizations. We did say we want to add visualizations to make data more understandable and to summarize big sets of data in a way that we can maybe at a glance get insights from it. But data tables do give a very detailed and objective view into the data. If I want to know, for example, in the chart we saw earlier of the US, how many stores there are, or a big cluster of stores, which location is this? For me, who's from outside the US, I would have to Google a map of the US at the same time to compare which different cities are on which different places. Whereas in a table format, I would be able to say, okay, now take me to the biggest dots. Okay, that's in Los Angeles, California, and know the location. And now we get to the fun part, which is making sure that everyone, including blind people using the page with a screen reader, can get access to the data. For those who don't know, screen readers, they base themselves on the information that's available on the DOM. A screen reader is a piece of assistive technology, and the only way it will know what to actually announce is if we as developers give them that information. Typically, this is based on, for example, if you have a button, then those elements will let the screen reader know, hey, this is a button. And the screen reader, in this case, I'm using VoiceOver, will even tell the screen reader user automatically in their own system language, this is a button, and in order to click it, these are the specific screen reader controls that you can use. This is not something you as a developer have to think about. As long as you use the button element, the screen reader user will be able to click the button and will be told in every way possible that this is a button. Similarly, if we use the H1, H2, H3 heading tags, those give structure to our page, also for screen reader users who can pull up this very useful heading menu and get an overview of the page and the content of the page, similar to how we might visually scan a page for headlines. And then they can choose one of those headlines and automatically navigate to that part of the page. Now, when it comes to dataviz, for those who have created data visualizations, SVG elements, they don't carry much semantic meaning. They're just, as you see there, for example, a path that has been given a fill and a lot of coordinates. A screen reader, first of all, does not know how to access those elements, but it will also not know what to actually tell the user. Like, it cannot tell the user, here are the coordinates of the shape. It needs to do something with it, and that's again where we as developers come into play. And one option is to turn the entire viz into an image with alt text, to put a role image and an area label with the description of what's visible in the image on just the top of the SVG. Then the entire chart will be an image. And in this case, the screen reader will say, this is an image, 53% of orders included drinks and ice cream, 47% of orders were for ice cream only. And this is again something where automated tests can check whether or not the image roles have an alt text associated with it, but they cannot test the quality. If I, for example, post a picture and I ask, is this a photograph? Is this a bird? Is it a European herring gull? Or is it an adult herring gull looking straight at the camera with a stern look on her face? Automated test will be able to check that this alt text is there, but it will not be able to tell me if this alt text is useful for the user. That's again something where like developers and designers and testers will have to collaborate. Another option is what the graph in the start of the presentation started doing, and it's to make those individual data points into elements that are accessible by a screen reader. So, for example, a list or a table is something that has semantic meaning, and that can also be used as a tool of grouping elements or sorting elements or communicating this type of information.
NVDA, line 106 with 6 data points. This is the most used screen reader in 2019. Region 1. December 2010, 34.8%. NVDA, image. 2. May 2012, 43%. NVDA, image. 3. January 2014, 51.2%. NVDA, image.
So this is a chart made with HiCharts, which is a Norwegian company that makes data visualization libraries, and those also have really good accessibility support options. So in this case, the screen reader has understood that this entire line is one category of data, has some high-level information about it, and then the user can choose to go into detail through all of those steps. This is again something that will require manual testing, accessibility reviews, user tests. This is a place where it's very good to get a user in front of your chart and get them to interact with it. And again, tables, they're always a really good alternative to have, even if you do all of those other steps, because first of all, they give this objective view into the data, but they also are very recognizable. A screen reader user, whichever table they land on, wherever on the web, if it's coded as a table, they will have the same controls to navigate vertically and horizontally and get all the information. Then this should not be confused with keyboard accessibility, because screen reader users do use keyboards, but they also have their own commands. I'm not going to talk that much about keyboard accessibility, but what we need to know there is that designers can help a lot documenting this. If, for example, you want your chart to be filterable and people to be able to navigate through each and every single data point and then click on them with their space or enter bar, you will still need to tell the developers what kind of sorting of the data makes sense or what kind of grouping you would want people to navigate this through. And similar, again, when you test this, an automated check can't really tell you if this makes sense. This is something you yourself or with an accessibility tester or with users have to verify. And there's a whole lot more to think about. I would keep talking about this for 5 more hours if I was allowed. But my final tip is to not get too focused on the viz part in dataviz. It's very easy to talk about, oh, we're making data visualizations. It's a visual practice. Now we have this bar chart or we have this map with all those data points. How are we going to translate this back into a screen reader experience? Instead, I want us to also focus on the data itself, because the visualization is just a way of communicating the data. So this is like a map about the locations and opening years of Walmart. It's not a map with hexagons of variable sizes and colors. That's just the way we chose to visualize this data. So I want us to think about what are we trying to communicate? What type of values does our data have, or what kind of units is it? What kind of trends do we want the user to look for? How will people interact with this and in which context? And that makes us realize that accessibility is about much more than just compliance. It's about designing an experience, and it's about designing an inclusive experience. And in order to reach that, it needs to be part of the entire process. What I often see is whatever the development process is, like research, design, prototype, develop, test, or any variation of that, people do this. Then they wait a while and they're like, hey, we maybe have to think about accessibility. And sometimes this is at once, very often, this is many years later. But the issue is that the longer you wait saying, hey, let's make our shit accessible, the harder it's going to be and the more expensive it's going to be, because the more accessibility will be ingrained in your company habits, your company culture. If you're not used to testing, it's very hard to get started. And it's what makes accessibility a really big and expensive job. So instead, I want everyone to think, hey, let's make this accessible, and how can we let this influence our process? Like, what do we have to think about when researching our users? What do we have to design for? What do we have to document when handing this over to the developers? What do we want to include in user tests? What can developers test themselves? What can designers test themselves? For what do we need external help? For what do we need internal help? And when we do all of that, then accessibility is a really good tool for making us think. We have to think about the content when making data viz accessible. We have to think about the structure of our graphs, and we have to think about the functionality of it and how people will interact. And that's how prioritizing accessibility will lead to better visualizations. But we also need to remember we're doing it because it's the right thing to do. Thank you. And if there's any questions, I'll be either available in the break or on Mastodon or my website.
Thank you. And break is the right keyword. We have a break now. See you in 10-ish minutes. Oh, you have a fan club. Nice. Yeah. Okay. So 2 more minutes. Yes, I get it. All right. We're doing mostly good over here with moving into the middle, like that. The right side is so-so. So, yeah, I think we will get started, and hopefully the rest files then in a little bit silently. Enjoy. Yes.
Hello. How many of you have seen this thing before? Oh, so many people. That's so good. That means we're approximately the same generation, I think. I've always been so curious how you can actually make games for this thing. This tiny games console was such a big part of my childhood, and I don't even have any clue how many hours I've actually spent with this one and the one that came before it. Of course, back then, I was not a developer. I was just a child, and I didn't really think that much about how someone might actually make games for it. But these days, though, things are a bit different. I'm an adult now, and I have some more years behind me as a developer, but I've never really been a full-time hardware programmer. Of course, I did some low-level programming courses in university, and I did love that. But most of my time has been spent building things for the web. So how can someone like me, not very experienced with hardware, but with a lot of passion for both retro games and programming, get started coding for the Game Boy Advance? Well, that's hopefully what we're going to find out about today. But first, my name is Benedicte, and I am a full-stack developer, and I work at Koul, which is my own consultancy that I started 2 years ago. And we are mostly developer consultants who not only are passionate about code and programming, but also enjoy being leads. And other than that, my main interests are gaming, and these are some of my favorite games. And the gaming interest is kind of what got us here today. So let's get started. So this is the Game Boy Advance. Why is it called the Advance, you might ask? Well, that's because it's even more advanced than its predecessor, the Game Boy Color, which again came after the original Game Boy. And even though none of these are actually the first portable games console ever made, they're still kind of considered the console that popularized portable gaming. But now, as I briefly mentioned at the beginning, I am no expert in hardware programming, and there are too few hours in the day for me to learn all the details about absolutely everything for this talk. And I will also quite purposefully simplify a lot of the concepts so it's easier to follow, and we can get through more in a quicker time. So before you come after me on Mastodon, keep that in mind. So my journey started out with a simple Google search, how to code games for the Game Boy Advance. And that led me on to quite a lot of good resources and sites online. And after doing some research, I kind of ended up with 3 possible methods that I could choose going into this. First of all, I could code everything by hand in assembly. Assembly is sort of the native programming language of the CPU chip itself. Another option would be to code everything in C, sort of like a bit higher level language, and use a special compiler to compile it to assembly code. And this compiler would be made for the Game Boy and for this purpose. Or I could use something called GB Studio, which is basically a drag and drop editor for making games on the Game Boy. And all of these kind of have pros and cons. Hand coding everything in assembly is what they used to do back in the days. But considering what those projects actually look like, I kind of threw that away. On the other hand, GB Studio is a very nice piece of software, and since it's mostly drag and drop, it means that you can get started very quickly. But since it's such a refined editor, it also means you'll give up some of the control over what kinds of things you can make. Maybe you'll lose some performance or frame rate, and I would be coding a lot less, which for me actually is a con. So what I landed on was the middle way, using C and a special suite of tools called DevKit Pro, which includes this special compiler that we can use to compile C into assembly code for the Game Boy CPU. So in order to demo this and show you all how we can go from some C code to something that actually shows up on the Game Boy screen, I drew this amazing piece of pixel art. So let's set up our environment so we can actually put this onto the screen. So the first thing we have to do is install this DevKit Pro package, which comes with all of our tools, but they package this in a nice installer for the Mac. So you can download it and double-click it, and you get this folder of scripts that does things. You don't really need to think so much about this. And it will kind of look like any other GCC compiler if you know what that is. And we can also use any editor that we want. Most of the things I'll be showing you, by the way, I learned from a very good in-depth guide on the internet, or I don't know if guide is the right word, it's more like a book. It's called Tonk. It'll take you through everything from start to end about this device and to develop for it. And it'll even show you an in-depth technical information about the device and give you a ton of coding example. So the person behind this has also made a very handy library that we'll be using a lot to simplify stuff. So if you ever want to get started with this, this is where I recommend you to go first. So with an empty project, we create some directories. We take the PNG that I drew earlier and put it in the graphics folder. We also create a directory called source, where our code is going to be, and we create a new file called game.c. And this will be our main entry point to our game. And as is customary in C development, we create a main method, which returns 0 when it reaches the end. And we insert an infinite loop, just so the game won't exit if we ever reach the end of that function. Now, instead of running npm build or relying on Gradle to build things, we need a script which kind of does all our compiling and converts it to something that we can play. Since this is C, we'll be using a makefile, which is one of the ways of building things in C. And kind of think about it as a package JSON, but there's a lot of history and things you can do with it, so don't quote me on that. And for the sake of brevity, we'll just copy a makefile from the internet, because we don't have to do everything by hand. And if we head to the terminal and run make, which is what calls our makefile, we end up with a nice ROM file with a Game Boy icon, and we can open that in any Game Boy emulator. But it doesn't really look that good. But I mean, that's because we haven't really done anything yet. And you see also the frame rate at the top is all over the place. And we're not actually using the device correctly. If we had a contract with Nintendo when this thing was like in the market, they would tell us that we need to set this device into the right video mode. And there are different kinds of video modes. Some are meant for cutscenes and some are meant for gameplay, and they kind of change a bit how the device works and how we're supposed to use it. In addition, we should add something called a vsync to the top of the main loop, and the vsync will kind of make sure that we don't change data while the display is doing other things, because if we do, then we get like split in half images and it doesn't look any good. Okay, so we add those things, we compile and we run the ROM again, and now the screen is black, which is a very much better starting point. And now all we need to do is put our PNG on the screen. And let me show you the code before I actually explain it. And don't be frightened. It looks like a lot, but we didn't actually add that much. But we do some important things. So the first thing we do is we import the raw pixel data of the image that I drew. And right here, I've actually cheated a bit, because behind the scenes, I'm using another utility called Grit, which is a tool that converts a PNG image into a C file with the image as 2 data arrays. One array of the colors, so like every unique color in the image, and one array of each pixel in the image with a pointer to the other array of which color it's supposed to be. And the reason why we do it like this is that the Game Boy doesn't really have a concept of image files. I mean, arguably, data could be anything. It's just a set of bits. But what I mean is that we can't just include a PNG image with our code and load it directly on the device. It has to be converted into kind of raw numbers that the Game Boy can understand. But thankfully, we have a lot of great tools that does this for us, so we don't really need to worry that much about it. The next thing we do is we take those arrays, the palette and the pixel data, and we copy them into specific places in the memory of the Game Boy Advance. And I postponed it as far as I could, but at this point we actually have to do it. I'm sorry, but it is interesting, so stay with me. We have to talk about memory. So in your day-to-day, especially if you're a modern web dev, you don't really think about memory that much. JavaScript handles everything in the background for you, unless you do like super exotic WebAssembly stuff or something along those lines. When you go to the backend, maybe you think a bit more about it. Java has a garbage collector, Postgres has a vacuum thing, and you have to worry about the server or the pod having enough memory and all that. But it's always more like an upper limit. When you get to C and C++, you actually have to think more actively about it. You have to allocate a place for things in memory when you store stuff, and you have to work with it and remember it. And remember to remove it when you don't use it anymore. That's a reason for a lot of bugs. But at the level we're at now, kind of one step even deeper, you not only have to think about allocating space for things, you also have to think about exactly where in the memory everything is. Indexes pointing to specific places in the memory suddenly becomes super important. Because if you put things in the wrong place, maybe suddenly you override an important bit controlling which mode you're in so that everything after that is just garbage. But memory in itself isn't that complicated. So imagine that this array is the memory of the Game Boy. Each element can only be 1 or 0. In other words, a bit. And we have a certain amount of bits or max amounts of elements in this array. And that's what memory is. It's sort of a semi-permanent-ish way to store numerical values. And in reality, of course, this array is a lot longer. When we say the device has 32 kilobytes of memory, what we mean is that this array has room for approximately 32,000 numbers. Okay, so the way we draw things to the screen in our video mode is by splitting our image into 8x8 pixel tiles. And this is what the Grit utility does. After it's done that, we copy them to a specific place in the memory. And this is a screenshot from a tool that comes with the emulator, and it will show you the current state of the memory of the device. And there you see that the image doesn't look happy at all. It's like divided up and impossible to read. But this is what the Game Boy understands. We also take the color palette and we copy it to a completely different area in the video memory. And this is that same utility showing the palettes. So we're sort of making all the image available to use for the device, but we're not yet using it for anything. If we'd compile and run the program now, we'd still get a black screen. So the way we actually use this data and display it on screen is to create yet another set of bits, sort of like a control object. And the control object has information about which tiles we want and how many of them in the sequence we want, the position on the screen, and which palette to use. And this is how we control the hardware. It's called memory mapped hardware. So we control the things that are soldered onto the Game Boy by putting things in a specific sequence in the right place in memory. And the cool thing now is that we can move sprites around without touching the image data. So instead of moving large amounts of data around whenever we change anything, if we have to actually change the image every time, we only change one like data, that is the coordinate of where it is. And I tried to illustrate this by drawing a map. This is kind of how I picture it in my mind, sort of like a grid, and you have specific places for stuff, and then you kind of have coordinates to those places. So let's compile the code and see what happens. There it is. But there's one thing that every game needs, and that's letting us interact with things. So let's just take a quick look at, we still have some time, at how we can move this logo around with the buttons. So exactly like we previously set bits in memory, which made the hardware do things, at the same time, the hardware is also setting other bits in memory that we can read. So kind of like the reverse. So there's a bit somewhere in memory that represents the state of the buttons. And in order to use it in our code, we simply read what that bit is for a given button at a given time. And like this. And here I also changed the X and Y components of the control object for our sprite. I don't touch the image data at all. But we do need one more line, and the reason for that is a bit technical. We work on a copy of the memory at any given time, because if we want to change more things at the same time, we want to make sure that everything updates at the same time. So yeah, let's not mind that. Now, if we compile and run, we see that, yay, it moves. Which it was so fun when I first got this working. I was like, oh, all the theory, it makes sense now. So running this on an emulator on your PC is cool and all that, but wouldn't it be so much cooler if we actually managed to run it on physical hardware? And I actually have two Game Boys with me here today, and one original Game Boy Advance SP with like the, I don't know where the stream camera is, it's over there, with the flippy screen. And I have one device that's kind of from the Game Boy Resurgence thing that's on YouTube now, where people are making new hardware for kind of doing the same thing, so you get a nice screen and stuff. But how do we actually get games over to it? Well, they have to be on a cartridge, because that's what the Game Boy does. They look like this. And you can buy these cartridge flashing stations and empty cartridges, and you can put data on them, and that's what we call flashing. Yep. These are also a good way to get other people's games onto your device, by the way, and there's a very lively community online on it with people who make absolutely fantastic games, so go there, and they're free, and you can just download them. But the thing is, when you're doing development, at least I feel it's a lot of hassle to like flash the cartridge every time you want to test out new stuff. So I'm so happy that this thing exists. They're called EverDrives, and they're basically like a cartridge. You put an SD card in it, and you can put the SD card in your PC and just put the ROMs on it. And I've actually already put our little game here onto this cartridge. So let's see if it works. If we have some minutes. We have some minutes. See if this works. Can you all see me? Yeah. Good. So I have to power it on first. And this is actually an original Game Boy Advance SP that I've modded with a new screen, just so it's a bit easier to see. And now the game is booting. And whoa, there it is. And whoa! And this is actually a consequence of how the hardware works. It's not something I implemented. But I don't know how many of you think about overflows and stuff, but if you increment the numbers too much, you kind of get around to where you started. So that's fun. Anyway, that was everything I had. Thank you so much for having me again. And you can find me on LinkedIn and Mastodon and stuff, but please don't come after me for saying something wrong.
What's your high score in that game?
Oh, in the game we just made?
Yes.
Infinity.
Ooh. We will have a world championship next year.
Wait, am I ruining stuff? There we go.
Hello? Yeah. Det vann der. Hello. Welcome to Data Spaghetti to Data Buffet with DBT at NAV, where I will talk about how we rewrote a monthly data pipeline from Informatica Power Center to DBT. My name is Caroline Winther. I'm a senior data engineer at NAV since 2020. And I've been a professional data practitioner since 2012, where I've worked both as a power market analyst and I worked in the processing team of the 2018 New Zealand census. So what is DBT? It's basically a tool that lets you write modular code to transform and create objects in your database using SQL and Python. And it comes in two versions. It's DBT Core, which is the free version, and then it's DBT Cloud, which is a paid version, which has some extra functionality that I don't know that much about because we have DBT Core at NAV. So you can basically download it, and it comes with a CLI, a command line interface, and you can write DBT in it, your project, and it will initialize your project, set up your database adapter, and it will also set up this folder structure for you. You don't need all the folders. Basically, in the models folder, that's where you will put all your SQL code. And it comes with a couple of examples, actually, when you set it up this way, and you can just write dbt run or dbt test. And there's a lot of commands you can write. And I will show a little bit more details later. First, I'll just tell you a little bit about NAV. It's Norway's Welfare Association. We serve around half the population every year, and we handle around a third of the national budget. And my team, I work in the data warehouse, and my team works with the work-related benefits, and we make data that goes into the official statistics. So the work-related benefits are dagpenger, arbeidsavklaringspenger, tiltakspenger, and tilleggsstønader. I'm not going to translate those. But we are also required by law to provide statistics to the people about how many people, where they live, who are they. And for example, this is an example of the data that my team makes, and it's the number of people who receive arbeidsavklaringspenger per month. So my team, we have inherited a lot of data pipelines that some consultants built a long time ago, and they're written in Informatica Power Center, which is a graphical drag and drop tool. And that's all fine, mostly because it was running every month without problems. But in March 2023, we got a request to rerun every month between 2010 and 2020, and that's 120 months. This is not, I mean, you would think this was an easy task to do. I mean, the reason why they wanted us to rerun it was because there was an error in the original code that included people who also had an etterbetaling, like a post payment, and they were not supposed to be counted in the statistics. But they were, and they had been post-processing and trying to remove them, but they actually wanted the data to be good, which is fair enough. But for my team, because the Informatica Power Center workflow consisted of a lot of mappings and sessions, and for our team, our expert in this tool had just quit, or he'd left the team, but he did send us a list of 13 steps that you could do to rerun 1 month. So 120 months with 13 manual steps, and I calculated this would take one developer around 8 weeks just to do this task. So not only is it really boring and you don't learn anything, but also it's quite risky to do this. It involved like opening parameter files and changing it to the current month and then rerunning a workflow from the middle of the workflow because you didn't want to overwrite that parameter file. And yeah, really tedious. So we decided instead to rewrite the whole run in code. This would give us more control and ownership of the workflow, and it would be easier to change things for the future as well. So to understand how the current workflow was made, we dug a little bit in Confluence, and we found this document, which is from a meeting almost exactly 14 years ago, which is called NAV DVH AP Statistikk overlevering til forvaltning, which is basically a meeting where the consultants met with some IT people, and it was kind of the handover of, now we've built what you wanted, here you go. And actually it's fun to click through the slides, because it's also like, this we didn't get around to do, so good luck. Yeah, so this is what Informatica Power Center looks like. And 34 of those sessions consisted of the monthly run that we wanted to redo. So we had to, first we had to understand what the different mappings and transformations did. So this is part one of the spaghetti. Sorry to continue the food analogy, food and data analogy from this morning for the people who were here, but sorry, not sorry, it's a good analogy. So you don't have to read all the little writings, but it's a lot of work actually to make this document, because you have to click around, and sometimes the documentation was on the workflow level, sometimes there was some documentation in Confluence, sometimes not. Sometimes you had to click around into like this specific transformations, and you click through the tabs and there's a little bit of an explanation of what's happening. But even after doing this, we weren't really ready to rewrite it, because the thing that was made 14 years ago isn't necessarily what's needed today. So we also tried to do a little bit of mapping out who uses the data and what's actually needed. So this is the part 2 of the spaghetti. Yeah, so it turns out our data was used for a lot of things, and a lot of the data were not actually used. So we could have a go at rewriting the workflow. And we started out with Python and SQL because those were tools that we knew how to use. And it was so nice to start working in code. We could rerun things. We could run all the months in a loop, so you didn't have to like manually sit there and click. There was still a little bit of annoying things, like you would write documentation and then it would immediately be out of date because you added a column or you changed the names of things. And in the meantime, we had some colleagues at NAV who started using DBT, and it looked quite cool. And DBT is basically SQL and Python, so it was really easy to just put it into the DBT structure. And you can just press DBT run, and it would actually do all the months at the same time. So you get data lineage. This is just a part of the data lineage, which is made from the code. So it's always correct, always up to date, and you can click around it. You can write dbt docs generate, and it will generate a set of HTML files that you can host for everyone enough to see how your data pipeline is built up, to see what the columns mean, and you can click on them and see what's in there, how it's made. So this is the buffet. So here's a little bit more details about what DBT looks like. So you have the models folder, which is where you put your actual SQL code. And DBT has like a lot of documentation about how you should do things, what's a good idea. Like obviously all the projects are different, but they recommend dividing up your models in staging, intermediate, and marts. Staging is basically the source near data, and then the intermediate is where you do like your joins and your heavy work, and then the marts is what you actually share to the users. So here's just an example of an intermediate model where you can probably recognize this as SQL code. So you reference your source data or your stage data. Stage faxdønad is our source data, and the curly brackets is like DBT templating syntax. So you reference another model, and this is also how it makes your data lineage for you. And you can make macros if you need to. So we have this macro that looks at what environment you're in, if you're in dev or prod. And yeah, so you write, this is a common table expression, a CTE in SQL. So and then you just aggregate, you see who's had a payment each month, and you get the latest row, so you can count how many people receive money each month. It's not that complicated, but this is a little bit simplified, and there are a lot of models because you have to pull in a lot of sources and do a lot of lookups. But we run it every month in Airflow, and it takes 34 minutes. So this, I would say, is a pretty big improvement from 8 weeks. So we're pretty happy about that. And it's been running for maybe half a year now, and we've been running both models or pipelines in parallel, but actually last week we finally turned off all the 34 sessions in Informatica Power Center. So that was really nice. Yay! So another thing in data engineering or data warehousing is how to handle changes in your source data over time. So for example, you have your source system and it has a vedtak ID, like an ID of your case and a status and a date when it's updated, or timestamp. And the next day, or this is the 1st of October, the 2nd of October, the status has gone from pending to approved, and it's overwritten in your source system. But obviously, NAV needs to know how long was the status pending. And obviously, this is a fictitious example because NAV is not known for having such short processing times. We're working on it. In your data warehouse, this could look something like this on the 1st of October. You have a valid from and a valid to, and you just set a really big valid to date. And then on the 2nd of October, you add a row with a new status, and you update the previous row with the valid to. And this way you know the status every day, and you know how long the status has been pending. In Informatica Power Center, this operation could look something like this, where you have a router transformation, which looks at your data. So you have also an MD5 hash expression, where you check, is this a new row? Then you insert it. If it's an updated row, you have to both do an insert of the new row, and you have to update the previous row with the new high valid to date. So this is pretty complicated, and you have to do a lot of clicking around. And in DBT, you have a snapshots folder, and this is actually not been simplified, this file. This is how you would write it in DBT. You write a snapshot, where you basically configure your snapshot to say what's the unique key. You can have a timestamp strategy. It's the kind of the common way, or you can have like just, if you want to check just a few columns, there's another strategy. And you say what the date column is, and your target schema, and the table that you want to check. So that's basically it, and you run it every day, and it works really well. So this is my last slide. I don't think I have to convince you guys that code-based is better than the click-based tools. But there is still a little bit of work to do at NAV. But the reasons why it's better, there are many reasons that you can. My team is now able to change things. We can add columns. We can change the names of things. It's all on GitHub. The documentation automatically updates. It's so easy to figure out how things are calculated. You can just search instead of having to click around to find out what workflow, what transformation. And you have also tests. I didn't talk about tests, but you can write your tests in your data. You can check your not null and uniqueness and a lot of things. And we should also not gloss over the whole developer experience. It's been talked about before today. But I think it's really important, because how is NAV going to attract data engineers and also retain data engineers if the tools that we have are hard to work with? So yeah, thank you for listening.
Thank you. I guess this is also how you get time to speak at conferences, if you don't do it manually. Right, Kate. you some water.
Oops.
Your microphone should be on already.
Yeah, yeah, cool. Thank you very much. Okay, cool. Hello, everyone. I'm Kate Kuzmina, and today I will share with you how to build a data application and a little bit about growth mindset. So we will continue data talks. A bit about myself. I'm a senior consultant on the cloud and data team at Experis. I've been working for 5 years in the data field, and before I spent 7 years researching neuropsychology of language processing in humans. And the common line through my whole career was basically that I love data, and I love extracting value and knowledge from data in different ways. So let's dive into the project that inspired this session. We had a project with the Climate Research Institute, CICERA, where they built an application that allows customers, like for example municipalities, to create CO2 emission scenarios based on potential mitigation policies or scenarios. So for example, if there is a new policy that politicians introduce that reduces CO2, they want to see how they show how it influences CO2 emissions. And the solution for that was basically an Excel file, a massive Excel file with, I counted, 90 tabs, a lot of data, a lot of plots, and a lot of calculations. And they sent this file manually to each customer. Even if this Excel file is perfect and fantastically structured, it's still probably not the most user-friendly solution, because it's maybe a bit too much to expect from people to interact with an Excel file. And also, it's very time-consuming for researchers to send it manually. So instead, they want to do research. So we, together with CICERA, we built a new solution that was a cloud-hosted web application where customers can log in and they can see the data in nice dashboards, interactive dashboards. So basically, customers are self-served, and that's great. So let me just show you how this app looks. I'm running it locally now. So we can see that there are several pages, so we can just jump between them. And we can see that they have plots. We have some toggles that we can interact with. We can choose specific lines if you want. So there is a lot. And we can look at separate sectors. We can also now understand that I did some good stuff with accessibility, because you can also take a look at the table. And you can also interact with the table a little bit. And there is like other page that shows you other graphs that are also interactive and nice. And again, the same structure, tables, graphs. And then you have filters in the sidebar, and you can just do different things. And then filters will be applied to all graphs on the page. And there are many different variables. So now you probably understand why the Excel file was so massive, because there were data for each aggregation for each variable. So it's many combinations. So what is cool about this, that we separate actually visualization, we separate user experience from the data. Nice, and now let's just dive into how to build such an app. So there are 3 main steps. The first one is just to build it locally using Python and Streamlit. The second one is to containerize it with Docker, and then we host it in AWS using different AWS services. And we will go through each step. So
I think many of you know what Streamlit is, but I will still introduce it. It's a very nice tool. I absolutely love it. It's an open source framework in Python that allows you to very, very quickly, very simply build interactive, nice data web applications. It's very simple. It combines front-end and back-end in one file, and you don't need anything between front-end and back-end. So, for example, you can see the project structure of the app. There are two of the most important things. It's main.py and the folder views. So main.py defines the order of pages in the app that we saw, and in the views, each file corresponds to a specific page that we also saw in the application. Everything is in Python, and if you want to make your project a bit better, of course, you can have as many as you want Python files where you put helper functions, and you can just import whatever functions you want into your Streamlit files, like utils.py or something. You can also have a configuration toml file where you can define colors or formats or some kind of appearance things for your application. So if you have a project with a structure, Streamlit will understand how to render your application. Super simple. Basically, you install it as a normal Python package, and then it has very many front-end components that you can use. You basically saw them already, like tabs, warnings, everything. And you don't need to be a software engineer to basically build an application. So you just use st-alias, and that's it. And to run the app, it's, again, you just run streamlit run main.py, the name of your initial file, and Streamlit opens in your browser automatically. And also, it's good to know that when you make changes in the file, they're immediately shown in your local application. So it's very easy to debug, and it's very easy to develop very fast. I actually didn't, I think I didn't show it. So you can also, we also added login. So you can, for example, we can log out, and then we can log in. So we can put our username and password and login. This is a very powerful feature that is actually super easy to implement. We can use the AWS service called Cognito that is responsible for user authentication, and we can use Python package that integrates Cognito with Streamlit, Streamlit Cognito Auth. So you can just go to AWS, to Cognito service, you create so-called user pool. It's just where you define users who can have access to the application. And then you get 3 environmental variables. You will just see them. And then you just fetch these variables, put it in your environmental file, and fill this class with these variables. And that's basically it. So that's all code you need to have nice user authentication element. And then if you want to add a new user, you just go to this pool in AWS, you add an email of a new user, and they get an email notification that and temporary password automatically. And then they're pushed to change the password once they entered for the first time. So super powerful feature, super easy to implement. And so once we are satisfied with our local application, we can containerize it with Docker. Again, quite simple. We just create Docker file within our project with a typical Docker structure, and we also add requirements file where we put all Python packages that are needed to run this application. That's it. So now we can build our image of our application, and now we can continue to the cloud. So we have a nice app running locally. We want it to run in the internet, so everyone has access to it. So first step, and it's quite a simple process. The first step is to push our image to the service called Elastic Container Registry. It's a service in AWS. You just go there, and you will even find all the commands that you need to run in your terminal to push the image. So they will be pre-filled. Now you see like placeholders, but they will be pre-filled. So you just go into AWS, you build your image, you tag your image, and you push your image. And then you would see it here. So you can check timestamp that it's the image that was pushed just recently, and the image would have a special URI. Cool. So we have our image in AWS, and now we need to launch our app. So we want it to run. And there are 4 kind of main components that you need to configure. Again, with ClickOps, it's very simple. So almost everything is happening within the service called Elastic Container Service. So you just find it in AWS. And the first thing is to create a cluster. A cluster provides infrastructure to run and scale our app. And since I am not infra person, I decided that I don't want to deal with infrastructure. I just want everything to happen automatically. And this is why in the infrastructure section, I am choosing serverless option. And the service is called Fargate. So it allows you to run a containerized application without dealing with infrastructure at all. So everything happens automatically on the infrastructure side. That's basically it. After that, we need to create a task definition. It's basically a recipe on how to run our container and what to actually run, what container and what image. Again, not many things you will need to kind of choose. First, we choose, again, serverless infrastructure, and then we need to define operation system and architecture. And here, you need to make sure that architecture you choose actually corresponds to what you used when you built the image locally. And if something doesn't work, that's actually often the problem, that wrong architecture is chosen. And then you just define specific resources that you need for your app, CPU and memory. And then you also define container that you use, and this is where you put this URI from the image that you pushed to the registry. That's basically it. We are done. And then there is a third component. You need to create a load balancer that distributes incoming traffic to your application. And for this part, there are basically 3 components that you need to set up. It's security groups, listeners, and target groups. So security groups, they serve as a guard and protector for our application. This is where you can define what kind of IPs can access your application or range of IPs. You can define what type of data can be exchanged between your application and users, and what ports can be accessible to specific users or specific ranges of IPs. And then listeners, so this is where we define what protocol we use for the data exchange. And at this moment, we can choose only HTTP, and it's not encrypted, it's not secure, but we will make it secure later. So we just need one more step to make it secure. At this point, it's okay. And then the target group is basically a set of resources that your load balancer puts, transfers traffic to. In our case, it would be a task running our application. And again, you will have all these fields where you can just click and choose. And and then the last part is to create a service. So service runs and maintains a specific number of copies of your application. So it makes sure that your app runs without any problems, and if any tasks failed, it will restart them. So again, here we need to choose the infrastructure, and we chose serverless, and we choose number of tasks, number of copies. In this case, it was just 1. It means that if our task fails, it will be automatically repaired. So we don't need to worry about it. And also our application is actually, there are not so many users, so we don't need so much to put here. And also we set up networking, or we put what we already set up before here. So security groups and the application load balancer that we made at the previous step. So at this point, we are basically good to go, and we will get this link in the load balancer that basically anyone in the world can access our application following this link. if we share this link, of course. So you can see that it's HTTP, that is not perfect, and the link doesn't look very nice, so it would be better to have a nice domain name. And actually, you can get it from a service called Route 53. So I just checked yesterday, katekuzmina.com, and this domain name is available, and I can get it for 14 American dollars per year. So let's say I decided to go for it, and you can choose other domain name. You will get a notification on your email that this is your domain name. Great, you got it, and then you need to connect your application to this domain name. And you can do it again in Route 53 by creating a so-called DNS record to link your new domain name with the, in our case, load balancer. Cool. And the last step is we don't like HTTP. We want a secured protocol, so we want it to be HTTPS. And again, super simple. You can get a certificate, SSL certificate from the service called Certificate Manager. So you just go there and you just get it. You request it, you get it, and then you need to add it to Route 53. And also you need to change your listener in the load balancer that we set up a little bit, because now it should listen to encrypted HTTPS traffic, and everything that goes to HTTP should be redirected to HTTPS. So these are the changes that we need to make. And yeah, that's basically all you need to do to have an application running and available for everyone. So for example, this is our production application. So you can see that we bought this domain for this project, and we have this HTTPS protocol, and so we can share it with clients, customers, and they can log in and see their data in a secure way. Cool. So that's actually it about the application and how to make it. But what about the growth mindset? Well, it's a belief that our abilities are never fixed, and we can always grow and learn. And it makes perfect sense because brain changes during our whole life. Neuroplasticity is a thing. So yeah, I don't think anyone can argue against this. And it's good to keep in mind. And I think in this project there are several examples of growth mindset in action. The first is, I'm a data person, but data people can also do cloud, they can do infrastructure if they want. And yeah, I think whoever we are, we shouldn't be fixated in it. We should expand our comfort zone and just enjoy it, because our brain allows us to do it. And second thing, it's really cool to see that research institutes cooperate with IT industry, and we get great results. So researchers can actually do what they want and need to do, real research. And also for the future of this project, of course, to exercise growth mindset, it would be great to switch from the ClickOps journey that I just showed to you to infrastructure as a code journey. Yeah, thank you very much. That's it for me.
Thank you so much. Now there's a break, 15 minutes break. All right, find your seats, please. Let's give it 1 minute. Do you want a time reminder or do you use your phone?
I have
Yes, your microphone works.
Yes.
Okay, I think then we can start. Enjoy.
Yeah, thank you. Hi, everyone. Good afternoon. First off, a huge shout out to the organizers, Marcus, and everyone else as well. And all the incredible speakers who've come before me. It's been an amazing event. It's my first time ever speaking at AdaCon, so I'm really excited. Learned a lot, very insightful talk, so I genuinely hope that you find something valuable in next 20 minutes as well. I know it's post-lunch, that afternoon slump is kicking in, so I thought I'll start with this visual to jolt you out of that post-lunch lull. I absolutely love this picture. I think it beautifully captures that chaotic energy that all of us developers have experienced from time to time. I mean, imagine the inside of that battlefield, the cries, the chaos, you feeling that everything is on the line. Well, that's how we felt sometimes when we were dealing with unruly business rules. And you might see more such visuals later on in the presentation, but rest assured, our story has a brighter and a happier ending, unlike the infamous finale of this web series. And that gets to my next slide, which is my talk. How did we embrace chaos at Post & Bring? And how Kotlin multi-platform has been our ally in this journey. Before we proceed further, I'm Anshika. I'm a programmer. I have 12 years of industry experience, of which the past decade has been with Post & Bring, developing and software which enables millions of people like you and I and thousands of businesses in and around Nordic to receive and send packages. And I stand here on behalf of an extremely talented team at Post & Bring. I would have loved the entire team to share the stage with me because it's been a team effort through and through. Okay, let's just straight dive into the problem statement here. Complex world of logistics. I've not put Post & Bring there because I realized over the years that it's not a Post & Bring problem alone. I think logistics, like any other industry, is inherently complex. And to give you some context, I think you might have used Post & you see it every day around you, you might have heard of it. Some of you might have grown up with it, and rightly so. We're almost 380 years old. We'll be in few years. It's one of the oldest organizations in the country, maybe even in the world. And of course, the software hasn't been around for that many years, but it's been around for decades, and it's been worked on by a lot of different developers. So we can call it generational software. And that brings me to my next slide. That's the complexity that we were dealing because of this generational software. So we started with the monolith, where we had all the business rules centralized in that monolith. Over the last decade, that monolith has been decomposed or broken down into multiple different apps. So what you see here on the screen is basically front-end apps, back-end apps, and everything in between. And you see the problem now, that X is representative of a business rule. And don't get me wrong, we are absolutely reaping the benefits of not having to deal with that monolith. But there is a catch here. We didn't have any absolute source of truth for our business rules. And I think I can safely say for everyone else that that person there has been all of us, sifting through millions of lines of code, trying to understand and make sense of what is in front of you. I mean, 60 to 70% of a developer's time is spent understanding code and making a mental map in your head. And that was our biggest challenge here. And also, there were some business consequences of not having a handle on our rules. If I demonstrate an example, we deliver dangerous goods, and then we have something called flexible delivery, which is basically, hey, I am not home, put it on my sidewalk, throw it in the backyard, so on and so forth. Now, these two services don't go hand in hand. But if, for some reason, this is misinterpreted or not implemented correctly, well, you'll end up with explosives on your sidewalk. Not that we deliver explosives, as far as I know. But you get the drift. And apart from business consequences, there was another price attached to this chaos, and that was just discontentment amongst the team members who had to deal with this code base. Everything is mentioned there: developer frustration, increased likelihood of bugs, and just high cost of developing any new feature in this code base. So what were we chasing? I hope Lord of the Rings fan in the room would appreciate that visual. That was it. I can't say we wanted duplication to go take a vacation. I'm rhyming now. And also, like, yeah, just having higher confidence in our code changes. But at the crux of it all, we wanted to have one code base to run them all. Exactly like One Ring, but not to yield like evil power, but just to have some semblance of control over our business rules. So what we did is, in 2019, we started plucking out business rules which were duplicated in all these apps locally, and we started dumping them in a Kotlin library, which was spitting out a JVM artifact, which we then used as a dependency in all the backend apps. So then at least that person heaved a sigh of relief in 2019, because then they had some semblance of control, at least for the backend APIs. And we enjoyed the benefits for a couple of years, but in 2021, we realized, hey, we didn't have any handle on our front ends, because we need to validate everything in front ends as well. And we wanted somehow to use this library that we had created 2 years back to also do validation for our front end. And that's a nice segue into the talk. That's multi-platform. Now, before we see how we achieved that, we need to take a little detour. No deep dives, because I don't have time for that, and it's a huge subject matter. But I'll give you enough information to, if you're not aware of this technology or have not heard of it before, you'll have a foundational understanding, and it'll also help you correlate to the code snippets that I'll share later in the presentation. So let's start with basics. What is Kotlin multi-platform? This is a watered-down definition by our team. It's an open source technology which was developed by JetBrains and announced in Kotlin Conf in 2017. So it's been around for 7 years. Simply put, it lets developers like you and I to write and share common code across different platforms. As simple as that. Let's unpack this a bit more, talk about what platforms are these, what are the most common use cases, and some technical jargon. If you talk to someone about Kotlin multi-platform, this would help if you know what these mean. So these are the platforms supported. We have the server side, which is what we are using it for. Then we have the mobile platforms, iOS and Android, desktop, and web, JS and WASM. It's a huge list. So the next question is, now you know where all you can run that code, but what do you share? And that is a $1 million question. And I think that is where Kotlin multi-platform really differs from its contemporaries, and it really shines, because it's the flexibility for me. It's not a zero-sum choice. It's not a binary. It doesn't require you to commit to a full-scale migration. You can start really small. All of us know those pesky constants that we have duplicated in all the apps. Well, you can start there. You can just rip that out and put it in Kotlin multi-platform library. And like it says, it's not all or nothing decision with this. Now, most common use case, unfortunately, our use case is not the most common use case that this technology is being used for in 2024. And the reason for that is, the most common use case is for mobile platforms. And the reason for that is that Kotlin, even though it's a server-side is seeing a steady increase as a server-side language in the recent years, but it's still predominantly used in Android development. So I think JetBrains just shifted focus in 2021 to just focus on these. But it's working fabulously well for us as well. Now, even if I'm not an iOS or Android developer, but I am well versed with all these different layers, and even though I'm a web app developer. Data core is basically you fetching data from either a database or an external service. Business domain is what I've been going on and on about in the last 5 minutes. UI presentation is you just clicking through different views. Now, imagine without Kotlin multi-platform, you had to have 3 different repositories. And you had, just imagine the amount of duplication and overhead in maintaining 3 different code bases, which are exactly doing the same thing but running on different platforms. With Kotlin multi-platform, you can, in principle, have one code base where you share all the 3 layers. And a disclaimer, more is not necessarily good here. So you do you. Like I said, you are not required to share all the layers. You can just share 1/10 of one layer. But you can do it with Kotlin multi-platform. But you see here that the only thing that you'd still need to write natively is UIs. So you need to use Swift UI for iOS, Jetpack Compose for Android, and so on and so forth. That comes to the next part, which is called Compose multi-platform. So I've added this because this, I feel, is a very ambitious project by JetBrains, where they've taken Jetpack Compose. Jetpack Compose, for people who are not Android developers, is just Kotlin. You write UIs in Kotlin in a declarative approach, as simple as that. So what JetBrains has done is it's taken Jetpack Compose and built this framework on top of it, which in theory would allow you to write your UIs in Kotlin for all the different platforms. So in principle, you can just have one code base which would run on every platform, and the only thing left would be platform-specific logic, which for obvious reasons you cannot have in the common module. But it's still an experimental stage. Now, a little bit of technical jargon. Modules, well, naturally your eye would be drawn to that shared module there. It's basically a project structure of a common KMP library. I'm just going to use the short form because we don't have time. So you have common main. You generally have common main, that's the common module. And then you have, depending on what platforms you're building the app for, you'll have those platforms. In my example, you see iOS and JVM. Now, common main or common module basically has code which is common to all platforms. Then one would say, why do we need platform-specific module? Because when you're building that app, there are certain tasks, there are certain operations which require you to talk to platform-specific APIs. And Kotlin compiler, by principle, will not allow you to write code which is platform-specific in the common module. So that's why we have the platform-specific modules. And you can achieve that by a very good mechanism they've introduced called expect actual. And I can explain that with an example. So suppose you've built an app and you want to display the operating system, the app of the platform that the app is running on. So what you do here is, in common module, you will declare the platform agnostic function by adding that expect keyword. And the actual implementation of this function, you can put in the platform-specific modules by adding that actual keyword there. And you see, we are talking to iOS-specific APIs and Android-specific APIs to fetch that operating system out. Then we have something called targets. This is a developer telling the Kotlin compiler by writing this DSL in the Gradle build script. You just say that these are the targets that I want the common code to compile to. And at the end, when you compile the whole library, you get these executables. For JVM, for Java, you'll get JVM class files or JS files or native executables for iOS and Android. This, for Java developers, the analogy here would be your POM file or your Gradle file. This is basically all the modules that I talked about. You need dependencies to compile that code. And source set is just a keyword that you put that, okay, for JVM common module, these are the dependencies. Like if you see this would resonate, you just put a JUnit dependency here to write test cases for JVM test. So this is just a POM. It just has a fancy name here. And I want to wrap this deep dive on steroids by putting this visual out. All of this is from JetBrains' official website. I would highly encourage all of you to go read the case studies. Some of the leading industry players are using it for a couple of years and with a lot of success. And that is like seeing those names there, the apps that we use daily gave us some confidence back in 2021 to dabble with it. And that's when also it just took off. Another visual that I have there, which I really liked, was which layer is the most commonly shared. This is from JetBrains, and that is the data validation and serialization. So which tells us that this is, again, not a post and bring problem. It is prevalent in the industry. So read those case studies. You might find your use case there as well. Platforms, you can just select you want to develop your app for, the platforms you want to develop it for, and boom, you just get a project structure out of the box. You don't need to worry about how to build this. It does it. The wizard or the template does it for you. And this is our project structure. So all, you see the common main. So now hopefully that theory would help correlate with this code snippet. You see the common main there. That's where all our business rules, like we dump our business rules in. So that is where, like you see country rules, product rules, tracking rules, all of those rules are dumped in there. And we have two platforms. Like I said, our team doesn't have any native apps, but Poston has a lot of native apps, and there are teams who are dabbling with both Compose multi-platform and Kotlin multi-platform for the apps that you use every single day for sporing and tracking. But our team doesn't own any native apps. So for us, it's for our front ends, that's JS main, JavaScript, and for our backend APIs, that's a JVM main. Let me explain what goes in those platform-specific modules with an example. Now, we have a lot of fun methods at work, but I chose a shipped by boat because why not? The rules aren't relevant. There are like a bunch of rules whether the shipment is allowed to be shipped by boat or not. But all those rules go in the common main. That goes in the common module. What you see here is we need these methods which are almost similar but slightly different in JVM main and JS main to expose that rule out to our backend and front-end APIs. Now, the difference that you see here is that the JVM main, because Java allows for more complex and strongly typed code, you'll see that we use country enum, but that might not fly that well with JavaScript. So then we extract the code out of the enum and then we pass it as a string. That's the difference between the two methods. Another thing, JVM static is not related to Kotlin multi-platform. It's just this code is written in Kotlin. So if you want to use this in a Java app, this just tells the compiler that this method could be called statically. But that JS export is related to Kotlin multi-platform. So JS export, that annotation basically tells Kotlin compiler, hey, this method, this class, this function needs to be compiled or built into the JavaScript library with all the TypeScript definitions and everything. So it acts as a bridge between Kotlin and JavaScript, that you can actually reuse this code in JavaScript. Plugins and task configuration. So now we have seen the code. This is how all this goes in Gradle build script. So you obviously need to put in a plugin for multi-platform. And like I said, there's a code there telling the Kotlin compiler, do not spit out native executables because we don't have any native apps. So we just want JVM and JS, and I'll show you how we tell the compiler to do that. And the other plugins that you see there, Maven and Dev Petuska, NPM publish, that's just for publishing these as library to Maven Central and NPM, just so that we can use these as dependencies in our front-end and back-end apps. Yeah, this is how we tell in the Gradle build script that this code that we have needs to be compiled. You need to spit out 2 artifacts, an npm artifact and a JVM artifact, and this is how we tell in the build script. Yeah, just to also summarize, so common main, all the rules are there, and then you add the JVM main and JS main, it spits out JVM artifact and npm artifact, and then we have a lot of test cases testing all these 3 modules in that library. Using this dependency like any other dependency that you use. You just add it in your POM, in your Gradle script, or in your package.json, like any other dependency. No fancy stuff happening there. How do you use it in your actual apps? Well, that's self-explanatory. You just statically call that method, and we are passing the enum. Front end, because of that JS export, now isShipByBoat acts as a normal JavaScript function that you can call in your front ends, and then pass the country code, the string that I mentioned in the definition. And one of the very good side effects of doing this, of course, we have that library which acts as a now rule engine to validate both our backend and front-end apps, but we also generate JSON and XML from this library, which acts as an input to our developer site. So our developer site used to have rules like what is the coverage area for that service? Is it from Norway to Sweden, or all of that? And there used to be a mismatch between what our APIs were saying and what the dev site was saying. And we used to get a lot of feedback on that. But now our developer site is actually live documentation. So if I change the max weight of a service, well, it reflects on the dev site as well. And our apps are validating the same thing. So yes, have we demystified X? Well, I would say a resounding yes. We have. It's no longer a wild goose chase. But is it all sunshine and unicorns and rainbows? No, it's not. This is my message on Slack last week to my product owner saying, hey, this service locally says the coverage area is XYZ, and from the common lib, it says something else. Why is this app still using the local rule, and what is the truth here? So as you can see, there is a bit of a trek left for us. But we are not wandering aimlessly now. We know where we want to get to. So yes, hopefully this short introduction to this concept inspires you to untangle your spaghetti if you have a similar use case in your project. Some last key ways, just start small. Like I said, just start with those constants. That's what we did. Iterate and improve, and just stay flexible. It might come across like that, but I'm not a spokesperson for JetBrains. Neither was this a sales pitch. We're not married to this tool, but it's worked out really well for us in the last few years. And we are running one of the most critical apps for Poston powered by this. So if it works for you, wonderful, but if it doesn't, there's always another way. Thank you for joining, and thank you for listening to me.
Thank you. A quick reminder to use the feedback form. We have 200 participants, 20 talks. That should be roughly around 4,000 opportunities to provide feedback. Right now we have 12. Yes. And especially for the speakers, give the other speakers feedback, because have a different insight. Let's plug it in. I hope it works. Can you say if it works to see if the microphone works?
Yes.
Yes, okay, it works.
All right. Just a moment. Yes. All right.
Do you want a timer?
Yes, or I'll just keep track here. Okay. Awesome. Yes, hi everyone. My name is Nora. I work at Vipps Mobile Pay, and a shout out to some of my coworkers are here today. So the systems that I'm talking about today, it was really a team effort maintaining them and making them. So there are a lot of people involved in these processes. And today I'm going to talk about beyond safety, how security can enhance developer experience. And I work as a developer myself and work on developing authentication systems in Vipps Mobile Pay. So these systems obviously have quite high security requirements because you use them to authenticate and send money and so on. So I'm really interested in the intersection between development and security. And I know people here have a bit different backgrounds and work with different things. So, but if any of you have been to any security conferences, you might have heard about this like kind of beef that sometimes happens between developers and security professionals. Yes, it's very fun and can get a bit dramatic. So I have some examples here. So what sometimes can happen is that because security teams, they work outside of development teams, developers might feel like, oh, they maybe come with requirements or lists of problems that might be less or more relevant. And developers are often measured on like how many features they can produce. So security teams might sometimes feel like, oh, the developers are not fixing the security problems quick enough. And we see some examples of this in the open source community. So before summer, this article came out where the developer of a popular open source package called IP, he got really upset because he got a CVE registered to his repository. CVE stands for Common Vulnerabilities and Exposures. So basically, some security researchers found a security problem with his package. But he was saying that what they found wasn't really so relevant because basically what they were saying was that his package wrongfully identified if an IP was public or private. And they rated this CVE as like 9.8 critical. So it was rated quite highly, and he said this was not quite fair. And if you want to read more about this, there is also an interesting article written by Daniel Stenberg, one of the maintainers of curl. So he wrote about that he also thinks the CVE system is a bit broken because curl got a CVE registered to it, also rated 9.8 critical. And what this CVE basically was saying was that if you abuse an integer overflow in curl, then you can make curl retry a bit quicker than it actually should have retried on a failed request. So again, Daniel was saying this is a bug for sure, but is it like a 9.8 critical CVE? Probably not. So what I want to talk about today is to show that actually security and development, they can enhance each other and have obviously many things in common. And I want to show some examples where I think that security enables developers and also show an example of how you can implement security features while still keeping a system quite quick and responsive so that security doesn't need to just make the system worse. And I'm going to mention two examples today because we have a bit short time. So I'm going to talk about JSON Web Tokens and how I think they can enhance developer experience in addition to be used for authentication. And then I'm going to talk about async first, which is a way in which we use to implement a security feature in a way that doesn't slow down a system and make it worse to use for users. Yes, so let's start with the JSON Web Token example. So I'm going to give the world's quickest intro to API security. So basically, if you have an API that you are hosting somewhere, then if you put no authentication on your API, then you basically have a URL that anyone in the world can go to and get data back from the API. So sometimes you want to add security to this and require that someone authenticates themselves in order to get data back. And you can add this security on different levels. You could just require someone to send the username and password, for example, to get the resources from the API. But one thing that is quite common to do is to require someone to send a JSON Web Token to be able to authenticate to the API. So some of you might have seen in DevTools that sometimes you send an authorization header where it says bearer, and then you have this long gibberish value, which is the token that you're sending to authenticate towards the API. And don't worry, this is not a real token from Vipps Mobile Pay. This is just it's a random image I found on, on Stack Overflow. So yes, the JSON Web Tokens, they look something like this. So this is an encoded token to the left here. And this token might look like very secure because it looks so gibberish and strange to understand, but actually it's just base 64 encoded, and anyone can decode it to get these values to the right, which is the payload inside of the token. So the most important thing to know for this presentation is that these tokens, they are cryptographically signed, and this means that nobody can change this information that you see to the right here inside the token without ruining the whole signature. So it's a security mechanism that ensures that the data you see to the right here hasn't been tampered with when it gets to your backend system. And in Vipps MobilePay, we have a system that hands out these tokens. So this is one of the systems that my team is maintaining. It's called Vinx. And the name Vinx, it comes from combining the word Sphinx with a V for Vipps. And the reason for this is because the Sphinx was like a protector of pyramids in Egyptian mythology, and our system Vinx is like the protector of all APIs in Vipps MobilePay. So you can't do anything in the app or call any other API without having a Vinx token to do other things in the app. So Vinx is the authentication system that hands out these tokens. And if you have logged into the Vipps app, you might have seen like 3 dots on the screen when you scan your Face ID, for example. And behind those 3 dots, it's Vinx working, checking if you are who you say you are. And if you manage to authenticate, you get a token. And the way this works is that, okay, like we said, a user logs in, they authenticate, Vinx sends them an access token, and then the user and the app, they can do other stuff in Vipps MobilePay as long as they send this token to the other APIs. And so JSON Web Tokens are used for authentication, but I also think they have some advantages for developers that go beyond just the authentication part. So one of these is that there is useful data stored in the token, and using tokens also allows you to do offline validation. Let me explain this a bit further. As I mentioned in the token slide where we show the encoded and decoded token, tokens have payload and data inside of them that you can guarantee to be correct and not tampered with as long as the signature pans out. To the right here, you see an example of a test token in Vipps MobilePay, and you have some data here. So these words might look a bit strange, but for example, you have MSISDN, which basically means phone number, where you can see the phone number of a user. You can see that they have different ID values, which says what kind of authentications they have used, and so on. So you have some information about the user inside of this token. And what this means is that if I'm a developer making a new system in Vipps MobilePay, so I'm going to make a completely new system, and I need some of this data, then I don't have to make a call to other systems to get this data. But if I need to use tokens anyway, then I can just fetch these values from the tokens themselves. And our system Vinx, the authentication system, hands out these tokens. But these tokens have a lot of values that don't just have to do with authentication. For example, the phone number value. So we could ask ourselves, well, if Vinx is going to give these tokens with this information, how does Vinx know what this information is? How does it fill the information inside the token? So what we do is, I'm going to show an example here. So here to the left, you have an OTP system. OTP stands for one-time PIN, and it is a system that sends out an SMS that a user uses to verify their phone. And to the right here, you have Vinx, the authentication system. So the way this works is that when a user has successfully verified that they own their phone, maybe some of you remember when you register to Vipps MobilePay, you actually get an SMS where you have to fill in the value to make an account and prove that you have access to your device. So this is the OTP system. So the OTP system is the one doing this work. And when a user has managed to prove that they own their device, the OTP system, it sends a call to Vinx and says, okay, a user has managed to prove that they own their phone. And Vinx says, okay, then I can add that value to the token. And the reason why we can trust this call from the OTP system is that this is a backend to backend call protected with Azure Entra authentication. So this is a way of making a secure channel, a backend to backend channel, where you can trust that if someone has been authenticated via Entra and has this role, then they can be allowed to set these values on the token. And I'm gonna go just check time quickly. Okay, I'm gonna try to hurry up. So JSON Web Tokens, they also allow you to do offline validation, which means you don't need to make additional calls between systems. So let's look at an example here. So here to the left, we have the app. We have the OTP system again, the one-time PIN system that sends out SMS messages. And then we have a user registration system to the right, which is used to keep track of all the activities that a user has to go through to make an account. And if you use a JSON Web Token approach here, then you can make a design like this. So a user has managed to prove that they own their device, and the OTP system says, okay, and sends a token to the app. Then the app can send this token to the user authentication system, and the user authentication system can just verify the token. It doesn't need to make any additional calls to check that this user has actually proven that they own their device. An alternative approach, if you were not using JSON Web Tokens, would be to make something like this. So this time, a user still manages to input the values from the SMS correctly, but they don't get the JSON Web Token from the OTP system. Instead, they get an authorization code, which is just like a value. And then when the app sends this authorization code to the user registration system, the user registration system can't just trust it. It needs to make an additional call back to OTP and ask, is this code really something you handed out? And then wait for a response back before moving on. So you have an additional online call in this part of the system here. And I think as a developer, if you need to work with authentication and validate tokens anyways, then they can simplify life for you in a way where you don't need to make these additional calls to other systems. And then I'm quickly going to talk about async first, which is a way in which we implemented a security feature without slowing down Wings too much. Because like I previously said, Wings is the authentication system that everyone needs to go through to do anything else. So it needs to be quite quick. It can't be like a very slow login system. And if something happens where Wings is down, then nothing works in the Vipps app. But still, we can't just allow anyone to log in. So we also have a blocking system, which is supposed to block users, and we shouldn't log in users that are not allowed to log in. And what you can do, so if you had an authentication system and I had to implement this blocking feature, how would you do this without disturbing the authentication system too much? So one way in which you could do it is in a synchronous way. So here we have the app, we have the authentication system, and we have the blocking system. And if you do things synchronously, then a user asks to log in. The authentication system needs to then ask the blocking system for every request, is it okay that this user logs in? And wait for a response back. And now this can cause some problems in very high traffic systems, because what you're doing now is that you're creating a dependency between the authentication system and the blocking system. So if the blocking system is down, the authentication system doesn't work. And another problem is that you have some extra time making this additional call to the blocking system, even though in reality this is not a very long time. But an alternative async first way of implementing this is that, okay, here we still have the app, we have the authentication system, we have the blocking system to the right here, but now we have also introduced a worker. And a worker, this is a system that just keeps working all the time in between. So this worker, it's always asking the blocking system, do we have any blocked users? And then the blocking system will respond with, yes, okay, this person is blocked. And then the worker will directly update the database of the authentication system. And what this means is that when someone logs in, instead of making an extra call to the blocking system every time, the login system can just check inside of its own database if this user is blocked or not and get a quick response back. So this is a way of decoupling the authentication system from the blocking system. And I thought this was a fun example of how you can implement a security feature such as blocking users in a way which doesn't slow down the system or couple the system so tightly together that it can cause problems. So my key takeaways here is that what I've seen with JSON Web Tokens and these type of things is that I think they can actually help developers in the long run to architecture simpler systems to use. And it is possible to have systems that are quick, but also adhere to security requirements and implement security features. And I also think that actually, when you have some limitations on a system, when you have some requirements such as security requirements, it can be a positive thing, because what you have to do then is to automate more and come up with better architectures to meet all of these requirements. And I think that can kind of lead to more efficient system and more innovation that comes from these limitations, instead of just slowing it down and making everything awful to use. Thank you so much. This was everything from me.
Thank you.
Okay. 5 p.m. slot. Are you guys still awake? I have to admit, I saw my slot and I was like, oh, that's rough. I very much appreciate everybody who's still here. We're kind of quite a few fewer than we were this morning, I see. So I appreciate you guys wanting to listen to me talk about board games. That's my talk. Why are board games the perfect way to learn a new programming language? As all good talks, I'm going to talk a bit about me first, because obviously I'm the most important thing about this talk. My name is Inger. I'm 37. I live in Oslo with my partner and all of our board games, obviously. I didn't start my professional life as a programmer. I actually have a master's degree in mechanical engineering. I spent quite a few years doing calculations of steel parts and their strength, and whether or not they could sustain whatever they were exposed to. Luckily, I did see the light in the end. I did understand that it was a backend developer I was supposed to be. So I did some single class courses, enkeltemner, at UiO, University of Oslo, and I managed to talk myself into a job at my current company. This company is called Noah Ignite. We're a consultancy firm here in Oslo. And this being a consultancy company and my CV being what it was, basically 7 years of mechanical engineering, it took a while for me to get a customer project to work on. And I realized really, really quickly that tutorials are really, really boring. They're so very boring. And also, they don't actually teach you all that much. So what are you to do? What are you to do when you want to learn something new and you have no idea how? Luckily, I have friends who are also developers, and lamenting my sorrow to a friend of mine, he was like, but I mean, that's easy. Just, you're a geek, do a board game. That's a perfect exercise. And I was like, okay, sure. But I was desperate and was like, this doesn't sound that promising, but how bad can it be? So that's what I did. So, and this is now 5 years ago, and I'm here today to hopefully convince all of you guys why board games are the perfect way to learn a new programming language. First of all, it's an actual thing. Like, it's a concrete thing with a set of rules that you can make. And I chose this really random, extremely magenta, now that I look at it in big size, image from Unsplash on purpose, because the point isn't really what kind of a thing it is, but that it is a thing. Because one of the main issues I find when learning a new programming language is to decide on what to create. Because you don't know the language, you don't know the limitations, you don't know where to start. So you get stuck, at least I do, I get stuck in this continuous loop of, okay, but if I make this, but does that actually fit my thing, like language I want to learn? Will I actually be able to learn something trying to do that, or will I just waste time? Whereas if you program a board game, you can just go, okay, I need to learn this new language, or I want to learn it. Which board games do I like? And what does it, like on this list of board games, what appeals to me right now to create? What's kind of tickling my fancy? For me, my absolute favorite board game of all time is called Pandemic. This was in the autumn of 2019. Little did I know how ironic this would be. Pandemic is a board game in which 2 to 4 players cooperate, trying to save the world from 4 different pandemics at the same time. Yes, it's an incredibly difficult board game. Yes, you do lose most of the times that you play this game. Different players have different roles, and the different roles have different abilities that help you win the game. The pandemics themselves are represented by colored cubes, 4 different colors, 4 different cube colors. There are 2 types of decks of cards, the infection deck that dictates how the disease spreads, and then the player deck that gives the players resources to travel around the world and create vaccines for these pandemics. Unless, of course, a local epidemic happens and everything goes to shit. My point is that a board game has a set of rules and components, and how they interact are already specified. It's already fully spec'd. I think every single developer I know hates specification meetings and poker plannings and Christmas and t-shirt, whatever you want to call it. It's the bane of our existence, right? We realize they're a necessity, but they're terrible. With programming a board game, you can just skip that step because you have the rule book. The rules are already written. The interactions between the components and the different types of rules and stuff that can happen in the board game is already decided, which means that you can spend all of your creative juices on deciding how to implement it, which is, after all, the fun part of programming, actually doing the thing. So it's all of the fun and none of the boring stuff. I also find that programming an actual board game teaches you how to solve actual problems using the language you want to learn. Tutorials in general, I find they're either too simple, they assume too much pre-knowledge, is that a word? You understand what I'm saying? Or they're way too specific. And also you end up like, you just follow steps, right? A tutorial is actually created for you to just follow a set of instructions and do all of the things and copy all of the lines and then paste them into your whatever. And it just works. And you don't actually learn, you just learn to follow instructions. Whereas if you have to program a board game, you will get bugs. You will have to bang your head against that brick wall of how the fuck do I solve this problem? How the hell do I implement this interaction between this thing that I programmed this way and this thing that I programmed this other way, and I did not think about this interaction. It actually forces you to think and create. And I think that's part of the value, at least for me as a developer. I get to learn new stuff all of the time. That's one of the reasons why I love being a developer. And programming board games allows you to do that instead of just watching boring tutorials. And you also get to start small. I believe with Pandemic, I started with the board itself, which is just a set of cities, and each city has a color and a name. Fairly simple, even for a tiny baby developer. That's, in most languages, that will be okay to implement. And then you can expand. You can expand the system, you can create players, you can create decks, you can create, like I said, Pandemic has 2 different decks of cards. So I got to implement inheritance, like I had an abstract class called deck, and then I had the infection deck, and I had a lot of fun with this, if you can't tell. In addition, board games as a programming problem are extremely adaptable. The rules are set, but how you implement them is very, very flexible. And I think most of us, when we want to learn a new language, yes, we want to learn new languages, but we all have stuff we want to learn, stuff we want to explore that we haven't gotten to explore yet. And with board games, it's quite easy to turn that board game application into an exercise for whatever you want to learn. You want to get better at microservices? Okay, then split your board game into tiny, ridiculously tiny components that have to talk to each other. And then you discover all of the problems with microservices. And like, yeah, exactly. You all know what I'm talking about. Do you want to learn GraphQL because you've only ever worked with REST APIs? Well, then make a game status class or whatever in your language and create an API that can request the status of the game. And voila, you have a GraphQL API that you can play around with. You want to learn cloud storage? Okay, pop some fake user data into a storage account. Mind the cost. I think most of us have gotten burned at some point. Do you want to get experience creating front-end applications? Well, make a web app for your board game. Like the possibilities are endless, and it's only your creativity that kind of sets the limit to what you can actually achieve using a board game. I remember I spent, I think, almost an entire day Googling how to shuffle a deck of cards programmatically. And spoiler alert, it's a lot more complex than you think it is. To actually get it random, I used something called, I think it's called the Knuth algorithm. Like, it has its own name. It's amazing. And it was fantastic. I also dream about programming a die using that lava lamp randomized thing they have. Is it in Australia? I can't remember. There's an API for a lava lamp randomizer, which is just fantastic. I love programming so much. And last but not least, I've been talking extremely fast because I thought I had not enough time. That's fun. It's fun. Tutorials are boring. I heard your groans. You all agree tutorials are boring, and we don't learn when we're not having fun. When you get to choose what you want to program yourself, be it a board game, a card game, whatever, something with set rules, choosing something that actually gives you energy makes you have much more fun, so you learn more, and it makes your stamina stronger, like you're able to keep going. I was on the bench, I believe it was like 5 months from I started my job till I actually got a customer project. That's rough if all you're doing is watching tutorials, right? So just do it, create a board game. Since I've been going through this at super speed, I'm gonna show you my pandemic, which is kind of terrifying because I did this 5 years ago, mind you. So please don't judge me too harshly for whatever is on the screen. I haven't looked at this in ages. Can anyone see anything? No. Well, I can't. Now I can see something. Okay. So this is my, I work in C#. I'm kind of a language agnostic. C# is the language I chose because that's what my company uses mostly. And here you can see, can I see? I should duplicate my screen. So here you have it in all its glory, the card I was talking about, an abstract class, just names and colors, and a constructor. If you're trying to play a card without actually having implemented the play, how that specific card is being played, an illegal move exception is thrown. And then you have a city card. They aren't playable, which is why it doesn't have a play implementation, or why it should throw an exception if you try to play it. And the infection card. This is how the disease spread. It's terrifying. And you can see that I've had to implement a method called infect because it infects a city with disease. And just this is what happens. I also have in the bottom, and I've done this for all of it, like roles, there are different roles. I have the cities hard-coded here somewhere. I wonder if I can find the shuffle thing. Here, Fisher-Yates Knuth Shuffle. I used the boring old randomizer of C# though, so I still have improvement possibilities for this thing. Removes at the specific place and adds somewhere else. I have a game manager here somewhere, there I believe, and this is what actually runs the game. I've hard-coded the users. Ragnar Rakkverk og Frida Frosk. Some people actually know who they are. That's funny. And it's just a while loop that tries to play the game until an exception is thrown. If you win the game, can I actually go there? You get the, oh my god, how did you do that? Congratulations, the world lives to die slowly by global warming instead. If you lose the game, which is the most common occurrence, you get, the world is dead. I'm so sorry, the world just died. Yeah. And this is just because this wasn't 100% of my job. I didn't do, I did other stuff as well. I have no front end for this, but I do have this beautiful console application, which also, imagine as a baby developer how much satisfaction this gave me, actually having a console app up and running and having an interface. Let's do this the introductory way, and then you get, I wrote this whole text of welcome to pandemic, this is what you can do, these are your players. The following cities are infected with disease. Like, this is useless in a console application. You actually need a front end to actually play the game. But it's still fun to see that it's there, that it updates appropriately, like that all of the elements actually work. So you have all of the moves you can do, and I can move my character from, let's say I want to use number 2, direct flight, which I can do by using the cards I have in my hand, which is down here. So I can either fly to Bogota, or I can use an airlift. So I can click 2, and I can apparently only airlift. That's interesting. I'm blaming the demo ghost for that one. But airlift allows me to move to any city I want to. So then I get a list of cities. I can use number 3. And voila, I'm in Lima, I believe I went to. Yeah. So that also part of the fun of programming a board game is that you get to do this. And this is a board game, like I said, it's my absolute favorite board game, so I know this really well. I've played Pandemic shit tons. So, but also, while developing, that was actually incredibly practical. Because I saw the bugs, I knew how to test. Like, you get rid of a lot of that uncertainty that you get when you're trying to learn a new language of just like, but is this a me problem or is this a language problem? Did I just misunderstand the rules or is this kind of like a finicky, weird thing about this specific language? And when you know the board game, it kind of helps a lot with that uncertainty and debugging and understanding what kind of bug you're dealing with and how to solve it. So I cannot recommend that enough. I'm going to close this down. And show you my last slide, which is this one. I have a QR code if you want to give me some feedback. I love feedback. If not, thank you so much for your attention. Any questions?
Yeah, we have time for questions. You can also take the questions outside. There's a break now until 5 after half, 7:35. See you later. Remembers the last bit. your hairs for me. Thank you. Hey, so I'm here for this talk. Like math, oh my God. Yeah, that's why I became a programmer. It's like, I don't have to understand it. I just let the computer do it. So let's go with the last talk of today. It was amazing. Okay, yeah, I will have a few words later.
Welcome to the final talk of the day. Algebra, you already know it. And I know, this was maybe not what you thought you wanted to listen to for the last 20 minutes separating you from dinner. That's okay. Bear with me. My name is Aurora Hofman. I work as a backend developer at NAV, but I also have a master's in physics and math. And for the time that I've been working, my experience is that a lot of developers get a little bit anxious when it comes to math. So my goal for the next 20 minutes is that when you leave here, you get a little bit less scared if you see or encounter a mathematical expression. I also want to show you that you actually use a lot of these concepts in your daily life as a programmer. So actually, it's not even new. You already know this kind of stuff. I am going to end with showing you something that you may not know. And I do this because I think that every time our brain hurts a little bit, it makes our possibility to learn something new a bit larger. And that is really relevant in our job. Okay, so today we are going to talk about sets, represented by this drum set. We are going to talk about functions, represented by this function wave. And we are going to end with groups. That's algebra. But let's start with sets. This is probably something that you all have a natural feeling of what it is. This is some Kotlin code where we see a set of fruits. And we can see that even though I put apple in my set twice, when I print my set, apple will only appear once. And that is because a set only consists of each value one time. So duplicates are ignored. Now, how would I represent this mathematically? Usually, when we represent sets in math, we use big capital letters. So for example, my set of fruits can be represented by a capital letter X. And if I have my set X, I can ask questions like, is an apple represented by a lowercase letter x, often with an index, an element, that's the E, of my big capital letter X, which represent my entire set of fruits? I can also ask, is an avocado represented by x2 an element of x? And here I say no, this is not an element. That's the E with the line through it. So this is just how I would abstract what fruit and apples and all these words are, and I can write it really, really compact. I can also decide to make a different set. For example, all fruits with leafy things on the stem. I represent this by a capital letter Y. And maybe I want to know if Y is a subset of X. So are the fruits with leafy things on the stem a part of the larger set of fruits? Now don't panic, okay? Everyone take a breathe so that we lower our stress levels. This is the mathematical definition of a subset. We're going to take it really, really slow. So we start to your left, and we say Y, so my fruits with leafy things on the stem, is a subset of X, all fruits, if and only if, that's the arrow going both ways, for every lowercase y, so for every fruit with a leafy thing on the stem, if that fruit is an element of all the fruits with leafy things on the stem, then that leafy fruit also has to be an element of all the fruits. If this holds, then you have a subset. All right? That's sets. Let's move on to functions. Again, this is a coding example. I start out with my set of fruits, and then I want to do stuff to it. So for example, here I apply a filter where I filter on the letter length more than 5. I can do a map, I can do a sort, I can do a join to string, and all of these actions are actually functions. All right? Let's focus on the filtering part. So what happens in my filter? I go from my set of all the fruits, I apply my function, and I end up with the set of only fruits with letter lengths longer than 5. All right? So I go from a set, my starting point, to a set, my endpoint. Now these have names. They are called my domain. That's where I start. That's where the input data lives. To my codomain. That's where the output data lives. Okay? And these spaces can sometimes be the same space. Also, my function can have properties. They can be, for example, injective, one-to-one. They can be surjective, onto, or they can be both, and then we call them bijective. I'm going to walk you through the examples. Let's start with injective, or one-to-one. Now we remember that we have our input space, our domain, and we go to our output space, the codomain. And in this example, both of these spaces is the set of integers, or natural numbers, and my function is 2 times x, okay? So my function is injective, or one-to-one, if there is only one value in my domain that maps to the same value in my codomain. So in this case, that means that only 3, for example, in my domain will map to 6 in my codomain. You don't have any other integer that would map to 6 if I times it with 2. However, as we see here, nothing will map to uneven numbers, because you can't do that when the function is 2 times x. So we can go one way, but some values don't really have something. And that brings us over to a surjective function, or onto. Now, if we change our spaces, so now our domain is the set of real numbers, and our codomain is the set of positive real numbers. And my function is x squared. Now in this case, we know that for every positive number, we can actually take the root, and we can come back to our original space. All right? But there are actually several values in our domain that map to the same point. All right? You're still with me? Great. If I want the possibility to move in circles, I need both of these properties. So another example, we go from the integer space to the integer space with the function x plus 2. Now I can start anywhere. I can, for example, start with 3. I can add 2, end up in 5, and I know that I can subtract 2 and get back. But I can also start in my codomain with 5, and I can subtract 2, end up with 3, and I can add 2 again and end up in the same space. So this is really cool. Okay, so this was sets and functions. This was our warm-up. Now let's move on to the firework, the last part, namely groups. And before I start now, a little note. Sets and functions is probably something that you use, like in some form or another. I'm going to talk to you now about group theory and what a group is, and it's probably not something that you're really going to use. Why am I talking to you about this? Kind of because I think it's fun, but also because I hope that this gives you a teeny tiny fundament to build on if you ever encounter a really complex problem. Because that's the cool thing about math. It has actually already solved a lot of our complex problems. And we can meet them when we actually program. For example, with optimization, or if we do geometrical stuff with 3D gaming things, we might need math. Okay, so what is a group? A group consists of a set and an operation. An operation is basically just a function. So we need a space where we do things, and we need to know what we want to do. And this set and this operation together has to fulfill 4 rules. Now these rules are called closure, associativity, identity element, and an inverse. I will go through them step by step. We start with closure. Okay, so if we have the set or the space of natural numbers, integers, closure means that if you do something to that set, now I choose my operation to be addition, so I take 2 elements and I add them together, I have to know that I am still inside my original space. So I can take 1 plus 1 or 10 plus 5, and I know that what I end up with is still a number, right? What would not be closure? Well, if I take natural numbers and division, then I could take 1, divide by 2, and I would end up with a half. But 1/2 is not an integer, so then the system breaks, right? Okay, associativity, the second rule. Associativity basically means that you can put brackets wherever you want. So if I can take 1 plus 2 and then add 3, and that's the same as taking 1 plus 2 plus 3, then I have associativity. And you know that you have it if you can write an expression without brackets. Then you're good. Okay, third rule, the identity element. The identity element means an element that doesn't change anything. It doesn't do anything. So with natural numbers and addition, this is 0. You can add 0 to any number, and it doesn't change anything at all. Cool, right? Final rule is the inverse. And now we come back to what we talked about with functions, right? Because the inverse means that for every element, you must have a different element that gives you the possibility to come back. So here I have 5, and then I add 1, and then I add -1, and I get back to where I started. So what we've seen here is that natural number with the operation of adding 2 numbers is a group. Maybe you're wondering what's not actually a group. Well, let's look at strings with the operation of adding. Now, can we add 2 strings together and end up with a string? Yeah, we can. We can glue them together and it's still a string, right? Now, if we look at this code line 20 to 22, we're checking for the second condition, associativity. Can we put brackets wherever we want? And we can see from the output code that we get hello, you are cool at every step of the way. So we can put brackets wherever we want and it doesn't change anything. So that's good too. Now we check for this third condition. Do we have an identity element? And with strings, actually we do. We can use the empty string. We can add an empty string and nothing really happens. So this is what you see again. We have hello, you are cool. But you can also see that I've commented out a line. Because what's up with the inverse? How do we kind of get back, remove a word, or something like that? If I try to run this code uncommented, it looks like this. because we don't really have a sense of minus cool or inverse coolness. It doesn't really exist. So here we see that strings with addition of two strings is not a group. So that's a bit sad, but usually it's okay. So what have we learned? We've learned about sets, and we learned that they can be represented with letters if we want to. We've learned a little bit about functions and domains and codomains, and that something can bring it from one place to another. And we've learned a little bit about groups. Now, what I want you to take away from today is that it doesn't have to be scary. Most of the time it can actually be explained, even though it's kind of really complicated algebra. So if you encounter a problem that is really, really, really hard, don't be intimidated to look up if there's actually a solution to your problem, because there could be, and I promise you, you can also understand it if you just take the time and have someone explain it to you in a calmly manner. Thank you so much for listening.
Thank you very much. Okay, yes, right there. Yes, that was AdaCon 2024. A big, yes, yes. I'm really blown away. This was amazing. Thanks for everybody who showed up today and in the weeks leading up to this conference to make it happen. Really fantastic. Yeah, I think we have to do this again next year, right? Okay. Let's go downstairs now. There will be there's food, so I think the best approach is we all gonna go outside and then try to find our way into the catacombs. Yeah, then we'll have something to eat and something to drink. Thank you all.